closer like snowflakes on a breeze. Scan your drives for safety and keep your holidays with ease. Silent nights online, hackers on the prowl. Keep your passwords tight, don't let your systems howl. Encrypted files safe, two factors quite a gift. Without it you're a target, your data might just drift.
Firewalls, guard your precious slate.
Hackers try to sneak inside, but they can't ruin your day.
Firewalls, keep the threats away.
Clicking links without a thought is Santa's big no way. Deck the halls with updates, patch your software right. Ignore that sketchy email, it's phishing in plain sight. Malware's creeping closer like snowflakes on a breeze. Scan your drives for safety and keep your holidays with ease. Silent nights online, hackers on the prowl. Keep your passwords tight, don't let your systems howl. Encrypted files safe, two factors quite a gift. Without it you're a target, your data might just drift.
Firewalls, guard your precious slate.
Hackers try to sneak inside, but they can't ruin your day.
Firewalls, keep the threats away.
Clicking links without a thought is Santa's big no way. Deck the halls with updates, patch your software right. Ignore that sketchy email, it's phishing in plain sight. Malware's creeping closer like snowflakes on a breeze. Scan your drives for safety and keep your holidays with ease. Silent nights online, hackers on the prowl. Keep your passwords tight, don't let your systems howl. Encrypted files safe, two factors quite a gift. Without it you're a target, your data might just drift.
Firewalls, guard your precious slate.
Hackers try to sneak inside, but they can't ruin your day.
Firewalls, keep the threats away.
Clicking links without a thought is Santa's big no way. Deck the halls with updates. like snowflakes on a breeze. Scan your drives for safety and keep your holidays with ease. Silent nights online, hackers on the prowl. Keep your passwords tight, don't let your systems howl. Encrypted files safe, two factors quite a gift. Without it you're a target, your data might just drift.
Firewalls, guard your precious slave.
Hackers try to sneak inside, but they can't ruin your day.
Firewalls, keep the threats away.
Clicking links without a thought is Santa's big no way. Deck the halls with updates, patch your software right. Ignore that sketchy email, it's phishing in plain sight. Malware's creeping closer like snowflakes on a breeze. Scan your drives for safety and keep your holidays with ease. Silent nights online, hackers on the prowl. Keep your passwords tight, don't let your systems howl. Encrypted files safe, two factors quite a gift. Without it you're a target, your data might just drift.
Firewalls, guard your precious slave.
Hackers try to sneak inside, but they can't ruin your day.
Firewalls, keep the threats away.
Clicking links without a thought is Santa's big no way. Deck the halls with updates, patch your software right. Ignore that sketchy email, it's phishing in plain sight. Malware's creeping closer like snowflakes on a breeze. Scan your drives for safety and keep your holidays with ease. Silent nights online, hackers on the prowl. Keep your passwords tight, don't let your systems howl. Encrypted files safe, two factors quite a gift. Without it you're a target, your data might just drift.
Firewalls, guard your precious slave.
Hackers try to sneak inside, but they can't ruin your day.
Firewalls, keep the threats away.
Clicking links without a thought is Santa's big no way. Deck the halls with updates, sight. Malware's creeping closer like snowflakes on a breeze. Scan your drives for safety and keep your holidays with ease. Silent nights online, hackers on the prowl. Keep your passwords tight, don't let your systems howl. Encrypted files safe, two factors quite a gift. Without it you're a target, your data might just drift.
Firewalls, guard your precious slave.
Hackers try to sneak inside, but they can't ruin your day.
Firewalls, keep the threats away.
Clicking links without a thought is Santa's big no way. Deck the halls with updates, patch your software right. Ignore that sketchy email, it's phishing in plain sight. Malware's creeping closer like snowflakes on a breeze. Scan your drives for safety and keep your holidays with ease. Silent nights online, hackers on the prowl. Keep your passwords tight, don't let your systems howl. Encrypted files safe, two factors quite a gift. Without it you're a target, your data might just drift.
Firewalls, guard your precious slave.
Hackers try to sneak inside, but they can't ruin your day.
Firewalls, keep the threats away.
Clicking links without a thought is Santa's big no way. Deck the halls with updates, patch your software right. Ignore that sketchy email, it's phishing in plain sight. Malware's creeping closer like snowflakes on a breeze. Scan your drives for safety and keep your holidays with ease. Silent nights online, hackers on the prowl. Keep your passwords tight, don't let your systems howl. Encrypted files safe, two factors quite a gift. Without it you're a target, your data might just drift.
Firewalls, guard your precious slave.
Hackers try to sneak inside, but they can't ruin your day.
Firewalls, keep the threats away.
Clicking links without a thought
Hey guys, welcome. Yeah, welcome to the stream. Within 8 minutes we will start. So I hope you all are looking forward to a great day. And yeah, I apologize, my microphone was turned off. But yeah, I hope you all will have a wonderful day. We start with the first talk uh, about Mac OS attacks. Yeah, you can see the countdown timer below. It's 8 minutes. Uh, and then we will follow up with the rest of the talks. And then we will finish with the last talk, which is 22.00 or 10 o'clock in the evening in Dutch time, Amsterdam time. Yeah, you see two links downstairs, there and there. If you want to join the Mystikcon Discord, you can check this one. And if you want to play the CTF, which is not really a CTF that we are hosting beside this, but more a CTF if you want to play, it has over 100 chats. It's up every single day of the year for multiple years. So if you want to play or learn some things, then you can do that one. Yeah, but for today we are mostly focusing on the talks, of course, because those are the hot topics. Yeah, so I hope you all will have a wonderful time. For those who are watching, if you are watching one or two talks, it's also fine, as long you are learning something, which is the most important thing of this conference. Yeah, we have been doing this for multiple years now. I think this will be the third or fourth time we are doing it. So yeah, I also want to thank, of course, all the speakers who put energy into this, who make great presentations, who make great talks, interesting talks and learningful talks. You can always hit those speakers up. They are always happy to help and to assist with any problems you are having or facing. Yeah, of course you can also always reach out to me too if you have any questions or want to join Mystikcon. We are active on Telegram and Discord, but more on Telegram. But we also have a Discord server. So yeah, if you want to join the Discord server, it's also fine. Yeah, I think I have nothing more to say for now. We have exactly 6 minutes. So I'm going to prepare the next speaker. Going to set up the connection and everything. And I hope to see you all within 5 minutes and 45 seconds. And again, I hope you all have a wonderful time. And yeah, for those who can stay the entire day, I wish you all a Merry Christmas and a Happy New Year in advance, of course. And for those who will stay till the end, which is amazing, I will say it again after the event. So yeah, stay and hope you all have a wonderful time and enjoy, and hope you all learn something new. So see you all in 5 minutes, and yeah, wait for it, and 10 seconds. Yes.
Silent nights online, hackers on the prowl. Keep your passwords tight, don't let your systems howl. Encrypted files safe, two factors quite a gift. Without it you're a target, your data might just drift.
Firewalls, guard your precious slave.
Hackers try to sneak inside, but they can't ruin your day.
Firewalls, keep the threats away.
Clicking links without a thought is Santa's big no way. Deck the halls with updates, patch your software right. Ignore that sketchy email, it's phishing in plain sight. Malware's creeping closer like snowflakes on a breeze. Scan your drives for safety and keep your holiday nights online, hackers on the prowl. Keep your passwords tight, don't let your systems howl. Encrypted files safe, two factors quite a gift. Without it, you're a target, your data might just drift.
Firewalls, guard your precious slave.
Hackers try to sneak inside, but they can't ruin your day.
Firewalls, keep the threats away.
Clicking links without a thought is Santa's big no way. Deck the halls with updates, patch your software right. Ignore that sketchy email, it's phishing in plain sight. Malware's creeping closer like snowflakes on a breeze. Scan your drives for safety and keep your holidays with ease. Silent nights online, hackers on the prowl. Keep your passwords tight, don't let your systems howl. Encrypted files safe, two factors quite a gift. Without it, you're a target, your data might just drift.
Firewalls, guard your precious slave.
Hackers try to sneak inside, but they can't ruin your day.
Firewalls, keep the threats away.
Clicking links without a thought is Santa's big no way. Deck the halls with updates, patch your software right. Ignore that sketchy email, it's phishing in plain sight. Malware's creeping closer like snowflakes on a breeze. Scan your drives for safety and keep your holidays with ease. Silent nights online, hackers on the prowl. Keep your passwords tight, don't let your systems howl. Encrypted files safe, two factors quite a gift. Without it, you're a target.
Hello everyone, welcome back. After 10 minutes of waiting, we are here with the first speaker of today. Well, you can see it on the screen, the anatomy of split APKs on Android, with Mono as the next speaker. So I don't want to hold you guys any longer and don't want to make your anxiety more anxious, if I say it correctly. So I give the word to Mono with his next talk, and I hope everyone has an amazing time.
Yeah. So, hello everyone. Myself, uh, Deepak Yadav. I also go by my alias, which is Monal, MON3L. A lot of people don't pronounce my alias properly, so here I go again. It's Monal. Okay. I am a cybersecurity enthusiast. Basically, from the last, uh, I would say 7 to 8 years, I've been into this cybersecurity domain. Uh, I do love to work a lot on web applications, API testings, uh, mobile applications, and today our topic also includes factor, one of the important concept of mobile application security testing. So I do love to work on all these areas, which you can also see on my screen. Network pen test is one of the thing which I like to do a lot. But when we talk about network pen testing, I'm not telling that I go ahead and use Nessus and all to scan the findings and perform the pen test. No, that is not the case. Uh, Morely towards the exploitation part is what I prefer to work on. Apart from that, AD, the client and clients, then cloud audit and pen test. When we talk about AD also, I am not a red teamer, I would say, because there are a lot of things which a red teamer should do. I'm not that technical, you can say. So mostly the audit part or the normal AD compromisation part, lateral movement, those are the things which I am more fond of, which I would love to do it, and I also do it. Okay. So the today's topic is all about the split APKs. When we talk about APKs, then definitely Android is one of the important thing which will gonna come into our picture. So the topic of our today's is known as anatomy of split APKs targeting Android applications. So why do we have split APKs? Why exactly does this split APK exist? Okay, before talking about that, do we have okay? There are different types of applications which I will talk about in a bit. So why do these split APKs exist? So there are basically the type of applications which we used to had in our past, like whenever a security tester or whenever a penetration tester goes ahead and tries to perform the application security assessment of any of the clients or any banks or any well-known organizations, especially targeting the mobile applications, Android. So the developer tends to give us a single APK file, and we have to install that APK file, and that application will be installed in our device, and we will have to proceed with our exploitation part or the testing part. That was the scenario which has been going on for a long till date. Till now, the same scenario has been going on. Now, why we have this split APKs? Because previously, when we used to receive the single APK file, that type of file is known as the monolithic applications. So basically, these are the single APK files which consist of the different following scenarios, different following things such as uh, there are different CPU architectures which are bundled inside a single APKs, which can be for ARM devices, which we use in our day-to-day life. When I say which we use in our day-to-day life, that means whatever the Android device, whatever mobile phone which we use, those are the ARM devices. Then we have x86, x86 underscore 64. So these all are some of the well-known virtualization architecture. When I talk about virtualization architecture, Genymotion and Android Studio is one of the name which pops up in my head. And these traditional APKs also consist of screen densities such as medium DPI to triple large HDPI, and all the different language options, all the different language resources are all pre-built inside the single APKs. So if everything is inside a single APK, what we will gonna get in the return? We will get large APK size, the download and the installation procedure of that APK will be little bit slower, and it will gonna not waste specifically, but it will gonna take a lot of storage of the devices on which it is going to be installed. It can be my actual Android device, or it can be my emulator, anything, right? So what is the solution? Like if I have to say that I am not at all interested in, as a developer, I'm not at all interested in creating a large APK size, and I don't want my application to have all the different CPU architectures in a single APK file. What is the solution? The solution, uh, Google is one of the well-known company. Everyone is aware of Google. Google came up with the solution, and they introduced the well-known scenarios known as split APKs and application bundles. So from here on, we will gonna start with our main topic. What are the exactly split APKs and how, as a security tester, we can perform testing on this split APKs. Before proceeding ahead, there are some of the key terminologies which we have to be familiar with, such as APK. APK is nothing but the Android packages. Then we have split APKs. These are the modular APK delivered based on the device configurations. Okay. Now, when we talk about device configurations, it means that if a developer wants to make the application for the testing purposes and he likes to use uh, Android Studio or Genymotion with x86_64 architecture. He doesn't want to go with ARM architecture. In that case, he can make several changes in the applications so that the application should be built for that specific device, and a lot more different things comes into the picture, which we're gonna later on look at. Then we have the base APKs. Base APKs are the core application logic. Then we have the configuration APKs, which will gonna include all of the device specific resources. It could be the images, SVG files, XML files, and a lot of different things. It can also include, not it can, but it also includes the native libraries. Whereas the base APK doesn't include our native libraries, it only includes our application's core logic functionalities. Then we have dynamic feature modules such as on-demand functionalities. Now, when I talk about dynamic features, a lot of people might have seen this scenario. Like, let's take an example of Instagram. Okay, so I installed Instagram in my mobile device, and I used it for a couple of weeks, for a couple of months. I didn't intentionally updated my Instagram applications, but later on, I noticed that the UI of my Instagram in my mobile phone suddenly got changed. So many features got updated, or so many new UI layouts I can see after a couple of usage or after a couple of days. But one thing kept ringing in my head, one thing kept going in circle in my head. That is, I didn't updated my Instagram application at all. Then how come my application, the Instagram application got updated? It was all because of the dynamic feature module. Okay. So whenever the developer intend to make changes in the UI, there can be two ways to do it. First, they can either push the update, and the end user, they can download that update directly from the Play Store. The second one will be that whatever UI changes the developer is thinking of to do the changes in the UIs. What developer will gonna do? They will gonna add all those different UI modules in a single update, so that once the user download that update later on, the Instagram developer, from sitting inside the company, they can simply make the changes, make the UI changes, and whatever UI changes required by the application, all those changes are already present in our device. Why? Because we have updated our applications. Okay. In a simple way, I can say that whatever the UI changes are required from the developer side, they will not gonna push the update, because they will simply give you a single update instead of giving you a multiple updates. They will give you a single update, and inside the single update, that update will gonna include all of my UI changes, all of my libraries, you can say, or all of my UI elements, and the developer can simply rearrange those UIs whenever they want. And this is how, without updating the applications, our UI gets updated automatically. How? Just by using one of the well-known feature known as dynamic feature module, which basically I don't want to pinpoint it directly, but it falls under split APK scenarios. Then we have the Android application bundle, short form AAB, double AB. This includes the publishing format for Play Store. What exactly it is, we will gonna look at. Now, the difference between APKs are normally AABs, Android application bundle, as well as the uh, split APKs. What are the difference between all these three topics, all these three different architectures? So APK, we all know these are the legacy APKs. We will get a single APK file. We can use it to, we can use that APK to install that application in our device. Correct. Then we got the split APKs. But before that, we have double AB, which is the publishing format. These type of files are not at all installable. As a developer, what I will gonna do, I will gonna upload this file. I will gonna create this file, and this file will going to be uploaded to the Play Store. And this AAB file is responsible to tell the Play Store that whatever application is being pushed by the developer onto their server, the user will gonna download that application, but that application should not behave as a legacy application after downloading. That application should behave as a split APKs. So the AAB plays the important role when we talk about the split APKs. Then last, we have the split APKs. This consists of different APK files, and these APKs are also meant for device specific. Like I said earlier, there are different types of CPU architectures. ARM devices are there, x86_64 devices are there. So that now it is completely up to the developer that they don't have to create a different file format for different CPU architectures. What they will gonna do? They will simply going to use the split APKs, and once the user from any different sort of CPU architecture, if they are using, let's say, multiple developers, multiple end users are using different CPU architectures. So now the developer will not gonna build the application for different CPUs. Instead, it will gonna use a single format. It will gonna convert that APK into a split APK using AAB. And now the Play Store plays the important role. Once the user goes ahead and tries to download the application from the Play Store, then the Play Store will gonna identify, detect the user's device, user's CPU, and after detecting that CPU architecture, uh, after detecting that CPU architecture, the Play Store will send that specific file to that device, because once the Play Store detects that the mobile device is ARM, then the Play Store will send the ARM-based application to be installed on the device. If the Play Store detects that the user is using emulator, specifically Genymotion, then it will going to send the x86 bit architecture file format to that user, and that type of file will going to be installed on his or her device. That is how our split APKs basically works. We will look at how exactly and what are the different things which are available over here. Okay, so here is the small diagram architecture. I'm not very much good with a diagram, so this is how I created in my Obsidian. So we will get the AAB, not we, but as a developer, I will build the AAB. I will push that to the Play Store. Now the Play Store will have the base APK, and this base APK will include different things such as configuration based APKs or feature based APKs and all. Okay. Now, when a developer pushes their application to the Play Store, it will be a single logical application. But once the user download that APK file, it will not gonna be remain as a single APK. It will gonna be converted into the multiple APK, commonly known as split APKs. Okay, let's quickly look at the different types of split APKs which we have. or the different file formats which we get when we talk about a split APKs. Okay. Now, the first type of file which we will get is known as base.apk. Okay. Now, what exactly is this base APK? This is one of the mandatory file format, one of the important files. Why? Because this base APKs consist of our application's core logic. If my application is not at all having any kind of logic, then how my application will gonna work? Correct. So base APK is important. It consists of uh, all the core concepts, all the logic concepts, all the common resources which are required. Android manifest file is also available in this base APK only. Then we have the configuration based APKs. These are specifically delivered based on the device characteristics, such as based on the device's CPU architecture. And this type of configuration APKs majorly consist of native libraries. Their extensions are known as .so files. Okay, and also when we talk about APKs, when we talk about configuration based APKs, these all are the types of split APKs. When a user downloads the application from the Play Store, they will gonna receive all these different APKs. Okay, then there are different things which falls under this configuration APKs, such as when we talk about the native libraries, then since the native libraries depends upon the CPU architecture, we might see some of the file names such as ARM64 underscore V8A or ARM EABI underscore V7A, or else we can also get different type of applications, different types of files such as 86, it should be small x 86 underscore 64. So these all are the different types of configuration based APKs which we will receive along with native libraries. If the application is using native libraries, then we will receive the SO files, shared object files. But if the application is not at all using native libraries, then we might see that the configuration APKs are based on specific CPU architectures. Okay. Configuration files also include images, different resources, SVG files, along with and its name and the name will be something like this: double X HDPI, or else the name can be something like this also. It could be triple X HDPI. Now, what exactly is this double X HDPI, triple X HDPI? These are my device's screen size. Okay. If I have to talk about Samsung S7 device, then its screen size would be S7 or S6, and compare it to Pixel 7 or compare it to Pixel Fold devices, Samsung Fold devices, their screen sizes will be different, right? So the configuration APKs do include that information as well inside this kind of file. So its name should be HD. Its name should consist of DPI. Okay. Now it is completely up to the device which we are holding in our hand. It could be Pixel Fold. It could be uh, Pixel 7, Pixel 6, Pixel 1. Okay. It can be anything. And configuration APKs also include strings.xml files. Okay, now usually when we talk about the traditional APK files, we used to decompile that application. We have to navigate to the XYZ location, and we will get the string.xml file, which will gonna have all the hard-coded informations, right? Now, when we talk about the split APKs, there is a very high possibility that we might not get to see these string.xml files. Instead, we might, I'm saying we might. Okay. Why? Because if the traditional application uses string.xml file for language conversion, then the same thing we will not going to be see in the split APKs. Why? Because split APKs are created in such a way that if my application is meant to be used for different locations, for different geographical locations, such as for England, there will be my application should have English language. For uh, Arabic nations, there should be Arabic language should be available in the application. For Indian region specifically, English and Hindi language should be there. So what developers can do, they, instead of using the string.xml file, they will gonna create different config files, and their name should be similar like config.en.apk. This will gonna include all the language translation to English. Config.hi.apk. This will gonna include all the language translation for Hindi language. Okay, these all are the different things which split APKs consist of. Then we have the third type of split APKs, or the third different types of split APKs inside a single file. Okay, this is quite confusing right now, but once we proceed with the practical part, it will all gonna make sense. So the third type is dynamic feature APKs. These all are the optional modules installed on demand. Let's take an example that I have the application, and it can be anything. It can be Amazon, it can be payment based Android application. What developers can do, if they are keen to make these split APKs, they can divide the applications into different APK files, such as one APK file will gonna have all the features to chat to different customers, or to chat to different users. Another APK file will gonna have a feature specifically meant for payment gateways. So in this way also, developers can bifurcate, split a single APK file into a different feature based applications. Okay, so once we decompile, I would not say decompile, once we extract the installed application from the Play Store, like for example, if I downloaded the application from the Play Store directly on my Android device, it can be either emulator, it can be my physical device. So once I downloaded that application, now, as a security tester, I have to do the static analysis of that application. How will I be able to extract that installed APK file from my Android device or emulator? Correct. We can do that easily. So once that application downloaded into the device, we will, from the Play Store, we will get different types of files over here, like base APKs. Then we will get split underscore config for my specific architecture, device architecture. Then this third file, split underscore config dot double x hdpi dot apk. This will tell me more about my uh, Android device or Android emulators screen size, dimensity. Then we have split underscore config.en. This specifically tells me that the application only has the English language available. Then if the developer has created split APKs for different features, then we will get to see that files as well. Okay, now the important part is all these different five APK files belongs to a single application, and all these different APK files should be signed with a single certificate, and all those different APK files should share the same package name. If the package name is different, then my application will not gonna work properly, or I would say that specific feature, that specific section will not gonna work properly for my application. Okay, so here is my Android emulator. I will bring it over here. So just now I was doing before the talk, I was doing different activities. So let's target our well-known Netflix and Crunchyroll application. So all these two applications, I have installed it in my emulator via Play Store. So as a tester, I want to perform the static analysis of this application. So how, from where I will get the APK file? Let's have a look from where we can get that. So I'll start my terminal. Let me go to desktop. I will create a file. Hmm, what should I name? Mystico underscore 2025 talk Mystico 2025. Okay, I want this. All right. Now, uh, I will use ADB shell. And important thing, my current emulator is not at all rooted. So if I go ahead and try to use the command su, I will get the option inaccessible or not found. Let's try sudo su. Again, same problem. What if I enter adb root? I will get this message saying ADBD cannot run as root in production. This specifically gives me the information that my emulator is not at all rooted. So right now, if I have to extract all these APK files from a non-rooted Android device or non-rooted Android emulator, how we can do it? The procedure is quite simple. So let's have a look. I will have to gain the CLI access of the device by ADB, or we can also use browser if the person is more familiar or more comfortable with browser. They can go ahead and do that. Go ahead and use that. I'll use ADB for now. My next command will be pm list packages, and I will get the different applications which are installed in my Android device, their package name. I am more interested in Crunchyroll and Netflix. So in that sense, I will grep the Netflix package name, FLIX Netflix, and this is my package name for Netflix. Let's open our notepad. This is my package name for Netflix. And what about our Crunchyroll? Crunchyroll. This is my Crunchyroll package name. Okay, so let me go there. Yeah. Now I will have to list the exact location where my EPK file should be present. For example, I am targeting the Netflix application first. So my application, my Netflix got installed from the Play Store. So there will gonna be a APK file, right? Because Android is meant to install APK file. Even if you are talking about Harmony devices, Harmony OS, they do support APK files, right? So at the end of the day, if I have to install application in my Android emulator or Android device, APK is needed. Doesn't matter if we are installing it from a third party or installing it from a Play Store. But important thing which we have to consider right now is that whenever we download any sort of application from Play Store, by default, now we will get these split APKs. Okay. So even if I am targeting right now the Crunchyroll application or the Netflix application to perform the FAST or to perform the static analysis, I will not at all get the single Netflix.apk, or I will not at all get the single Crunchyroll.apk file. No. Why? Because I have installed it from Play Store. So I will get the split APK files only. So let's see how we can uh, get those files. So my next command would be the pm path. I guess the command should be something like this only, pm path, and my Netflix application location. So this is where my Netflix applications base APK resides in. There should be more PM list path. No, there should be more. Okay, let's uh take a look at Crunchyroll, PM path this, and same. Okay, let me start this application. Wait for it to start. Okay, let me and Crunchyroll, because right now I am only seeing a single APK file, which is base APK. I am not at all interested in a single file. So let me do one thing. I might have made some changes into this application, so I'll reinstall it. So let me uninstall it first. Come on, come on, come on. Full stop, okay. Uninstall, okay. Now Netflix, okay. Let's reinstall these two applications once again. Mm, Netflix, install, and our favorite Crunchyroll, RWL, install. Let's wait. I will exit right now. And let's wait. That is all we can do right now. Almost done. Let me check if Netflix is installed. Yes, Netflix is installed. Crunchyroll will be installed in a moment. Come on, buddy. Where are you? Still stuck on 90%? 94, okay. Yeah, it is being getting installed. So Netflix is installed. So let's do our ADB shell again. PM list packages, grab Netflix. This is the package name. Then PM path, and here we go. Earlier on, made some changes in the Netflix application. That's why these split files were not at all visible. But once we download the application from the Play Store and don't make any changes into the APK file uh, in terms of reverse engineering or in terms of code tampering, then we will get this different split APKs. So this is the legitimate flow. These are the legitimate files which we will get once we download the application from Play Store. Now we have to extract these files and we have to merge them into the single APK so that we can perform our task activity. Uh, let's take a look at Crunchyroll as well, because I am also interested in that. Crunchyroll, and here we go. PM path Crunchyroll. And Crunchyroll gives me only 3 different files, whereas Netflix gives me total 4 different files. Okay. Twilio application, Twilio.apk file is something which is missing from here. Okay, let me start Netflix. Let's wait. Let's try it out again. Okay, why bro? Why do you have to crash like this? Come on, come on, come on. Be a good friend and start properly. Sign in, okay. And here you can see that once we try to interact with our application, we will get a lot of different TPK files, right? Earlier on, I downloaded Netflix and didn't use it properly. So I was getting these 4 files. But once I started interacting with the applications, I got to know that, wow, Twilio based application is also something which came with Netflix. That was strange. So now what I have to do as a tester, I'll have to pull all these Netflix files, all these Netflix split APK files, and merge it into one APK so that I can do my activity, you know. So uh, I will make a directory Netflix, let's say, and I will also make a directory for Crunchyroll. Crunchyroll, okay. Now let's start downloading this file. Let's start pulling up this file and saving it in our Netflix directory. Yes, this is done. Now the second, third, fourth, fifth. One thing which we can notice over here is since I am using Intel based Mac and my emulator CPU architecture is also Intel based. So I am getting this split underscore config dot x86 underscore 64 APK file. And I also have this en dot APK which indicates that this Netflix application has English language so far enabled, or so not enabled, but this application is meant to present you the English language as of now. And I also get this xhdpi.apk which indicates that my Android emulator's DPI or screen resolution falls under or falls somewhere around 720p. Okay, these all are the common information which we will get uh, by seeing all these state APK files. And this base APK file indicates me that all the Netflix applications core logic resides under base APK. Okay, so what file I have downloaded? This one. Okay, let's pull up this file also. And now let's proceed with our Twilio ADB pull and this. Oh, okay, sorry. APK. It should be APK. Then this one, and last but not least, the final file. Okay, so I have downloaded all the files. I can see that I have extracted all the files. So let's see. Okay. I so these all are the files which I got. Okay. So the important thing right now is I would need these files. So let me copy that file in my current directory. Uh, those files should be uh, where it is APK editor. This is something which I need, APK editor. Uh, and I would also need my where it is apk tool dot jar file. Not you. Do I have any other? No. Okay. So these two files is something which I need. APK editor is one of the file which I'm gonna use right now to merge all these split APK files into a single application. So do I have? Yes. Java hyphen jar APK editor, then M. Let's take a look at the help module first. So M is meant to merge the split APK files or compress all the files into a single library or into a single file. Then we have a refractor also. Refractors obfuscated resources name. So it basically tells me that after decompiling the application or after pulling out all the PID files from the emulator or from the device, if I get any obfuscated names or if the application's internal code have any obfuscated names, it will gonna refactor it, will gonna remove it. Then P is meant to obfuscate the APK files, APK resources. Okay, let's first try to check the information of the APK file. So what I will do, okay, let's not do the info first. Let's first merge the application. So java-jar APK editor, I have to merge it. And after merging it, I'll have to give the source. And my source location is this. Over here, I have my Netflix directory. And here we go. Here, my APK editor file Java file is automatically merging all the different APK split APK files into a single file. So over here you can see that total 7 different APK files were found, 7 APK files found. That means total 7 different modules are found. All these APK files are now getting merged into a single base file that is known as base.apk. Along with that, whatever different text files are present, they will also gonna be merged into a single file. Then it is merging the value files, and it is merging all the split APK files which we got. Then it is creating a proper manifest.xml file. It is removing all the different attributes which are as of now not required. And since we have these split APK files which we uh, downloaded, which we got from the Play Store, what this APK editor tool is doing, it is basically removing all the different metadatas from my manifest file so that uh, it can behave as a single file. It is also removing a table entry known as split0.xml. This split0.xml file indicates the uh, file name or the file range or the file count. Okay, split0 will be considered for my single file base.apk file. Splits1 will be for second file, second APK files. Split2 will be for my third APK files. So what it is doing, APK editor file is doing, it is basically removing this specific XML file from the res XML folder. It is also removing different files, different metadata tags, such as this one, com.android.vending.splits, com.android.vending.derived.apk id. Then it is writing the APK file, and at last we will get my merged APK file at this location, Netflix underscore merged.apk. Okay, if I go over here, did I got any file? Yes, I got that file over here, Netflix underscore merge.apk. Now, what we can do, now we can proceed with our SAST activity. I can use APK tool to decompile this application and perform the static analysis part. I can also use MobSF to perform this automated SAST based activity. Okay, so let me use that APK tool. Decompile -rs. I don't want to decompile the resources and the different stuffs. Uh, I don't want the Smiley code as well as of now. So I have used -rs tag, and I will mention the application name. Let's wait. It will not convert the text file. Uh, this rs tag will not gonna convert the text file, and we will also not get the Smiley code. So apart from all these things, what we will get our manifest file, Android manifest file. We will also get the native libraries which are present in Netflix. These all are the things which we will get. And this is some of one of the interesting file, which is lib bug snag hyphen root hyphen detection. So just by saying the name, I can tell or I can have a rough idea that this might be related to root detection, but I'm not sure because the uh, native library file size is of 5 KB only. So as of now, I'm not gonna go ahead and start the Gidra, start analyzing this root detection set object file. No, I will pull my horses back and I will stick to the static analysis part as of now. Okay. So we can also use we can also decompile the application without RS tag. So now I will get the Smiley code and other different things which I can uh, use it, which I can manipulate it. Okay. Similarly, if we don't want to use the APK tool, JADAX is one of the well-known tool present in the market. We can use that, which everyone basically uses. I don't have to give much introduction about JADAX. Now, what we can do? In the meanwhile, I'll start uh, MobSF in the background, but first I'll have to install it. I think I have not installed it properly. Oh, do, which Python 3.12. Okay, okay. So I'll have to install Python 3.12. As of now, I'm not gonna do that. Okay, so let me show you something. Like, there might gonna be a question that Deepak, you have extracted the split APKs, you have converted that split APKs into a single merge file. Now what? Will you be able to reinstall this merged APK file into the emulator and use it as the actual Netflix application? Let's try to do that, and then we will get the answer. So before proceeding with our installation, before proceeding with our installation of this merged Netflix application, we will first uninstall this already installed Netflix. Hmm. What about the storage? I don't want anything. I will clear the storage. Yes, I will uninstall this. Okay. Now I need one more file which I can get from either internet or from other different location, that is Uber APK signer. This application has the capability to sign the application with a generic certificate as well as to align the bytecode boundary of the APK files properly. The bytecode boundary should be 4 KBs. This Uber APK signer application has this Uber APK jar file has that kind of capabilities. So I'm not gonna use APK signer, zip align, or jar signer tool manually. Instead, I will rely on Uber APK signer file. There are different instances, there are different scenarios that once a tester tries to perform the Frida gadget injection into the application, they will face some problem when signing the manipulated APK file using Uber APK signer because it will not gonna work properly. So the tester will have to rely on either APK signer or either jar signer and Cookie Align tool individually. Okay. Right now haven't made any changes. So I haven't made any changes into the application, so I will simply use the Uber APK signer file just to sign the application and reinstall this APK file directly into the emulator. So this should be my command java hyphen jar Uber APK signer hyphen hyphen APKs and my application name, which is this. And let's see. So the bytecode boundary line is done. Verification is also done. Okay, we got 0 errors within 5 seconds. That means This is the final application. Netflix merged, aligned, debug, signed. Wow, what a name. Okay, so since I have uninstalled the Netflix application, what I will do, I will try to reinstall this application. We can do both way. I can simply drag and drop it, or I can use ADB command line tool. ADB installed, Netflix merged, align. Yes, this is the file, and yes, all files are installed properly. What ADB does basically, ADB basically tries to install the application in an incremental order. We can try to bypass this and we can skip out the incremental installation procedure and we can directly install it as well. Okay. But if I drag and drop this application into the emulator, then I won't be able to skip the incremental installation part. Okay. So Netflix application is present over here. Will it work? Let's check. For the testing purpose, I will use a dummy credential and try to identify if I'm getting any sort of different error or not. If I get different error or if I get any sort of error indicating that credentials are not working, then it means that I have successfully merged the Netflix application and it is using properly. But I'm not sure why it keeps crashing. Let's give it one more try. Okay, sign in. Email ID, let's say I will use test at the rate. Come on, come on, come on. I don't want you to behave like this. Okay, sign in again. Test at the rate gmail.com and password should be hello world. Okay, this is something which I am not at all doing. Let's sign in again. Test at the rate gmail.com. Password should be, let's say, hello world. Dude, now this is irritating. I should have used my actual device instead, I think. Come on, come on, come on. Installing resources. Let's just say test at the rate gmail.com. Test as a password, sign in. Okay, this is actually a strange thing because usually I tested this out in my actual Android device and it was working properly. But in the emulator, it either keeps crashing or it either goes in a loop. That is something weird. Let's try it out again. Get started. And okay, no problem. Fortunate, thankfully, I already have what you say, uh, a video file where I have recorded all these steps. Let me go to that location. Where will I get this? Come on. Is it in screen recording? No. I think I have placed it somewhere else. Okay. Okay. No problem. Uh, so as of now, I will stop here. Uh, I don't know where that recording went. It should be in my screenshots folder. Yes. Do I have screenshots? Yes. And okay, yes. Yeah. So the overall procedure, I have already recorded it. And did I? use Netflix or Crunchyroll. Let me check. Okay. So in this current video recording, I used the Crunchyroll application. Okay. And in the Crunchyroll application, everything was working properly. What I'll do after signing the application, I will simply drag and drop it, or I can use the ADB to install the application. And I used ADB to install it. And after doing that, I went ahead and tried launching the Crunchyroll application, gave the test credentials, such as I gave the normal credentials, and I got the error, which indicated that yes, the application is working properly. So I went to create account button. I clicked on that create account button. Then I entered the invalid credentials, and why it is taking a little bit more time. And yes, as you can see, I entered some random email, random password, tried creating the account, and I got the error, which specifically indicates that yes, whatever the merge file I have created, it is now working properly, and we can use that merged APK file to install the Crunchyroll application in either my emulator or either in my physical Android device. Okay, so yeah, these were all the things which I wanted to talk about. Okay, important part about the signing is that, which I already said, that all this bit APK files should be signed with a single file. If it is not signed with a single file, then my installation will going to be failed. Okay, so yeah, I'll take my rest now. I'll stop over here. If anyone have any questions, feel free to ask me.
Yeah, thank you for the amazing talk. And yeah, it was very nice to see, especially the Android and APK things. Can be handy for me soon. Uh, but yeah, for the people who are watching, if you have any questions, yeah, regarding this talk, then please place them in the chat, and we will answer them. Let's give them some time to maybe type their questions. I don't see any questions popping up so far. I think it was very clear for the people.
Yeah.
They were just flabbergasted. It's like, whoa. No, I don't see any questions popping up so far. So, yeah, I think we
Not
can.
at all. Uh, Everyone can reach out to me on my Twitter account. They can also subscribe if they want to my YouTube channel. That YouTube channel is a side project, I would say. It consists of several video tutorials which gonna help the beginner to learn about application security, API testing, and other different stuffs. So if anyone is interested, they can look out to that, and the rest is up to you.
Yeah, well, as you heard what he said, you can always reach out to him. You can find him in our Telegram group or of course on Discord. Uh, he's always happy to answer and help. So yeah, I want to thank him, of course, for giving this amazing talk, and for the speaker for the people who are watching. We will go to a short break for about 5 minutes, and then we will start with the next talk. So again, big applause for the speaker, and I hope to see you guys with the next talk.
Yes. Thank you, everyone.
Silent nights online, hackers online. on the prowl. Keep your passwords tight, don't let your systems howl. Encrypted files safe, two factors quite a gift. Without it you're a target, your data might just drift.
Firewalls, firewalls, guard your precious slave.
Hackers try to sneak inside, but they can't ruin your day.
Firewalls, firewalls, keep the threats away.
Clicking links without a thought is Santa's big no way. Deck the halls with updates, patch your software right. Ignore that sketchy email, it's phishing in plain sight. Malware's creeping closer like snowflakes on a breeze. Scan your drives for safety and keep your holidays with ease. Silent nights online, hackers on the prowl. Keep your passwords tight, don't let your systems howl. Encrypted files safe, two factors quite a gift. Without it you're a target, your data might just drift.
Firewalls, firewalls, guard your precious slave.
Hackers try to sneak inside, but they can't ruin your day.
Firewalls, firewalls, keep the threats away.
Clicking links without a thought is Santa's big no way. Deck the halls with updates, patch your software right. Ignore that sketchy email, it's phishing in plain sight. Malware's creeping closer like snowflakes on a breeze. Scan your drives for safety and keep your holidays with ease. Silent nights online, hackers on the prowl. Keep your passwords tight, don't let your systems howl. Encrypted files safe, two factors quite a gift. Without it you're a target, your data might just drift.
Firewalls, firewalls, guard your precious slave.
Hackers try to sneak inside, but they can't ruin your day.
Firewalls, firewalls, keep the threats away.
Clicking links without a thought is Santa's big no way. Deck the halls with updates, patch your software right. Ignore that sketch.
Hello guys, welcome back. I hope you are ready for the next speaker, because he's waiting. Let me see. Yes, because he's waiting. You can already see his talk at the screen. Signal Force, Ultimate Swiss Army Knife tool for hardware hackers to debug hardware protocols. So it sounds very interesting, especially for the people who love to do hardware hacking like me. Yeah, I'm not going to hold your time any longer. So I hope you all have an amazing time with the next talk. And I want to give the word to our next speaker.
Today, I'll be talking about Signal Forge. You might have seen a change in the name. Initially, it was UART Forge, but then we plan to extend this tool to various different to ensure that it supports various different protocols. So that's why we have kept it as Signal Forge. So the idea of this particular tool was to just have a border detection tool written in Rust that was from the previous tools like baudry.py and many more, which were written in Python as well. But then we thought, okay, rather than just solving a certain problem, why don't we solve the problem all together at once, like one place for everything? Because initially the pieces were quite different. For every piece, there was a different solution altogether. So we plan to we plan to make this tool so that from the start to end, from the identification to the point where you actually exploit, you can actually make use of this particular tool. So that's why the name is Signal Forge. Uh, yeah, I'll just tell a little bit about me. I lead a payment hardware security lab at CISA Information Security, and I'm also a co-founder of IoT Security Research Group. So it's basically where we come out of this certain cool research that we have. We also have certain products like Ice Bytes and more. And again, we have restarted a community called AssistInfo after it has been around from 2011, discontinued due to COVID situation in 2019, and now we have restarted. So I'm also a co-team member of SysInfo. It's a purely technical community meetup. So yeah, that's about it. Okay. So the agenda, I will tell you why exactly are we even looking at UART in 2025 or 2026. What about the other protocols, JTAG and SWD? And I'll explain you what exactly UART is, because a lot of people who get started in the hardware hacking, one of the things they eventually have to learn or will have to learn will be UART communication, because you find UART protocol in almost all the devices, I would say. Certain devices do not have it. And then I'll tell you how exactly the UART data transmission works, what are the different parity bits, and I'll also tell you reason why I'm teaching all of this. I'll be explaining all of this, and then we'll work towards a solution. Okay, the entire tool is based on the certain solution. So from the initial point where you open up your device to the point where you identify your UART and you take it further to exploitation, is what we are going to showcase today. And there are certain tools you might have heard about, like JTagulator from the very grandmaster Joey Grant. We'll tell you how exactly JTagulator is different from what we have done, and how JTagulator supersedes in certain ways from this particular tool, and what are the trade-offs that you have to go with, right? And why our tool. And I'll also tell you the different type of adapters that we have tested this tool with. Okay, so that's the agenda for the day. I'll just go ahead. Okay. Um, from a long time, we have seen that you everyone talks about how they've got a shell over UART. Probably you take up a router, you get a shell, you do XYZ things, which is all fine. But the reason why you actually still find UART is because UART has only two way of communication. It is very simple. You only have your RX, TX, and your ground. Your ground is to have a certain base. I'll tell you why you exactly have this certain base as well, as to how you define your logic levels with this particular base. And then with this, the most important part you have to notice is that in the other protocol, in other hardware protocols, you have your clock, but in this one you don't have your clock. So now what happens is that reduces the price whenever you're manufacturing these devices, and moreover the protocol itself is very straightforward, and the implementation becomes much easier. Still there are many different ways to implement, but it's been around for a long time now. Okay. And the other reason is that you'll find this in most of your microcontrollers and your SoC inbuilt. as in your the chip that you basically have it on your particular device will support UART. So what happens? Your intercommunication becomes much easier. If not, the other ways also you can do is that you can have some software libraries. Like for an example, a 1085 does not support UART, but then you have certain libraries that you can leverage to simulate UART communication over there. Uh, Okay. And then and yeah, as stated, right? So it's very cost effective for OEMs to implement, and that's why they have this. And most of your firmware and your bootloaders, the default mechanism, if you would have seen OpenWRT website for unbreaking your routers, the most common way is this is UART protocol, and you also have your bootloader shell as well, but you also find this. So, from my experience, what I've generally seen in a professional lab experience is also that most of the devices will have UART. Approximately, I would say I've come across 90% of the devices having UART. Certain devices, like NRF52, not in this case, certain NRF52 devices will have their SWD as well. Okay. And also, so I've spoken about UART being used where you interface with it, but UART is also used to interface with your other chips as well. Consider your ESP32. In ESP32, there are two UART ports. You can also see that the one of the UART port is also used for your Bluetooth. You can basically have your Bluetooth command sent over and listen to it. And in here you can see that I've placed how exactly your NRF52 interfaces with your host microcontroller. So NRF, I'll just give you a little information about NRF52. NRF52 is the most widely used Bluetooth chip. So almost all of, I would not say all of them, the newer devices what you're getting, and some high-end devices will have NRF52 most of the time. Okay. So now moving on. So now we know that okay, UART is the one which is widely seen, and it's been widely used everywhere from your OEMs to your supply chain. It makes the job much easier. Okay, and now okay, why not JTAG and SWD? Okay, now the reason why we have kept second priority for JTAG or SWD is that finding JTAG on your commercial devices is a big challenge. You might find it on your debug version of the certain devices. Probably OEMs might have them enabled for their interfacing. But then on your commercial side, it's very rare that you actually find your JTAG open because they would have logged it with one-time programmable keys, which will be present. Those are like your hard-coded values that you have on your microcontroller. And then SWD is also a stripped-down version of JTAG. We'll be adding support for SWD as well. But then you'll find SWD most probably in your smartwatches. On your lower end devices, you'll find SWD. Okay, JTAG is still on the higher end devices, but SWD is all on the smaller devices. If you have seen people happen to play Doom, um, or games on your smartwatches, smart bands, sorry, smart bands, is where they would have made use of SWD. So we are going to focus on it later on for now. So okay, now I'll show you the communication. What exactly is UART? So if I can tell you in a very layman's term that I understand and that I got my initial understanding is that okay, if anybody is talking to you, consider my language which right now that I'm communicating is English. You need to have the capability to listen to me and interpret the same language. If at all, if I'm talking in some other language, and if you're not able to interpret, uh, it you're not getting the entire communication right. Okay, so that's why you see the RX. Whenever I am telling, which is nothing but I'm transmitting, you are basically listening. That is TX. Sorry, that is RX. And when you are talking, when you are transmitting, I'm on the receiver end and I receive it. Okay, now we have spoken about this. Now we know that okay, we have one line for transmission, we have one line for receiver, and the vice versa on the other side. And I'll tell you about the length. how exactly your data transmission works. So you have your 8 bits over here. We have your data bus. We have 8 bits of data that goes along. So you can see this, all the 8 bits of data comes on the other side. Okay. Uh, and now, okay, the abbreviation of UART is Universal Asynchronous Serial Transmission. Is- yeah. And over here, when you mention that universal asynchronous, it means that there is no clock to synchronize the data between your receiver and your sender. Okay, and the only way that you can, but then if at all if you need to have two ends, a certain base to communicate, you need to have something. In here, it's your baud rate. So baud rate basically tells you, okay, I am gonna talk at this particular speed, and you need to be configured at that particular speed so that you understand what I'm trying to send. For an example, if you're sending Morse code, the other end should know that okay, I have to decode Morse code. Only then I'll be able to give the entire message correctly. Okay, so that is what is baud rate is. I'll explain you more about the baud rate. Baud rate is nothing but number of bits that you can send per second. Probably, I think we'll go on to the next slide explaining that one. But in general ways, if at all, if you open up your device, you'll basically have your 4 pin or your, you can very much clearly identify your UART pin some of most of the times. There are some caveats as well. I'll tell you, probably we have certain slides for certain caveats that you'll, certain challenges that you'll face along, but it is mostly 4 pin or 3 pin. You can see it, it's somewhere close to your microcontroller, 4 pin or 3 pin. And as stated, your RX is basically the listener, your TX is the sender. So it is, I'll reiterate this again. It is the TX is the TX is where you're gonna see the serial logs. So whenever you boot up your device, there are serial logs that get printed. Okay. So only when you're hooked into the TX of the device, which is nothing but the device is transmitting, we have to connect our RX, that is our adapter, to the particular TX of the device so that we can listen to it. More on this in the next slides, but I'll tell you ground is a common reference. Okay. What happens is, consider you the device might be operating at a 3.3 voltage. If at all, if you don't mention what is your base level, in here it is digital communication, as in if the clock signal is high, or if it is the probably the voltage is 3.3 and the operating voltage of the device is 3.3, then that is 1. If it is low, which is nothing but your ground, it will be 0. So now the common ground that you need to have between both the device and your target, between the adapter and your target, is ground. Because if not, what happens is that there'll be a floating point, nobody knows what exactly is the ground, and then you won't be able to follow the principle of digital signals, and you won't be able to get the entire data. Okay. That is why you have your common ground, because a lot of people generally question, okay, why do you have ground? Ground is for this reason. Okay. And as stated, baud rate is where I did mention you that it's a bits transferred per second, and in serial communication the data is transferred bit by bit, okay, using a single line, which is nothing but RX goes to TX, goes to RX. Okay. I'll move on to the next slide. Okay. There are certain things that we'll have to understand. I'll also tell you why exactly we are understanding this particular one. Okay. In UART, the transmission line is basically held high. Okay. If you have made use of your I2C display, 126 into 86 or 80, I don't know, you will have to connect your 47 k ohm resistor to the 3.3 voltage of your Arduino or whatever microcontrollers, so that you pull the I2C line high. Okay, which means that the normal standard for this particular one is that it is high, as in the whatever the operating voltage is, considered 0 or 3.3, it will be on the top, as in the voltage will be 3.3 itself. Okay. And when do you get to know that okay, it's actually starting, the packets are starting, are gonna start transmitting the data, is when it pulls the line from high to low. Okay. Probably I think, yeah, see, for an example, this is your high. You see we have whatever you see, this is nothing but your certain ground. Okay. And this is your low. Okay. This is your high and this is your low. We'll come back to this again. Okay. And then we have the data frames that is from 8-bit data that we can send across, that we've already spoken about. And now we have something called as parity bits. Okay, the entire concept of parity bit is to basically help you as a checksum. For an example, it is to identify the evenness or the oddness of the number of bits which are high. For an example, if the parity bit is 0, then we have even number of logic high, which means that for an example, if you see, yeah, this is your parity bit. Parity bit is 1. Then you need to have odd number of ones, which is nothing but 1, 2. So this is your logic high. Okay. Now this logic high, 1 logic high, 2 logic high, 3 logic high, 4 logic high, and 5 logic high, which means that this is an odd number. So the oddness of this particular one is nothing but parity bit. Okay, this is one. And I'll tell you why exactly the parity bit is, right? Because see, these communication lines are prone to electromagnetic interference. So just to ensure that your data is not lost is why you have a parity bit. And you also see this, right? I don't know how many of you have broken your cut your wires, and you might have come across a certain mesh wire. The reason why that you have mesh wire is to avoid such electromagnetic interference, so that your data, even if a slight change in your data, right, the data that you'll get on your output will be entirely gibberish. You won't be able to understand what exactly is happening there. So that is why you have a parity bit. Okay, and then you have a stop bit. Stop bit is nothing but you basically pull your data line to low, saying that okay, this is where I'm gonna stop my data. uh, Oh, sorry, sorry. No, no, no. So basically, now you basically pull your line from your low voltage to your high voltage, saying that okay, this is where I end my transmission, and that is what is what when I said you that the voltage level is high. So whenever it goes back to high, it means that okay, this is my end of my packet. Okay, this is your exact data transmission. And I'll tell you why exactly we use this. So whenever we are creating a certain UART profile in your minicom, we need to mention all this, because if at all if you're not mentioning this, what happens is that your entire data that you'll be interpreting will be completely wrong. You won't be able to make sense out of it. That is why I explain you what exactly data transmission is. Okay, and we have seen this. Okay, if you see this, this is your logic high. The ground that you see is what defines ground. As in you as a common base, you need to have both your grounds connected. Okay, and this is your logic low. You can see this high to low, and over here you can see this is your stop bit. It goes from low. Okay, 0 0. Okay, that's how you basically transmit your data, and that's how the receiver interprets it. Okay, and now and this is your data bits, 1 2 3 4 5 6 7 8. Okay, okay, now coming down. The first and most important thing whenever you wanna interface with UART, okay, is that you first need to identify where exactly UART is before doing anything. And I'll tell you something, uh, from the blogs or from what we have seen, from what people post, saying that just take a device, bring a debugger, connect to the UART port, and you have a root shell. Then you can do anything and everything that you want. It's not what the reality is anymore. Okay, your OEMs have started placing mitigations. These mitigations are on the hardware level and on the software level. Hardware level comes with certain challenges that I'll speak about in a certain while. But the very first step is okay. What exactly do you do? You open up a device. Okay, what happens? What are the challenges when you open up a device, right? Uh, I think okay, yeah. I'll probably come down to the challenges in the next step. Okay, first thing, it's a very simple thing. You open up the device. You basically check out for candidate headers. Like for an example, if you're lucky enough, you'll get a silk screen marking. You see this, we mentioned we needed an RX, we needed a TX, and we needed a ground. But generally, you also get a VCC. Okay. So if you're lucky enough, you can get the silk screen marking. And probably I think now the cameras are quite advanced enough that you can take a picture and you can identify the silk screen marking. Okay. And in some cases, you won't have silk screen marking. Like for an example, just give me a minute. Yeah. So if you can see over here, there are no silk screen marking over here. But in this particular scenario, I have good amount of silk screen marking. You see VCC, RX, TX, and ground. But in here, there are no silk screen marking. But then if you see, it is very close by to your microcontroller. Okay, and you can also see, the traces over here. The traces, you can see that the traces walk over here, and then from this we have traces to this particular line. This I don't know what it is, but again we have traces to this line, and then from this line we have traces over here. I don't know where this one goes to, but you can generally identify this with a multimeter. Okay. Yes, that is what you generally would do. You identify the four different lines, and then the next step would be that you identify all your components on the device. This is this, like, you're doing your recon phase. Entire This is your entire recon phase, where you identify your microcontroller, you identify your RAM, you identify your flash memory, and then you try to grab data sheet of all the different components, and then you make a table out of it, so that tomorrow's date, whenever, if at all, if you have to refer this, it is much easier. Okay. And again, remember that I mentioned that it is basically idle high, as in whenever the UART is not sending any data, it remains high. Okay. And whenever it starts, you have a falling edge. Okay. Then also what you can do is that, as stated, take up a picture. You can do pin tracing. For an example, what I showed you over here, following the lines over here, you do your pin tracing, and then you identify this. Okay. Okay. Now, sorry. Okay. Now, coming down, what okay. Coming down, we can see that, okay, some of the challenges that you'll actually face is that in some of the devices, what we have seen, I mentioned to you that the device pins are gonna be somewhere around 3 to 4. But in some of the devices, you will see a combination of 10 pins, as in you'll have a 2 into 5 row header. So in this case, it becomes much challenging for you to identify which is you are. There'll be multiple grounds there, and if at all, if you have a 2 into 5 row header, it could also be your JTAG pins. We never know. And again, something that we have seen, that I've basically seen in my experience so far, is that on the top, if you see, this is an image from a stereo microscope that I've taken, and you can see for different type of devices. See, for an example, this is a camera, IP camera. The placement of your pads, placement of your pads is different, but when it comes to your router, the placement of your pads is different. So this could also be one of the identifiers that you can basically have. And the challenges that I'm so sorry, yeah. And the challenges that you will come across in such situations will be that, I mentioned to you in the previous step, gather the microcontroller data sheets if you have. But then, whenever an OEM manufactures a certain chip for their particular use case, you will not be able to get access to the microcontroller. If it has been leaked somewhere online, you probably would get it. But again, how much of it you get it, we never know. As in, you might not even get it. But in such cases as well, you can find sister chips. What I mean by sister chip is that you from the same family of microcontrollers, you identify the chip with the similar pin pattern, with a similar number of pin layout, and then try to map it with this as well. Because what happens is that whenever you're trying to, you cannot have a different design specification made for an entire OEM, that an entire new chip can be manufactured. It's going to be quite pricey for your chip manufacturers to do that. So they might not have the exact data sheet, but they might have produced some other chip of the same type, the same pin layout that you can use. That is where your techniques such as pin tracing will come into picture. Okay. And last but not the least is that the one dangerous thing is that, it's like a ticking time bomb, as in, whenever you have your tamper switches. What I mean by tamper switches is that So tamper switches are nothing but they whenever they are pressed together, you have a certain resistance value between them. And whenever you open the device, the change in the resistance value will send a signal to your microcontroller to erase all the data. So I probably yeah, I should have added a picture where it shows you that okay, tamper alert detected. But you in the newer devices, it is it's being inbuilt in it. As in, whenever you try to open up your screws, the switch will get triggered, and then the entire device data is erased, which is a challenge. But then there are other ways you can circumvent that as well. Probably do not directly open up the device, drill it towards the sideways to see what exactly can you get. And if it's a plastic one, just probably heat up and cut out the area wherever you have your cut from the area wherever you have your tamper detection, and then you can do that. So this is a very simple tamper detection bypass. But there are other different bypasses which could include like your endoscope camera and many more. Okay. And then last but not the least is that you will come across custom screws. There are two ways you can circumvent the custom screws. You generally make use of you weld a you weld a screw you weld the particular screwdriver, the screw, and then you can just fold it, or else you have a certain micro drillers, okay, where you basically drill in and then you pull out the screw out of it. So that technique is also present. But then now, in the interest of time, I'm just telling you techniques that you can circumvent. What exactly is our solution? Oh, I again just messed up. Okay. What exactly is our solution? Now I've spoken to you about the challenges. I'll tell you about the solution. Okay. So this project I've been working on from past couple of months. So what exactly the project does is that we have I've basically opened up a website called as pcbdecoder.com. I think the website is not up yet. I was supposed to get it up by this particular talk, but then I couldn't. But I'll probably do it before the new year. New year, I guess so. So what I've done is I've taken 1,400 images of multiple different devices. I have trained them, and I have personally marked which exactly is your UART pins. Okay, and not just that, I also have an OCR. So if you see this, I've trained an object detection model, and then for every object that it detects, it will tell you what is the confidence level for each of this particular detected debug port. Consider for UART, it will probably show you like 90% or 100%. And I'll be expanding this one. There is still more to work on it. But I'm not an ML expert. I'm neither an AI whatever expert it is. But I have just tried to stitch and see what I can get out of it. The results have been quite good so far. And I also have an easy OCR because sometimes reading what is present on the chips becomes difficult. So currently I just have a normal OCR, but what I'm going to do is that I'll be adding some image filters so that I get the accurate OCR values. It's a little pricey to implement this. I'm just working on the pricing and how exactly, but this is going to be free for everyone. So I'm just working for it. I'll show you the output. Okay. So the output when I run, you'll see something like this. Consider you upload an image onto this particular website. If it finds that okay, it has a certain pin in a certain format, it will tell you okay, this is UART and this is its 97% confidence value. And for easy OCR, these are two separate parts that now I've stitched. I forgot to take the updated screenshot, but you can see this. It can tell you okay, this is an IC, this is a capacitor, what it does, and the next value will also be your easy OCR as well. But this is prone to false positive. But with the better training, I think we can basically reach to a point where the false positive will drastically reduce. So the very first step, what we have basically seen so far is that how to open up a device, what are the challenges that you can actually face while you're opening up a device, and then how exactly you can circumvent it, and how exactly you can make use of a pcbdecoder.com to help you with this. So the entire intention was to make the entry level in hardware hacking much easier. Okay. Now, okay, I spoke to you about adapter and a target device, right? So this is the adapter. And this is your target device. So you can see that this is my UART pins, and if I have to talk to this one, my TX will get connected to my RX, or RX of the target. This is my target device, this is my adapter, and then ground is the base level, and the RX goes to TX. Okay, simple as that. Move on to the next one. Okay, the first step, what you'll have to do is that, consider we have got multiple pin setup. Okay, I've got TX, RX, ground. These are the three pins that you have to find. Generally, you'll find four pins: VCC, ground, RX, and TX. But the first thing, let's identify TX. Okay, how do you identify TX? Okay, a couple of things that you should know how to, before we step ahead, is that you need to, we assume that you know how to use a multimeter, and especially in multimeter, how exactly, if you know how to make use of continuity, to identify the ground. Okay, because there is no, I don't know if there is a method to probably do some stuff automated or something, but um, you need to know this. This is a basis of using a multimeter, and how you can make use of a continuity test to identify your ground. And also, you don't need VCC at all. VCC is not required, and you do not need to connect. Okay. And then again, whenever you connect your multimeter, remember, first always connect to the ground, and then connect to different points. Generally, whenever you see there's a little fluctuate in your certain pins, whenever you boot up the device, that could be your TX. Do you know why I say this? Because it works on your logic high and logic low. So you have from 0 to the operating voltage level. Okay, and we'll have to power cycle the device certain amount of times to identify what is the candidate pins, because whenever a device boots up, right, you have serial logs that get printed. So we are going to leverage these particular serial logs. Okay, and the other way that you can also do is that you can identify your logic analyzer. You can make use of a, sorry, you can actually make use of a logic analyzer to identify your UART. But then our intention here will be focusing on a single adapter that can do the entire job. Your logic analyzer will be around probably 5 to 10 dollars, but we have tried this with less than a dollar adapter, and it works like a charm. I'll tell you this about this again. So, and you can, okay, I'll come to things like baud rate. I haven't spoken much about the baud rate. Okay, so what happens in the first part, that you, whenever you have to interface. Okay, whenever you're soldering, right, we are looking at points which are very minute. When I say that, I think it's probably 1 to mm. So your soldering becomes very hard. And see, now here what we are talking about is small scale devices. The images and all references, what you see is small scale devices. But if you get large scale devices, probably consider you're getting a device which is probably like 1 lakh, $1,000. You cannot afford to break the device. So in such cases, we have made a solution called as Ice Bytes. Yeah, you can see Ice Bytes. Okay, and couple of things that you'll actually come across. I mentioned to you initially that there are software mitigations, and then we also have hardware mitigation. Some of the software mitigations, hardware mitigations, will be that you'll have your pull up and pull down resistors. We will see a live activity. I will show you a live use case, live, I don't know whether it's called use case, a live thing that we figured out, how you can bypass such hardware mitigation. And not having a proper baud rate, which means that if the baud rate is not set correctly, on your adapter side, you will get a gibberish value. Okay, and identifying the baud rate is different again. And then again, see, knowing your logic level is very important. When I say this, using the continuity test, you identify the ground from your multimeter. Using the same ground, you identify the operating voltage, which will be 3.35, 12, whatsoever. Okay, and these are the two things you need to know. And if at all, if you're soldering your the pin pad again, you will actually end up destroying the pin pad. And we I think I happen to do this a lot of times, until unless I could get a proper hand skill out of it. Okay, So yeah, a lot more adventures to come up. But just to show you, I think that's how minute your pads would be. So this is our product Ice Bites. Uh, okay, yeah, I don't know. This is a little confusing whenever I escape this. Okay. Hmm. So what exactly do we do over here is that the solution that we have built, the tool, basically listens to different baud rates. I think the next exactly is the baud rate. One second. Yeah. So we basically look at different baud rates to see in which particular baud rate do we get some printable characters, because it talks to you in serial that we get decoded into ASCII. So we see, okay, what are the printable ASCII that we get out of it, in which particular baud rate. So there are certain baud rates that you can sweep through, right, 9,600 to 4 lakh 20,000. And then again, there is something called as printable ratio that we calculate. I'll explain you what exactly the printable ratio is. And then whenever we identify the particular TX, right, we save this into a session file as to, okay, which exactly is the TX file and what could be the probable baud rate, because we will use this entirely at the end stage whenever we have to interface with your particular UART. Okay. Yeah, I think I'll show you the solution. Um, this is demo one. Yeah. Oh, I'm so sorry. I think I'll just open VLC Media Player. One. Okay. Let me show this to you. Mm, okay. Yeah. So the tool is entirely made in Rust. Um, and yeah. So you can, let me just reduce the zoom a little. I'll just take it up to 150. One second. I'll just adjust my magnifier a little. Mm, mm, Myself, I have a little difficulty with my own magnifier. I'm just there. Yeah, okay. Probably I've got it at 150. Okay. Yeah. So if you see this, whenever you start a particular project, it will ask you for a directory name. You can mention a project name so that, whatever you identify in that particular project name, you can utilize all the particular configuration later on. So we wanted to have it like, okay, consider you're working on a certain device, you type the device name or you type the firmware version name, and you test out that particular firmware version name or the revision of that particular hardware, and then again you go for it later on. So if you see this, I just type TP-Link, and whenever I enter TP-Link, it says that, okay, there is something that already exists in the project, you want to reuse it again. uh, yeah, I think something is wrong with my lenses again. Yeah, I'm pretty new to using this lenses. uh, okay. And now coming down, so whenever you connect a particular device, right, what it does is you'll have to give some certain Linux permissions, so that it will identify what exactly is your what are the debug ports that are present on your device. And in the so yeah, I think I'll just go back a little. Huh. So if you see this, whenever you click it, you ask it to identify, it can tell you that, okay, I've identified a certain debug port which could be your USB serial, and then Other below, you can just reference that. Okay, one, you select that particular one. Or else if you want to refresh, consider you forgot to connect and then you want to refresh, you just connect it back again and you refresh it. Okay, you have connected, and see, it will ask you the certain voltage. Okay, this is where the initial understanding that you basically got from your multimeter, you just utilize that, and then you can see that okay, we have created a project link where the adapter we will make use of the adapter USB 2 with the voltage level of this one. Okay, you see we have implemented four modules. That the first module is where we identify what is TX. The second module is where we identify what is baud rate. I'll come on the different ones, but right now let's just focus on identifying your TX. Okay, what exactly? We select the module that we want to run. Then you select again. This is just as a fallback mechanism, just in case if you have selected the if you want to run this with a different adapter, you can also do that. And this is just a compliance check to saying that okay, whether you're authorized to do the testing or not. The answer has to be a yes. And then okay, it tells you whether have you located the VCC pad. See, identifying VCC is good, but it's not like it's necessarily needed. I'll tell you why as and how we go on. Okay, have you identified the ground? Okay, if you have identified the ground, yes. Have you connected the ground of your particular adapter to the ground of your target? Yes. Okay, and see, I said you that in multiple places you will have multiple pins. Probably, if at all, if you come across a 2 into 5 row header pins, and in that case, you might you don't know which of it could be your TX or your RX pin. Here, there's a typo error. It has to be RX pin, TX pin. Sorry, I've just mentioned it as RX. I'll just correct that one. So it asks you, okay, how many amount of TX pins will you be testing? In my case, I think I have identified as I'm using a router. We generally have a 4 pin. I would have given around two, because now I've identified VCC. I've identified your ground, and how you can actually identify your VCC will be that one of your voltage would not fluctuate from the start. It would be just 3.3, unlike your TX, which might fluctuate. Your VCC will not. Okay. And what will you name it? See, for an example, certain pins might have some certain silkscreen values, or probably you might just take a marker, or you just write it next to that pin. Okay, whether it is TP3, TP1, whatsoever, because it becomes much easier for you to later on notice. Okay, this is the pin I've already tested. You just label whatever you have to write. Okay. Oh, yeah. And then what is the pin? Okay. So what it does is, over here, you will have to power cycle the device multiple times, because whenever the device boots up is where it has a serial log that get printed out. So we are going to leverage this particular power cycle to identify in which particular baud rate is it sending the data. So now what you do is you connect the RX of your particular device to your first target TX. Okay, and then it sweeps through multiple baud rates to see whether in any of this baud rate could it see any ASCII character that get printed. Okay, because even if you're getting gibberish value, which means that your baud rate is not correct, but then it is transmitting some data. The next step will come to identify, okay, what exactly is the baud rate. Now we currently don't want to know what exactly is the baud rate, right? Okay, then you see whether the device is powered down, and then if I say safe to probe, yes, you tell it a yes. Okay, now it tells you, okay, attach the TX lead to your RRR. So it has to be a TX. um, Sorry, here it has to be your RX. So now we connect the RX of a particular adapter to the suspected TX, which is nothing but this RRR value. RRR is what we have mentioned. Okay, and then you have it connected. You just tell yes. You power cycle the device. Yeah, so it tells you, okay, power the entire device. And then what happens is that, if you can see this, it starts moving to different baud rates. See, we have starting from 9600. This are most common baud rates. Okay, it goes to 576,000. You see, it tells okay, it has not received any data, any ASCII characters. Okay, now what you do is that now you do the same again with your other suspect. Initially, suspect pin where you connected your RX of your particular adapter to the TX of the device. Now you remove the particular from the pin that you've already tested. Consider this could be your TP2 or TTT. Connect it to that particular pin, and then you run it again. You power cycle the device. Over here, you can see that it has got some amount of data. Some bytes is what we are receiving. We don't know whether if that is the correct baud rate, but we know that okay, this is sending some data. We'll see what the data is, and I'll tell you what exactly is the printable ratio. Okay, the printable ratio is something that we'll look into sometime later on. Okay, now coming down. Now it tells that okay, we have identified that okay, at some particular baud rate at 9600, it has found some printable ratio. But do you think this is human readable? No, this is not. But it knows that okay, one of the pins in this particular one, TTT is where it is sending the data. So now we have identified a certain pin which is sending the data. What is the next step? You identify what exactly is your baud rate from that particular pin which is transmitting. Yeah, you can see this likely console RX identified. Sorry, this is again TX. There has been uh, mm, some errors with me getting things right over here. So I'll probably move on. Okay. Now we have identified your TX. Now what is the next step? You identify your baud rate. Okay. I'll tell you what baud rate is. Okay. Baud rate is nothing but number of bits that is sent per second. Okay. For an example, the most common, see, I think I am running out of time. I probably started at 4:30. I might take an extra 15 minutes or so. I hope that's fine, right? Sure. Fi- 5 minutes. I probably need 5 to 10 minutes. I'll just try to wrap it up as soon as possible. Okay. Yeah. Thank you. What we do is that we make use of Minicom. We iterate through different baud rates, and then we calculate something called as printable ratio. I'll tell you how is this printable ratio different. See, in the previous tools that you might have seen to identify the baud rate, the thing was that you can mention how many printable ratio what is the printable ASCII characters do you want to focus on. Consider you give 25. It will just ensure that okay, if at all at any point in time if I'm receiving 25 printable ASCII characters, it means that okay, that is the correct baud rate. But then there are some drawbacks to that. So what I've done is that I have taken the printable ratio, which means uh, consider at a certain point in time you receive certain bytes, 100 bytes. In that 100 bytes, what are the printable ASCII? You divide the receive one, the printable ASCII characters divided by receive one into 100, you'll get the percentage. So that's how you calculate your printable ratio. Okay. And then and also a couple of things that we have seen is that most of the places your UART is around 115200, but then that is not what it is. Some people have different UART implemented altogether, and your high and low lines will be inverted. Initially I told you that it's initially high, but that can be inverted. And you might have your 8 and 1. When I say 8 and 1, I'll tell you what it is: a data bit, no parity bit, and one stop bit. Okay, that's the reason why I showed you. Okay, this is what you need, because this will be using it in our Minicom profile. That will help us interface with the particular device. Okay, so we have two modes in a solution, in an open source solution that we have. One is the full mode where it peacefully iterates through every border and to identify. But there's a turbo mode where it iterates through most common borders and it identifies which is the printable, which has the highest percentage for the printable ratio. Okay. I'll probably move to the second demo. 1 second. Open what? VLC Media Player. Okay. So you see this? We moved the second volume. Okay. It asks you whether do you want to reuse the previous TX pin. Okay. Whether you want to manually advance. When I say manually advance, you have some certain keystrokes that you can utilize to increase the baud rate. But then, what's the whole point of the tool if you're not able to do it in an automated fashion, right? So what we are going to do is we are going to make use of the turbo mode, which means that okay, we're just going to look at the most common baud rates. Okay, and we do not want to look at the UART output whenever it is sending the data. So entire output we don't want to look at. We just want to look at whenever we get access to certain printable ratio, and what is the timeout between each baud rate sweep that we have, and what is the threshold. See, I'll tell you, in other tools the threshold is around 25 bytes, but here you can define your threshold. You give 100, so it is gonna get 100 bytes, and in that 100 bytes it will see what are the printable ASCII characters, and then into 100 divide by it, and into 100 will give me the printable ratio. Okay, and it tells you whether you're going to make use of the same adapter port that we have. Yes. And now is where you power cycle the device again, because when the device boots up is where it leaves, it gives you serial data out. Okay. Okay. Let me show you an example. See, for an example, over here, when it's probing a different baud rate, you can see the data. This is gibberish data. This is how the gibberish data looks. And if at all, if it identifies, okay, there are some amount of printable ratio in this, it will tell you, do you understand this, or do you want me to stop here and take this as the actual baud rate? But we know that, okay, this doesn't work. This is not your actual UART output. We tell go ahead with it. Then what it does is, then it will manually keep sweeping. Okay, it manually sweeps through multiple different baud rates. You see? Uh-huh. So now what happens is that after a point, if you see this, yes. So if you see this over here, when it identified the correct baud rate, when we gave the correct baud rate, out of 50 characters, 50 bytes of data that we captured, it has identified all 50 are printable ASCII. You can see the ASCII percentage over here. That is nothing but the printable ratio. And now from this one, we say that, okay, this we see that, okay, the baud rate is 115200, and what are the different baud rates that we have tried? 38. You have a different value. You can increment the value, and then we have identified, okay, this is the baud rate. Yeah. So that is all with this particular demo. 1 second. We have identified the baud rate right now. Okay. What is the next step? Okay. Sorry. Hello. Okay. I thought I just heard someone. Okay. Now, we know at what is the baud rate it is sending the data. We know which one is sending the data. We know at what baud rate it is sending the data. The next and most important step is where you have to identify the RX. RX of the target. As in now, this is the pin where you can send the data. See, in most of the devices, you can still get your listen to your data, but you won't be able to interface with it. Okay. What we will do is that we'll basically connect the TX of the adapter to the RX of the test input, and now we know your data frames. Okay, whether it is 8 and 1. 8 and 1 means that 8 data bits, no parity bit, and 1 stop bit. Okay, this is what it is. And then what are the things that you have to see? Here is where the OEMs have become very clever. They'll put up some pull up or a pull down resistor. Pull up resistor is where it's connected to your VCC. Pull up is where it's basically connected to your ground. That's the difference between a pull up and pull down in a very layman's term. And in this case is where you might need some expensive equipment like your stereo microscope, and you might have to perform little like microsurgeries, right? Now 0.007 mm wire, and if at all if this is not done correctly, you'll have your noise, and if your framing is not done correctly, then you won't be able to get your entire output. Okay, so I'll tell you a case study. What happened was that, 1 second. Hmm. Yeah, sorry. What happened is that in one of our RX bypass that we identified, this was the ground. This pin is connected to this. Okay, simple. But then here there was a 10 k ohm resistor. This one, I was trying to do this. We had our B-sides training the next day, and the day before is when we were actually checking our target device whether it is working. And that's when we came across, okay, these new devices have some mitigation in them. So we have to ensure that, okay, we bypass them. So there was a 10 k ohm resistor. This pictures and all were taken after we bypassed it because we didn't know that we could actually do it eventually. So now we know that this is connected to your ground. This 10 k ohm resistor is connected over here, which is nothing but pull down because it is connected to the ground over here. Okay, and these two pins are connected. There is no connectivity between this, and these two pins are connected. So we have identified, okay, this is your ground, this is your VCC, this is your TX. Now the next one remains your RX. But then you're not able to interface with your RX. You cannot send the data to RX. That is where you see this is the consequence of doing whenever your soldering is not good, right? If you see, I've broken the pad here entirely. And this is the 0.007 mm wire that I've soldered from this particular point to this particular point, which is nothing but what I did. I removed the 10 k ohm resistor from here, whatever I had. Um, uh, yeah, I removed the 10 k ohm resistor between these two points, and then I connected from this particular point to this particular point. So now there is no connectivity, and the pull down resistor is removed. Okay, uh, that's the RX bypass. So in our solution, what exactly we do is that we send a fixed sequence of tokens, uh, hyphen r hyphen in, to see what exactly output that we get. And there are some certain commands that you can send, help and etc. So we check out in this each stimulus window, that is nothing but a set of commands to see if at all if we get the output for whatever input that we have given. That's how we identify the RX. Okay. Now, oh, sorry, I'm supposed to take. Okay, one second. Multi-parameter. Yeah, just a minute. I think let me take out the demo for that. I think I've just kept it somewhere. Mm. Yeah. Okay. Okay. I won't be able to zoom in because I think there's some issue with this. So if you see, we connect. We have a baud rate that we've identified. We have a certain TX that we accept, and we generally say it's safer to connect your 4.7 kilo ohm resistor. But then in cases you don't need that, then we ask you to connect the TX that we have identified to your suspected RX, whatever you have, and then you power cycle that you once you power cycle the device, you wait for some time, because once the device power cycles, it takes a certain while for it to accept the commands. Okay, it sees whether have you sent the data. Then okay, then it asks you to connect to the next target pin, and you can select how many amount of pins that you want to check for this. Okay, yeah. And then you can see at a certain uh, whenever for a stimuli window, you can see we have got echo for 26, prompts given by 5. These are not your AI prompts, these are just a normal commands whatever I've sent, that is the prompt. And we identified that, okay, whenever I send a command to this particular a pin which I've called it as RRR, is where I'm actually getting the output, which means that, okay, this and that this is my RX. Okay, we have identified the RX. Everything's cool. Probably we have done everything. But what happens next? Okay, certain devices will have UART password. It will be protected with certain password. Uh, in this case is where you might have to perform UART brute forcing. UART brute forcing is a little bit tricky, I would say, because you're interfacing directly with the data that you have to send to a microcontroller, right? So in this case, what we are going to do is that we will define the I'll tell you about the solution as I'm running out of time. I'll just tell you what exactly the solution does. We can either mention the success parameter or the fail parameter, because sometimes you don't know what is the success parameter. You might know what is the failed attempt. So if you tell, okay, I just know the failed attempt, whenever it sees anything different from the failed attempt, is where it will flag. Okay, do you think that this is the correct one? It will stop you, and that's where you can tell, okay, no, whether it's a yes, go take with a yes, or just no, go with the second one. And also in some devices, before proceeding ahead, sometimes you might have to press your escape characters like your enter or your space bar, so that you get the prompt to enter the chat window. We also have a support for that. But then let me also tell you, currently the tool is only able to fuzz a single parameter. I'm still working on implementing multiple different parameters as well. Currently it's just one. So I think I'll just show you multi-parameter. No, 1 second. Yeah, I promise. These are the last demo here. Okay, you tell how many amount of parameters do you want to fuzz, and for each. No, I think I don't have to make use of a zoom for this. Okay. Then we tell so and you can also define when to actually give your username. What is the word list for your username? Okay, you can see that I've mentioned the word list here. And when do you have to go with the second regex? Whenever you identify the password is when you have to go for your password. Okay, you try this. Then it tells you, do you want to use the entire initial setup that we have? Okay, you do this. You can see it goes to different attempts, but then this module is still pending. But let me show you, for every detail that we made use of and for every project that we have, you can just directly make use of it to get access to a shell. For an example over here, I'll just skip through most of the things. You can see this. We are using the exact from modules 1 and 3, what and all details that you get. We use this particular details to get access to your UART. Okay, this is where you get access to a shell, and this is where you can actually see that, okay, whether is there any password protection. This is where I got all the details. Okay, what is my failure rejects, what is my success rejects. I don't know the success rejects, so I can't do much on it. So now the last demo for this particular talk would be that I basically configure saying that, okay, you'll have to use a single parameter first. Yeah, I think I'll just make it a VLC. Yeah. So you can see this. I do the same thing. I give so you can see my failure rejects is there. I don't know my success rejects. I'm just gonna leave that, and you can define the delay between the parameters that you need to have, and what are the escape characters that you might need, and it will start brute forcing on your UART port. Okay. And you can see this. Okay, whenever it identifies something a little different from a failure pattern, it will tell you, okay, this is what I've identified. Do you want me to go ahead with this? No. Okay. If that is not what it is, you can keep going ahead. And you can see this, whenever the credentials are correct, it will tell you, okay, this is what I've identified, this is what my captured details are, and this is what you can call it as your brute force or successful brute force, right? So coming down, that is what the entire tool does. We will be adding support to other different modules and all the very techniques that we use, and all the techniques that you see is that what we have learned from doing testing of multiple different devices, right? uh, yeah. And there are tools such as JTagulator. JTagulator is quite pricey, 249, but then the entire thing what I mentioned of where you'll have to switch between your RX and TX manually by your hand, that you do not have to do it in a JTagulator. That will easily be done by your electrical mapping, where it you can connect it to different pins, and it will identify, it will take each pin as RX and TX and see what exactly it does. And if you want to buy JTagulator, it's quite pricey. But then if you want to build it, You can build it. Like if you see, we have built it for probably 75 US dollars, almost a year back. You can also refer that. Okay. The tool. Okay. Now, the big question is that how exactly is our tool different? Is that there is no hardware dependency. The entire logic is on the software side, is on your host machine, and we focus on the printable ratio, and it's quite cheap. When I say it's quite cheap, so this is Indian rupees. 85 or 87 Indian rupees is what is $1. So you can see this. The cheapest one is around 58, which is almost one two third of your dollar price, and it works on this one. So now the hardware dependency is reduced. The logic sits entirely on a host machine, and we wanted to make it more accessible. So that is one. And credits to border.py. It has been a legend tool. It's probably around couple of years down the couple of years back, and then we call him the father of hardware hacking, Joy Grant. He's the one author for JTagulator. So yes, I've run out of time, but then if you have any questions, please feel free to ask, or else you can always reach out to me. Yeah, thank you.
Well, thank you for this amazing talk, which, yeah, 15 minutes over time, but that's no problem. I think many people enjoyed the talk.
Oh,
Uh,
I'm so glad. Yeah.
for the people who are watching, if you have any question or anything that pops in your mind that you want to ask, please place it in the chat, then we can answer them. I saw one question so far that's from Hoogie NL, and he's asking, do you use Binwalk or something similar?
Yeah, we use Binwalk. I think there's a V3 version of Binwalk. For firmware analysis, we use Binwalk, and we also make use of a tool called Emba.
Well, thank you for answering that question. I hope that is a satisfied answer for you, Hoogie NL. Yeah, I don't see any more questions so far. So I think we are done for now. I want to thank you, of course, again
Okay.
for the amazing talk and the time.
Yeah.
So for the people who are watching, big applause for the speaker. Uh, then we will go to a short break for 3-4 minutes, and then the next speaker will be ready talking about introduction to threat intelligence. So I hope to see you all with the next talk. And yeah, for our speaker, thank you again. Big applause again, and see you
Yes,
guys
thank you. No. Yeah.
a few minutes.
Apologies for the delay. Thank you, everyone. Cheers.
Silent nights online, hackers on the prowl. Keep your passwords tight, don't let your systems howl. Encrypted files safe, two factors quite a gift. Without it, you're a target, your data might just drift.
Firewalls, guard your precious slave.
Hackers try to sneak inside, but they can't ruin your day.
Firewalls, keep the threats away.
Clicking links without a thought is Santa's big no way. Deck the halls with updates, patch your software right. Ignore that sketchy email, it's phishing in plain sight. Malware's creeping closer like snowflakes on a breeze. Scan your drives for safety and keep your holidays with ease. Silent nights online, hackers on the the prowl. Keep your passwords tight, don't let your systems howl. Encrypted files safe, two factors quite a gift. Without it you're a target, your data might just drift.
Firewalls, firewalls, guard your precious slave.
Hackers try to sneak inside, but they can't ruin your day.
Firewalls, firewalls, keep the threats away.
Clicking links without a thought is Santa's big no way. Deck the halls with updates, patch your software right. Ignore that sketchy email, it's phishing in plain sight. Malware's creeping closer like snowflakes on a breeze. Scan your drives for safety and keep your holidays with ease. Silent nights online, hackers on the prowl. Keep your passwords tight, don't let.
Hey everyone, welcome back. The next speaker is already waiting. Well, you can see it in the introduction slide. Introduction to Threat Intelligence from Antonio Lara, if I say it correctly. I will no longer hold you guys up, so enjoy the next talk, and I give the word to the next speaker.
I have been attending to in the last years a few times, so glad to be back. I will talk today about threat intelligence, and I will try to just give a brief introduction because I know it's a topic that doesn't get much attention, and also it's not so in-depth from the technical point of view as other topics like the previous talk that we just watched. So I hope you get some ideas about what it is about, and you can start playing with it if you want. The entry barrier is not high. You don't need to be a super hacker, great programmer, but as I said, it doesn't get the spotlight, and many people don't even know it exists. I myself started to do some things at work recently about it, so I'm still learning, but I wanted to share some things with you and maybe discover something new that you didn't know before. All right, who am I? As Melvin said, I'm Antonio, I'm from Spain, and sometimes I use the name Doc in the cybersecurity community, so you may find some references to that name. I work as an application security engineer for the last several years. Now I'm working at a company called Ecosio. And as I say there, I like to automate stuff. So it's very useful to automate things everywhere. And as I will show or try to show, it's also useful in threat intelligence to automate things because by default, many things are very manual. Also, a disclaimer, I'm not a threat intelligence expert, but as I say there, who really is? In a world where threats are constantly evolving, it's hard to keep up the pace with the attackers, and that's what threat intelligence is about. So what you know today may be useless next week. So some examples. That is my LinkedIn. Feel free to reach if you want to ask any questions or just to connect. It's always nice to get in touch with fellow cybersecurity friends. All right, brief summary of what I'm going to discuss. First, a brief introduction with some concepts and definitions. We will discuss why threat intelligence is necessary and what it is. Then we'll look at some frameworks like the MITRE attack and something also called MITRE defense, which is not so well known. We'll go over the most well-known tools in this area, at least the free ones called MISP and OpenCTI. Then we'll talk about the importance of having a good inventory of assets to make threat intelligence useful and effective, and how we can automate that with APIs. All right, so let's get started. First of all, what is threat intelligence? Have a couple of definitions there. Threat intelligence is evidence-based knowledge about threats to assets. And I also say difference with pen testing and vulnerability scanning. So to give you some context, if you work in a big organization or any organization in general, but especially big software companies, which are targets of attacks, it's on the best interest of the company to know what threats from the outside world it's facing. And that's where threat intelligence comes. So there sometimes is a specific group that is only dedicated to threat intelligence. Some people, sometimes they are part of the security operations center, sometimes they are different people that only do this. But even if you don't know or don't hear much about them, they are there in the shadows. So next is, what is the difference with pen testing, vulnerability scanning, these kinds of things? Because pen testing and vulnerability scanning are also about detecting vulnerabilities and potentially threats to our systems. So when you rely on something like a vulnerability scanner or a pen tester, you know that they are going to be testing classical types of things like, I don't know, cross-site scripting, remote code execution, well, in different ways, file uploads, path traversals, all these kinds of well-known vulnerabilities. But most of the time, or always, they are not going to be testing the last attacks that have just been discovered by someone. They are not going to be testing the zero-day attacks, things that real attackers are using in the real world. We could argue that that's what Red Team does, but also, as I said before, this is a field in constant evolution. So even Red Teams could be outdated in their methods. And that's where threat intelligence comes into the picture. What threat intelligence analysts do is to follow the latest trends and to make those available to other people that will put them to the test, like Red Team operators, or even managers or directors who need to make decisions on where to spend money, things like that. So next here on the slide, you can see data versus intelligence. Data is simply raw data. It doesn't have any meaning or any context on itself. So for example, you could have a list of suspicious IPs, but it's only that, a list of IPs. If you don't know who is behind them, how they're being used, and many other things, could be hard to know if you are affected by them or your company. So that's also where intelligence analysts play a role, to understand if some information that comes up is relevant to the company, or we can forget about it. Because the truth is that there is lots of this information coming up every day, and there is a lot of fatigue if you try to keep up the pace and to analyze everything and decide what's relevant. So this is a process where you should automate everything that you can to avoid manual work, which could lead to errors or overlooking things. And yeah, that's why something like threat intelligence exists, precisely to give some value to those data. that are a huge amount. So threat intelligence is not for everyone, because here we are trying to understand the most advanced attackers, and not every company is on their sites. If you run a 10 employees company, probably big APT groups don't care about you. Still, there could be things like automated scanners or tools that could run some attacks against you, but you're probably not going to be the target of a nation state. So things like SAST, DAST, software composition analysis, pen test are things you should cover first. And then as your company gains some attention, some size, some relevance, it would be the time to worry about threat intelligence. But before, it doesn't make much sense. It's better to cover first more basic things that would protect you against the attacks that companies face all the time, like automated scanners, botnets, and things like that. Finally, threat intelligence can help to guide other security activities. I say here purple team, which is a general term to refer to many of the security activities. So yeah, instead of randomly trying to defend everything, it could help the company know what to prioritize first, depending on the threats they're facing. So, okay, there is no real consensus about everything on threat intelligence. It's a very malleable thing that everyone could do in the way that better fits their purposes, but this could be a generic diagram of the life cycle of threat intelligence. So here on step one, we would plan, we would set goals, we would say what we want to pay attention to, what we want to get from it, etc. Then we would go to the stage of collecting raw data. As I said, there is a distinction between raw data and useful data. The next step would be to normalize and sort and categorize all that data, because it can come from many different sources. And that means that the formats they are using could be very different. So it can be a bit chaotic to put all that data in the same format. Next, you do the analysis of that data. It's where the analysts look for patterns, look for things that could be relevant to the company, etc. And especially discard the vast majority of the data which are useless for most cases. You need to think that these sources of information are covering every kind of industry, every kind of system, both hardware, cloud, software, SaaS, software, open source, everything. So that's too much context. Everyone needs to pick only what is relevant for them. And then once you have identified what's useful, you would disseminate that data to the relevant parties. It could be a red team that it's going to be replicating those attacks before the real attackers do. Could be some blue team that is going to create some detection rules on their SOC. Could be some manager who is going to make some decisions. So it again depends. And lastly, there would be a feedback loop where you would analyze how this whole process went, what was well done, what was wrong, and keep refining it to make it more effective and streamlined. All right, we are talking here about data, but what kind of data? Threat intelligence feeds a lot from what is called indicators of compromise, or short IOC. That's a word you will hear a lot. And typically they come from forensic analysis coming from companies who have already been attacked. So imagine that some attackers on the internet compromise a company, are able to put some malicious payload on their website and exploit something and leak some data. And imagine that they are not very careful and leave some leftovers on the attacked systems, and then some forensic investigator can retrieve that. For example, the file they uploaded to gain a shell. So then there are platforms where all these artifacts are shared with a community of threat analysts. And that's how the whole community now learns that there is this actor using this thing, and they could also look for it in their systems to know if they got attacked. So for example, imagine they upload some agent that calls back to a command and control server, which is on a certain domain or IP. Those are indicators of compromise that everyone else can start looking for. Also, files, specific files with specific file names. Also, the hash of those files can be an indicator of compromise. Now, you can upload that to VirusTotal or check the hash and see, even if they renamed the file, if it would be the same virus or whatever. Also, sometimes, let's say someone is running one of these ransomwares on you, and they told you to pay to a certain, and there is a certain URL. That URL would also be. Also, if there is a credentials leak, those credentials could also be indicators of compromise. If you find that all of a sudden they are reusing some credentials that they shouldn't know. So everything you can think of that could be part of an attack could be an indicator of compromise if somehow it leaves some traces on your systems after being attacked. There is this organization called MITRE, and they have this MITRE attack matrix. It's pretty well known among red team operators, but to my surprise, many other security people don't know about it. So I'm going to briefly describe what it is. It's a collection of what they call tactics, techniques, and procedures that attackers use in the real world. So it allows you to classify what a certain tool or method achieves, what's their purpose. So this makes it easy both for threat analysts, for red teamers, blue teamers, to understand where a certain thing fits and what it achieves, and what are other alternatives, as well as who is using it to attack real businesses on the wild. So here, it's a pretty large matrix. It doesn't fit here on the width of my screen, but if you go there, you will see for yourselves. It's a pretty nice site. Here on the top, you have what they call tactics. It's these main categories like reconnaissance, resource development, which I really don't know what it is, initial access, execution. So they are the main stages that an attacker can go through, all the way to breaking into a system, doing some lateral movement, exfiltrating some information, etc. Inside each tactic, there are what are called techniques. So here you can see there are 11 techniques for initial access, 17 for execution, etc. So all of these are techniques. If you click on the links, it gives you more details. So for example, this is a technique, in this case for something related to cloud. It describes what the type of attack is, and then it gives you procedures, examples. Procedures are specific tools or specific methods. Doesn't always need to be a tool, could be a set of steps that someone can do manually. And those alternatives would allow someone to achieve that technique. So also there are some mitigations sometimes. Here you can find a lot of tools that maybe you didn't know. There is also a counterpart called MITRE Defend, which is not so well known, but also covers the different aspects of blue team, like detection and response to attacks. So in the attack matrix, there is also this section called groups, where you can find information about the real attackers in the real world from every country, although of course some countries attack more than others. And here you can see how sometimes, even if they have an identifier, they are known by different names. So here you can see a list in these associated groups of different names that they could have, or it seems like also sometimes they collaborate with other groups. So here you can see some correlations, and then it tells you some description of who they are. If you scroll down in this list, you will find some called APTs, and I don't know if I have a slide for that. Okay, APTs means advanced persistent threats. And they are the most advanced attackers that are active on the internet. So as far as I know, there is not a clear line that says where a group starts to be considered an APT, but in general, they have resources, they have several people working for them full-time, and sometimes they are supported by their state, like the government of their countries. So often they are not just some idealist hacktivists, but they are really working in the best interests of the country that pays them. Here I have a couple of trendy APTs that you often hear about in the news if you follow these things. And one is called Sandworm. It's from Russia. Well, I'm not going to make any super strong statements. People say it comes from Russia. I don't want to take any sides with any country or against anyone, because many of these things sometimes are based in investigations and suppositions, and sometimes not everything is super clear. But in these cases, it seems like it's clear who they work for. So this Sandworm, the name comes from the fact that in the source code that was recovered from their scripts, they used many references to the movie Dune. I haven't watched it, so I don't know, but I read some investigation where they name variables as characters from the movie. And then someone who was a nerd of that movie, who was investigating that, started to call Sandworm to them, because in the Dune movie, there are some giant sandworms. So that's where the name comes from. Then apparently they have been very involved in the whole WannaCry thing, some attacks against Ukraine, against infrastructure, using this NotPetya thing that, among other things, used Eternal Blue. So yeah, they have been very active in the last years. Then there is this Lazarus group from North Korea. And yeah, they do a lot of social engineering. So as you realize when you start to know more about these groups, not all of them are super advanced from the technical point of view. They just use some tools that they know well, and they are especially good at social engineering to make those tools more effective. But maybe not all of them are hardcore computer scientists. Here I have some links that I encourage you to read. The first one is a very nice research that they did in collaboration with any.run, which is a sandbox where you can run malware online so that it doesn't break anything. So they have this service where they spin up virtual machines, and then you can upload your malware and study what it does in a safe environment. So in collaboration with some guys, they prepared a bunch of fake virtual machines and interacted with the Lazarus hackers, trying to appear as victims, but they were recording everything they were doing. They were capturing video of what they were doing once they were inside of their computers, and to understand better how they work. It's a long read. It takes about an hour to go through the whole post. It's very long, but very recommended. It has some video captures of how they did things inside of the victim computers. And they trolled them a lot. It was funny to watch. These other two are 2 half-an-hour reports or documentaries by a Spanish YouTuber, which is quite popular here, but they are translated into English. You can change the language. One of the links is for Sandworm, another is for Lazarus. So it gives a very nice overview of who they are supposed to be, what they did in the past, etc. So all of them are very recommended, and you don't need a very deep technical knowledge to follow these links. All right, now I want to go into some more depth. First, I'm going to describe the most popular tool that there is out there for threat intelligence, and it's called MISP. And that stands for Malware Information Sharing Platform. Here you can find it, misp-project.org, and it's created by this organization called Circle, which is the Computer Incident Response Center of Luxembourg. It's an official organization working for their government, so they are to be trusted. You could say it's some kind of social media for threat analysts, where different people share indicators of compromise that they have gathered with the rest of the community, so that everyone is aware. So if you join this platform for free, you can profit from all that information, and you can also share your own indicators of compromise with others. And it's also useful to find some correlations between the findings of someone and the findings of someone else. For example, you may have found the IP that another guy found, but maybe you find a different file. So now both files could be relevant for a third person. Yeah, like you can read here on the last sentence, most of what we get from these shared feeds is irrelevant to us. We need to filter and match to our systems. There is a crazy amount of information coming up every day or every week. So you need to be able to find exactly what applies to you or to your company and forget about the rest. How to run this tool? It's pretty comfortable because there are already Docker composed files. It requires several services. It has some database, Postgres probably. It has some Redis server, and then the application itself. So it spins 4 or 5 containers, but with the Docker compose file is pretty simple. I found the second link is the official one, and the other is someone else who did their own version. And at some point I was trying to deploy to a Kubernetes cluster, and I found that it was easier to use the second one instead of the first one, but it really depends for your purposes. So yeah, it has some default credentials, and to deploy it on a cluster, if you're looking for Helm charts, there are no official ones so far. So what I used was this tool called Compose, and it worked pretty well with the first Docker Compose. So you give it a Docker Compose file, and it generates a set of Kubernetes resources, for those of you who know what Kubernetes is. And it worked right off the bat. With the other link, I wasn't able to. So if you're interested, I would go in that direction. There are some options which are paid and cost a lot of money, in my opinion. So they do the setup for you, they keep them updated. But honestly, for the money that you pay for those, you can hire an engineer to work full time and do that and many more things. Depending on where you live, of course. Yeah, there is a Python client from the official repository, which is useful because as everything related to this, I recommend automating the process, and that Python client makes things very easy instead of going manually through all the information, which is something that doesn't scale. There are many training online on YouTube from the creators themselves about how to use their software. But in my opinion, most of the videos say the same things. So if you watch a couple, then you have watched everything. And also many of them are not very contextualized. So you learn how to use the tool or what options are there, but then it's hard to know how to make that relevant for your specific case. So I hope that by the end of the talk, I have covered that a little bit, because of all the information that I could find online about threat intelligence, they take a very manual standpoint. They tell you how to use the graphical interface of tools, but not how to do it in practice. So it's like, yeah, the tool is very pretty, but I cannot spend 10 hours a day going through all the findings. So that's where automation comes into the picture. Yeah, here you can see some of the prices. So if you want to run a virtual instance of MISP in the official site, it costs 12,000 euros a year. And if you want your own dedicated hardware where your instance is not shared with anyone else's and with some crazy amount of hard drive, which I think you don't need, because most of the time, most of the things that you save are not relevant for your own case anyway, so you can just delete them. You would be paying 46,000 euros. All right, here I have a little video. I didn't want to risk trying it on live, so I recorded myself clicking around the platform so you can see what's inside. This is what you see when you first log in with the default credentials. And okay, I'm going to be pausing and resuming the video. Here, there is already things. The first time that you run it, this is empty, this events list. An event is something that someone creates to share with the community, and inside of an event, they can put any indicators of compromise that they want. So you can see that some events have a lot of things inside, others have very few, and even if you upload something, you can update it later and put more things inside. It's not like a one-step thing. There is a lot of them. As you can see here, you can put tags. There was one at the bottom which had a lot of tags of different colors, and that helps to organize things and to filter among the information. Here on this menu is where you can configure some things. I think if you use a non-admin account, you cannot see this menu, but here there is this feeds section, and that's where you configure where the sources of information come from. By default, there is this very long list, but all of them are disabled. So here I enabled this one only. You can enable as many as you want. And then if you click here on this button, fetch, you will start to get a lot of things, a lot of findings on the main events window. It can take a while, so you need to be patient. So you go to that list of events, that's where you get all these things. And if you click on the ID of any event, you see all the details. So you can see who created it. In this case, it's a test that I did myself. You can create things, but you don't need to share them with others. You can keep them to yourself on your own MISP instance, while you pull information from other people. There are different ways to visualize things. So there is this graphic view. In this case, I didn't put much, so this is pretty empty, but in other cases, you see a big network of connections here. Now let's go to another, which has more information pre-populated by someone else. So you can see here how they have identified many different threats, tactics, technique, procedures. Those are these codes, T, whatever, and if there is a dot, that means that it's one level deeper. So it's more specific about what software they're using. Here they have some of these connections. What they call galaxies here in MISP refers to attackers, so you can get more information of them. So that's another way to link information to other sources. And all of them with their own set of data here. And here you can see specific indicators of compromise that they attached to this specific event. So a bunch of IPs that someone determined were malicious, some websites, even some onion sites of the Tor network, all kinds of things. So now you could look for these things also on your systems to understand if you were attacked by the same issue. These blue boxes are called groups, and you can put many indicators of compromise inside one such box to indicate that they are related somehow. That's how you add a new event. There are some forms that you can fill with information. At first, you don't need to give many things to create the event, but then you can add more in the future. All right, so that was it for the MISP demo. I have some screenshots of what I explained, so I will skip them. Now we have the other tool called OpenCTI. I don't know this tool so well. I started to have a look at it, so I don't know all the details of what you can do with it, but it gives the feel or the vibes that it's something that you would look at first. It's like the big picture of things. It has a nicer UI, things are easier to find, and you can see more graphs and things that make more sense at a first glance. And also you can connect it to MISP to import things from MISP. So the ideal situation would be that you run both and you look first at this and then go to MISP if you need more details. It has these nice graphs that update in real time as new threads are added. It has this map, which unfortunately wasn't working for me. It should have colors depending on what countries are being most attacked, things like that. There must be something wrong with my setup, so something to play with. Then you can see these summaries. So you can see what groups are the most active. For example, here you see APT 40 is the most active lately. You can see what CVEs are the most active in the last 3 months. Most active malware, etc. So it gives you a pretty good idea of what's going on right now. What sectors are being more attacked? It's a bit small, but here it says government, energy, Russian Federation, aerospace. So yeah, tells you what the trends are in terms of attacks worldwide. So yeah, here, for example, we are looking at the aerospace sector, and you would see things that are more relevant for that. So there is this report here called Space Pirates, analyzing the tools So there seems to be a group called Space Pirates that are attacking maybe SpaceX, I don't know. And here in this report, someone has added this information. So on these labels, you can see some useful things for filtering information, some other references, what kind of things there is more information about, etc. In this case, for this particular one, there is not much information. You can see some references to Alien Vault. For this OpenCTI tool, you can connect it to many different sources of information. And in this case, I only use for this demo Alien Vault, which is like also a repository of a lot of threat intelligence things related. And I have this information here because Alien Vault sent me this information. If you add more sources, then you will see more different references. All right, there is these threat actors. I don't know exactly why I couldn't find anything here for the demo. Probably I didn't pull enough information, but here you would be able to search for the different groups and find more details about them. Here, in this case, Space Pirates, as we saw before. Yeah, there are lots of options. Probably not all of them are very useful here. And as I said before, most of the time, you wouldn't be manually reading all this information every day. Maybe you could have a quick glance in the morning, but if you want to do the real correlations to your assets, you would rely on some APIs, which OpenCTI also has. So here are descriptions of also different malware reported by Alien Vault. Other sources could give more information about them, but here you see how it has been added some more of these relationships. I don't know exactly what they are, but maybe there are different hashes. Maybe it's that the same thing is being used under different file names. Again, information about campaigns. And there is in this ingestion tab here where you configure what sources of information you're using. You can see some of them, and I manually added Alien Vault. I think it wasn't in this list by default. It gives other options. So you can see that all of them have a 0 number of messages except for Alien Vault, which sent to me 370,000. And yeah, a lot of information. Here at the top, you can see the speed at which you are downloading these things, this information. And yeah, you can see that I made some progress, but still there were many to come. And I'm pulling it real time. So this is the logs from Docker. You can see how fast it's getting more information. So that's why you need to filter things to make it relevant to your case. If not, you will just be flooded by useless information. Okay. Another source that is useful of information for attacks going on is the National Vulnerability Database. In this case, it's specialized in CVEs. This will be more well known for most of you, which are about vulnerabilities in software. And if you want to automate this, something more useful is the CPE code, which has all these different fields. It's a single line. I just put it in a multi-line here for it to be easier to read. But it tells you, for example, what product is affected, what version is affected. The problem with CVEs is that they don't follow a strict format. Someone finds something and they write whatever they want in free text. So that's hard to parse and correlate to your assets. but the CPEs are filled manually by people, by real people. I mean, by people that follow some standard, and it's much easier to correlate to your own thing. Here you can see a request that I made to the API of the MVD some time ago, and I looked for the word CPE on the findings. You can see a lot of matches here. More to the top means older, and there are no findings here. This means that it takes a few days for these people to populate manually the CPEs. So yeah, you will not get the real-time thing, but it will be much more precise for you to find things relevant to you using the CPE than the CVE if you want to automate this. And I encourage to automate this because there are from 50 to 100 new CVEs every day. So it's impossible to do it by hand. There is a post here that I wrote on Medium where I explain this whole thing and provide some Python code to make things easier. So if you want to check it out, it seems to be relatively popular. Other sources of threat intelligence. The most traditional one is to read security news, security blogs that every day tell you the most important things. Still, it's manual work. You could get the RSS feed and do some automation, maybe some AI, text parsing, etc. Look for things on the dark net, but that's very unreliable. Some of these sites sometimes disappear, so yeah. VirusTotal is good, also to check if things that are suspicious could be actually bad or not. And there are some other sites also if you want to search for leaked credentials. Now we come to the last part, which is the last piece of the puzzle, which is the inventory of assets. That's where you would gather, I will try to go fast, but that's where you put everything that your company has, so that when you correlate that to the threat intel sources, you know if something could affect you. There are different options, but I recommend going for a graph database because there you can make connections between different items. And if something is affected, you could quickly know what other things could also be affected. This is an example of what it would look like in Neo4j, which is a threat database that I'm using. I mean, a graph database. You have different nodes and you can put connections between them. So it's pretty useful for knowing what things relate to others. And for example, if a certain asset is affected, you could also quickly find the people who are responsible for fixing that instead of asking around. That can be useful in big companies with thousands of employees. Some ideas of things you want to include in your inventory: code repositories, dependencies that this code uses. You could argue that for that you have dependency scanners, but those run typically only when you push new code. So for something that is not so actively contributed, you could be missing some things there. Hardware, yeah. Cloud and physical infrastructure, employees' information and their devices, the software they have installed, what patches they have, databases your company uses, what domains, subdomains, etc. And what is important at first is that you develop some scripts that with some automation, some cron job would run every day to get new information and keep the inventory up to date. And finally, there is the correlation to the inventory. So you would now need to know what things from the threat intel sources apply to you. And for that, you need to use the APIs of all these things. Both MISP and OpenCTI have APIs that allow you to retrieve in plain text or in JSON files. All this information, then you would iterate through all of them and would check in your inventory if you have something relevant. For that, you need as much standardization as possible in the names. So things like the CPE codes help. But maybe you would miss some things, or you would need to guess some things. It's not perfect. I encourage, when you pull data from sources, it can be very slow. So for example, if you pull data from repositories, it takes some seconds to pull that repository. If you connect to human resources software to get employee information, etc. So it's good if you use threading to do that, and your computer isn't waiting for the first thing to retrieve all the repositories and then you jump to the next one. You can do your scripts such that you open several threads and pull all that information much quicker. In my research, Neo4j doesn't allow you to write in multi-thread. So if you do the first thing right, the second is what takes most of the time when there are lots of assets. Okay, not much more from here. I have here, but I'm short on time, so I'm not going to go in detail of a potential scenario of a real attack and how threat intel could be useful at different stages. So you guys want to take a screenshot or go back to the video later and read through it. Or if you have any questions, just ask me. Finally, threat intel can be used to make more effective as a set of different actions, security tasks that companies typically do by focusing them in what matters the most at a given time, and don't waste time with threats that are not so relevant. So it would help other teams to know what to focus on. And yeah, some conclusions here. Well, threat intelligence is about entities sharing information about attackers. There are lots of information and most of it is not relevant for our particular case, so we need to filter. Makes sense in companies which are already mature. You don't want to start doing this, first of all, only when you cover the main gaps in security. Not all attackers are very technically sophisticated technically. Many do social engineering, and threat intel also helps to demystify them and to treat them as what they really are, not like super magicians. All the information you can find is useless if you don't have a good inventory to correlate things to. Most of the information you don't care about. And you need to automate things to be effective. Most tutorials don't cover this, so I hope I made this point clear. Yeah, and it can help drive other activities. That would be all. I thank you for staying to the end. And yeah, any questions you have, either ask now or later, you can reach me on LinkedIn. So that's all. Thank you.
Yes. Yeah, thank you for the amazing talk, for the good demonstrations of the tooling you are using. I hope the people who were watching, they also enjoyed it. If you have any questions, as I said in the chat, please drop them in the chat, then we can answer them. So far, I don't see any questions popping up, but let's give them some time. Yeah, again, I want to thank you for your time and, of course, for the presentation. Hope you also enjoyed it.
Yeah, I learned some things doing it, so it's always good. And thanks again for the opportunity.
Of course, no problem. Yeah, I don't see any questions popping up so far, so I think it was all clear for the people who are watching. That's good. So I want one big applause for the speaker before we jump to the next one. And yeah, again, thank you for doing this talk and being here. And then we go into a short break of 2-3 minutes, and then we jump to the next speaker. He will talk about state of threat modeling, overview, and talks.
All right. Thank you. Bye.
See you at the next talk.
nights online, hackers on the prowl. Keep your passwords tight, don't let your systems howl. Encrypted files safe, two factors quite a gift. Without it you're a target, your data might just drift.
Firewalls, guard your precious slave.
Hackers try to sneak inside, but they can't ruin your day.
Firewalls, keep the threats away.
Clicking links without a thought is Santa's big no way. Deck the halls with updates, patch your software right. Ignore that sketchy email, it's phishing in plain sight. Malware's creeping closer like snowflakes on a breeze. Scan your drives for safety and keep your holidays with ease. Silent nights online, hackers on the prowl. Keep your passwords tight, don't let your systems howl. Encrypted files safe, two factors quite a gift. Without it you're a target, your data might just drift.
Firewalls, guard your precious slave.
Hackers try to sneak inside, but they can't ruin your day.
Firewalls, keep the threats away.
Clicking links without a thought is Santa's big no way. Deck the halls with updates, patch your software right. Ignore that sketchy email, it's phishing in plain sight. Malware's creeping closer like snowflakes on a breeze. Scan your drives for safety and keep your holidays with ease. Silent nights online, hackers on the prowl. Keep your passwords tight, don't let.
Hello everyone, welcome back. The next speaker is already waiting, as you can see on the screen, of course. The title will be State of Threat Modeling. Yeah, I will no longer hold you up, so I wish you all a great talk, and yeah, I give the word to the next speaker.
We'll be talking about the state of threat modeling. And I thought this is quite timely simply because this is in fact one of the very, very first engagements to actually figure out what organizations actually think about threat modeling, right? And unlike some other domains of security like AppSec or cloud security, threat modeling is one area which is, I think, perhaps a bit more misunderstood than some of the other domains, right? So let me tell you what I will be doing today, right? So I will be talking about a fairly high level view of threat modeling trends. When I say trends here, I don't refer so much to marketing trends as it refers to, say, how end users are looking at threat modeling, how we look at the tools, whether or not we find them useful, what questions are we trying to answer, this kind of stuff, right? And I will be basing this off a certain report, which I will share in a bit, right? Bear in mind that what I'm going to be talking about today is reflective pretty much of only earlier this year. And that, it's December already. So, next year, if you hear of like new trends, etc., don't blame me too much for saying that my talk is outdated, but rather what I'm going to be doing is some sort of a bit of a literature review. It might also be helpful for you to start thinking about this question on whether threat modeling is more of an offensive tradecraft or a defensive tradecraft. Okay, I asked this question because in some cases it is quite clear whether or not something is offensive or something is defensive. Like for example, pen testing, red teaming, these are obviously on the offensive side. Whereas if you talk about capabilities like DFIR, like SOC, these are clearly on the defensive side. So where does threat modeling lie? I will speak a bit about it, and that will give you an opportunity to think about these questions as well. Okay. Next, so why state of threat modeling and why talk about this? So as I mentioned, right, today, if you talk about threat modeling practices, there are lots and lots and lots of different frameworks. There really is no such thing today as a consolidated corpus of knowledge of threat modeling practices. What this means is that if you ask whether or not there is a certain, I would say, gold standard for this, the truth is that there isn't really one, right? There are perhaps threat modeling frameworks that are maybe a bit more famous than others, like Stride, right? But by no means is that considered an authoritative, I would say, threat modeling framework. When I was in Romania earlier this year, I actually managed to speak to one of the collaborators. They came up with the PASTA framework, which is another threat modeling framework, which is more focused on risk, right? And he also said that there are limitations in different threat modeling frameworks because the different threat modeling frameworks answer different security questions. And then earlier this year, I also had the privilege of speaking a bit to one of the collaborators who did something called Lindun, and Lindun is a privacy framework. So threat modeling is not only useful for security objectives, they can also be used to fulfill privacy objectives. And if you think about threat models from the perspective of attack trees, then you see that threat modeling can also be useful from the safety perspective, among other kinds of objectives that you want to think about, right? So think about this really as using a framework, a methodology to ask ourselves what can possibly go wrong in the system. Now, if you like the full report of the state of threat modeling, you can scan this QR code and you would be able to get a copy, or you can also hit me up on LinkedIn or some other means to be able to get your own copy as well. Now, having said that, so let's talk about what we're going to be doing today, right? I will be doing a fairly quick recap on threat modeling principles. I will not be going through too much on the frameworks because there are so many of them. One and two, today it's really just a bit of a literature review, not so much a threat modeling workshop that I typically do. If you want to find out more about the threat modeling workshops that I typically do, I do plenty of them in different capacities. So if you follow me, you will probably know some of these things I already do. Okay. Rather today, I want to focus on some of the observations in the state of threat modeling, and we talk about some few stories, my own personal experiences or analysis on why these survey results might be as such. And then there will be time for questions and answers as per previous years of Mystikcon. And I thought I would leave you with some questions as food for thought to think about, even if you may not have questions right now. Okay, next. Now let's do a bit of recap. What is threat modeling, and what we are trying to do is to really answer four very simple questions. We want to know what we are working on. We want to understand the scope of threat modeling. We want to understand what can go wrong, and this is usually the really, really fun part for threat modeling exercises. And then we are not paid just to figure out what can go wrong. We are paid to answer the questions on how we can set these right. And then lastly, we have to ask ourselves whether or not we do a good enough job. So these are what we call the 4 questions for threat modeling in the Threat Modeling Manifesto. And these are the very, very basic questions that I think you can ask if you ask somebody, okay, what do you do in a threat modeling exercise? So where does threat modeling fit into, say, a security program? Think of threat modeling as a means to prepare a team when they say want to develop a system or build some software, and think of it a bit as prophylaxis. There is a good saying, prevention is better than cure, and the threat modeling practice is really about finding out what things can go wrong before they actually do. In other words, we try to deal with these security vulnerabilities, these issues at the design phase, and from the architectural perspective, come up with solutions before we commit to a certain design, and then we realize that that design is in practice very difficult to secure, and that won't be very good. There's a nice saying when you talk about planning and preparation by Abraham Lincoln, that if you basically give 6 hours to somebody, well, in this case Abraham Lincoln, to chop a tree, he will spend the first 4 hours sharpening the axe. And what this really means is that when it comes to security, even when you talk about planning, when you talk about the security practice, we spend quite a lot of time doing some of these activities that are front-loaded, like for example, threat modeling, architecture review, so on and so forth. And at times it sounds quite laborious and sounds quite complex. But in my experience, this is almost always worth it for the teams, be it the architecture team, the software development team, infrastructure team, and so on and so forth. And the reason why is because sometimes when we do these threat modeling exercises, they thank us very much because we say we finally managed to get them to talk about a common set of, I would say, commonly agreed terms to then talk about the system. Okay, so next. As I mentioned, the threat modeling manifesto, and this is the team spot. What I mean by the team spot, if you look at the screenshot I have here, right, you see that these principles, there are 5 different principles. There's a systematic approach, informed creativity, various viewpoints, a useful toolkit, as well as to try to translate some things from theory into practice. So today's talk will focus on 2 points mainly. One is the various viewpoints as well as the theory into practice sections, though we will also talk a bit about systematic approach, or discover to our horror that, well, we are still quite far from the best principles that we have in the threat modeling manifesto. On the right, you also see that I gave a talk recently about threat modeling at DevCamp, which is a security conference that is held annually in Romania. And it was very nice, very good experience for me because it was actually my very first time speaking face-to-face in Europe, right? And so one of the audience members probably summarize my talk in a very succinct and I would say a very salient way, that security is never a one-person job. And I totally agree with this statement. And security can even be the role of people who are not even doing security as a primary role. So there could be that as a developer, it could be that as somebody managing the infrastructure, or say even the guy who reads emails for you, right? Security is everybody's responsibility. It's a team sport. Okay. Now that I'm done with this, let's talk about some interesting things about the state of threat modeling. So this survey was done across a few regions. Okay, as you can see, the geographic area. So this is very much confined to Europe and North America in terms of respondents. And I suspect one reason for this is that in Europe and in North America, the threat modeling practice is more, I would say, more mature, right? If you speak to some other parts of the world, like for example in Asia, then you would find that threat modeling is something that we are still trying to, I would say, influence stakeholders to take it seriously. Okay. You might also notice that when you talk about the industry spread of who actually answered the survey, we look at software, technology, and finance industries, and all these industries put together take up more than half of the respondents. We suspect one reason is simply because these guys can pay, and some other industries may not actually have the finances to even build up a mature security team. And if you don't have a mature security team, typically your first hire is not a threat modeler. Your typical first hire would be somebody who can actually set things right. So it could be a GRC guy, right, to make sure that policy and process is set right. And very quickly, your second hire would be somebody who can help you build up defenses. So typically a blue team person. A threat modeler does not really come into this picture so quickly. Okay. Then the size of firms that have responded. Majority of firms are big enough. They have more than 1,000 staff. And if you take a bit of a simple ratio, right, of, I would say, staff that work in the security function, it can be anything from 1 to say 5%, right? So at max 50 people in the security function, which is actually considered quite big and quite lucky if you have a firm who has that many number of people dedicated to the security function. In many cases, it is not true that this is the case, right? I learned actually just today that even in Singapore, we have a department called the Open Government Products Department. So what they do is they build software for the rest of government in a very quick way. I presume some agile methodologies. And they said they got their really, really first dedicated security hire only when they were 200 strong. And over in Dallas, where I work, I'm currently working with the digital factory in Singapore, and I'm pretty much what we jokingly call the security guy in Singapore, simply because Dallas digital factory is 50 strong. And if you look at the ratios, no surprise that I was pretty much their first dedicated hire for security. Okay. Next, I would also like to talk about the program methodology, maturity. And I think it is quite obvious that threat modeling is a fairly new practice. It is fairly new, and because of that, you see the number of years of experience that people have is generally not that high, right? Even across these big firms, you see that the majority of firms take a view that they are not really that mature yet. More than 80% of firms have under 4 years of experience when they talk about their program maturity. In other words, there is actually a lot to talk about. Okay. So maybe I won't bore you too much with stats, and let's talk about frameworks. And I like to talk about this slide quite a bit because while this was not actually one of the survey questions asked, this is an important slide because when you talk about threat modeling, different people will tell you very different answers. A good number of people, if you speak to them about threat modeling, will tell you that they Stride, right, which is the first threat modeling framework, and they are not wrong in the sense that the Stride is indeed one of the earliest threat modeling frameworks that is specifically focused on IT-related threats. Okay, but that is not the end to it all, right? I talked about Pasta, I talked about Lindun, and I talked about various other threat modeling frameworks, and I thought it'd be nice for me to also bring up why there are so many different frameworks. The reason why there are so many different frameworks is because these threat models answer very different questions. Stride, for example, answers how you might lose the security property based on a certain threat. Like, for example, if a threat gets actualized, it exploits a certain vulnerability, it results in a loss of a property, like, for example, confidentiality, integrity, or availability. In Stride, it expands to a few more categories, okay? So next, if you talk about something that you have to bring your threat model to, like for example, your threat model needs to be will have to be communicated to some other audiences. Then you would probably have to use a different way of explaining it, because if you try to explain how you lose, I would say you incur risk for the organization through the loss of confidentiality, chances are your board will go, I don't quite understand what you're trying to say, right? So you need a different framework. When Stride was first developed, they had a complementary risk framework called DREAD. Though nowadays, DREAD has fallen somewhat out of fashion. There are more, I would say, mature risk management frameworks like Pasta, Octave, Trike, right? And then there are also attacker-based methodologies. Basically, you frame yourself as the attacker and you ask yourself, how would the attacker eventually get to a certain outcome? Some examples of these threat modeling frameworks that deal with that, which I'm familiar with, include attack trees and persona non grata. So attack trees might be something that you are familiar with if you have prior experience in process engineering, whereby you do an exercise called a fault tree analysis. So in a fault tree analysis, what you do is that you find out what faults are critical to a system, will stop the system entirely, right? For example, if you stop a conveyor belt physically, then in a manufacturing plant that uses a conveyor belt, the manufacturing plant will likely stop, right? Then you start to figure out, you start to extend some leaves to see, okay, how do you stop a conveyor belt, right? Or you stop a conveyor belt through various means. The same goes to security, and you talk about attack trees from the perspective of security. You look at it from the perspective of identifying some sort of crown jewel that you find very, very important. The crown jewel can be a process or a piece of, or a data or some kind of data that you want to secure. Okay, and then based on that, you will break up into the various leaves to figure out what kind of attacks must the attacker do in order for the attacker to be able to attain a certain objective. Okay. And then based on that, you try to form a tree, and then you notice graphically, oh, if you stop something at a certain point, then that attack chain is not valid anymore, and you don't really need to focus on that. And then your management goes, okay, at least we now understand what we need to look at from a prioritization angle. Okay. Meaning looking at what to do first in terms of security mitigation. Well, persona non grata is another threat modeling framework, and this one is particularly, I would say, evil because it assumes everybody is evil. It assumes that everybody can become an attacker in some sort, either because they have evil intent or because of the nature of maybe the circumstance of their archetype. Archetype meaning some sort of, like, I would say, persona, right? And because of their persona, they engage in unwanted behavior. Classic example, you try to take on a persona of, say, a careless employee who opens every single email that you give him or her, right? So that's an example of a certain kind of attacker, because this guy, sorry, not a certain kind of attack, because, well, an attacker could exploit this kind of guy through a spear phishing attack, right? And then based on that, the attacker gains control of this employee's account, and from there starts a certain chain of attacks, right? So having said that, I briefly mentioned that you can classify these threat models into different categories, right? As I mentioned. And I hope it should be quite clear by now that no one methodology is the best methodology. In other words, no one threat modeling methodology is the threat modeling methodology that rules them all. But now you can't possibly become commenting every single thing, because if you try to do that, you simply spend your entire year threat modeling a small system, and that is very, very bad ROI, which is not good. So there comes the next question, which is quite natural, right? What threat modeling methodologies have become quite popular? Okay, so how should we interpret this? Okay, so there are three charts, okay? The chart on the left refers to threat modeling frameworks that respondents know, but they don't really use them. They don't really like them, and hence they say, nah, these threat modeling frameworks and methodologies don't really align with what they do. Okay, then you have threat modeling frameworks on your right-hand side, which are frameworks that I would say that end users, consultants, etc., will find themselves quite aligned with. Okay, so some interesting observations, as you can see here, right? I said Stripe was very, very popular. So if you do a bit of math, you realize that more than 3/4 of survey respondents are at least somewhat aligned with, I would say, threat modeling with using Stripe as a means of threat modeling. Okay, but having said that, you notice that there are some interesting, I would say, feedback or what they think are approaches that are useful for threat modeling. But I might also want to caution you that not all of these frameworks are in fact frameworks that you should use for threat modeling exercises. And I should explain this. If you're familiar with web application security, you will be quite familiar with the OWASP top 10. And if you're very familiar with the OWASP top 10, you will know that the OWASP top 10 consists of a set of top vulnerabilities where applications encounter. Right. Now, if you try to use that to do threat modeling, you realize quite quickly two issues. First, it is an application-based threat model, which means that you will confine this to threat modeling of web applications, and that's actually quite fine. If you have a web app that you need a threat model, then sure, by all means, you should use something that is contextualized to web applications. Now, the second problem, which is perhaps a bit more insidious, is this. Typically, the OWASP top 10 it's a consolidation of various vulnerability types. And I guess perhaps it's a bit of a constraint for OWASP themselves. When they were doing the OWASP list, you might notice that the top 10 vulnerability classes keep growing. And the way they keep growing is quite creative. How they keep growing is that they keep consolidating different vulnerability classes, and they started to put them together as a new top 10. And a great example for this is the vulnerability class called injections. And in this case, injections encompass lots of things, right? It can encompass SQL injections, it can encompass XML injections, it can encompass basically injections in any programming language. And if you're not careful, you might see prompt injection there soon as well. The risk behind this is that you realize that you are looking out for input parameter, input fields, etc., where you can perform these kind of attacks. And I mean, that's great, but I'm not really sure if that counts personally as I would say, a full-fledged threat model of an application, because it is perhaps a bit more helpful to look at it, I would say, with a more holistic lens, which is something like what MITRE KPAC does. Okay, but that's not really to this OWASP, because OWASP is great in terms of improving our understanding of vulnerabilities. And I myself also use OWASP in trying to explain to people web application vulnerabilities, Gen AI vulnerabilities, so on and so forth. Perhaps one very interesting thing, as you can see, is the four-question framework. And it's very interesting why I call them the show stack four-question framework. Because actually, if you look at the threat modeling manifesto, this is actually quite agnostic. So the four questions that are being asked are agnostic to people, because, well, it's just simply four questions to help you scope how you should do your threat model. And this is quite popular. So I think one trend you might see here is that the simpler the threat modeling framework, the likelier you will see featured. Okay. Whereas you see something like attack tree, which is quite complicated, you notice it is something that people don't really like. Perhaps one thing that is of note, of interest, is MITRE Atlas. And MITRE Atlas is interesting because MITRE Atlas is actually a threat modeling taxonomy for Gen AI systems. Gen AI is everywhere now, like it or not. At some point, somebody will tell you to deploy a Gen AI system if it is not already being done, right? Because of that, we have to understand what can possibly go wrong. So MITRE Atlas has become more and more popular simply because it is a simple starting point for this. If you do look into AI threat modeling, which is something that I'll be quite happy to engage with you after this talk, we have been noticing that there have been more frameworks like AI Defend, I think written by somebody who works in JP Morgan, if I'm not wrong. I personally follow his work myself, so I find it quite interesting. There was Project Guardrails a few years ago, and there is also an interesting threat modeling framework called Maestro, written by somebody, I think he is the founder of distributedapps.ai. Okay, so this is just to show you what people find popular, what people find not so popular. Okay, let's move on. So, key findings, what tools are used and what tools are most favorable. And I thought it would be very nice to talk about this also, because this is a question that keeps coming up every threat modeling workshop that I do. Oh, what tool is the best tool? What tool is actually useful? What tool do you recommend a first timer? What tool do you recommend for enterprise, right? What is perhaps a bit surprising to us is that we realize that respondents don't really use tools that are out there, even though there are many tools out there in the market. This 35% figure, I think, came about, I can't remember how it came about in the survey, but I think it came about from the perspective that they ask whether or not they use the tool, and then they ask whether the organization uses the tool. Okay, because the sample size though for this is not very big, I think we cannot really draw too many conclusions for this. But some conclusions we can draw is that some tools, as you can see here, look fairly popular. Like for example, OWASP Threat Dragon, Threat Modeling Tool 7, Iris Risk has their own tool as well. And the idea is that some of these tools are familiar, at least in some people's minds. Now, of course, there are some caveats to this. And the caveats that come to this are that some of these tools are actually not really enterprise-grade tools. I personally use OWASP Threat Dragon to teach, and I find it very good for teaching, but it doesn't scale very well. Okay. Now, I would like to then talk about supporting tools. So threat modeling tools, such as those just now, help you to enumerate threats, and they help you deal with, say, for example, drawing the DFD, trying to highlight some threats, maybe helping you monitor some of these threats and helping you to eventually produce this in some sort of report. Okay, but not everybody uses all these features. And so there is also the question of what are the common supporting tools that people use alongside their threat modeling exercise. You can see here that there are lots of different supporting tools being used, but you'll notice that only 73% of people actually use a drawing tool, which is quite surprising to me because many of these tools don't really, I would say, draw out the DFDs in ways that people really like them. So typically, we like to draw them using some sort of tool and then translate it into a more dedicated threat modeling tool. So one must wonder what kind of tools they might be using to draw their diagrams. Because in some cases, it might be the case that they're using something like PowerPoint and they don't even consider that a drawing tool. Okay. Quite a number of people use Jira, and that's fine. I personally did a threat modeling exercise recently where what we did was that we did a threat modeling exercise using a mirror board, and then after that we assigned tickets to different risk owners using Jira. So I think that's fine. What is very interesting is also the differences in use of a document editor and spreadsheet. And we figure that these two items are there because you eventually need to present these findings to some sort of management somewhere. So it is also not clear, to us at least, what is considered a preferred reporting mechanism. Okay. So this is some conclusion that we also could get from the the state of threat modeling survey. Now, perhaps the next part, right? Are we satisfied with the tools? Because at the end of the day, if you're not satisfied with the tools, then perhaps someone should come in to develop improvements to these tools. Maybe someone should come up with some sort of open standard. Maybe somebody can come and say, "Hey, I would say, new way of demonstrating how threat modeling should be done." Okay, and then this would essentially help kickstart a new conversation or improve the existing conversation that we have when it comes to threat modeling, right? As you can tell, there is probably some scope for this. Only about a third's really satisfied. One third of people are a bit neutral, and one third of people are just not very satisfied. There might be many reasons for this. We don't really know all of the reasons. But when I was speaking to some people, some of the common constraints include a few of these, right? One, the DFDs are very hard to draw because not many people really understand DFDs. And when you try to turn architecture diagrams, and you try to turn enterprise diagrams into DFDs, you see that you sometimes realize that the people who drew the diagrams don't really understand the diagrams either, right? And so it's a lot of back and forth to figure out what's the single source of truth that can describe this system down to the level of that where you can define what is a data store, what is a process, what's an external entity that interacts with the process, as well as the data flow across these elements, okay? So this is one factor that I guess makes people not quite satisfied. The other factor that doesn't make people very satisfied with threat modeling tools today is that it's actually quite tedious to convert from diagrams to then enumerate threats or to say add in user context. There were some startups in Singapore that tried to build threat modeling tools that basically had some LLMs to translate certain user requirements into data flows or into some sort of sketches on what they want to do for threat modeling. Unfortunately, I got to say that these tools have not always been fantastic. I personally tried some LLMs myself when it comes to threat modeling, and they are quite good when it comes to brainstorming, but they're really not good if you want to have some sort of precise answers. And if you say, okay, sure, we can do some prompt engineering on this so that we can reliably query the LLM, we realize that the prompt engineering, number one, is not very economical. And two, as the models change, we realize that the ways to optimize these models' answers to us can change too. And that makes it very difficult because that makes the process, I would say, not very repeatable. And once it's not very repeatable, you run that risk that you basically introduce extra security tooling. And once you introduce extra security tooling that not everybody understands or use or can integrate with, you quickly realize that you translate a threat modeling problem into a CISO problem. That being that there are so many tools that people don't really like to use them because they feel that the more you use them, the more problems they encounter because there are more tickets to deal with, etc. In other words, the conclusion you get from this kind of user experience is that that sucks because the tool doesn't integrate very well. Okay. Next. So, how many threat models do respondents generate yearly? And this is also quite interesting. Why this is quite interesting, at least to me, is because no matter the size of the enterprise, we noticed that they all consistently generated almost similar number of threat models. Okay, so remember at the start we said that most of the companies were big companies, right? Many of them, about 70% were of this sort. But if you look at the number of threat models that get generated, more than half of these firms, right, generate between 10 to 100 threat models. Okay, only 1/5 of firms generate more than 100 threat models per year. So if you think about it, this is actually quite interesting. And why it's quite interesting is this. So if you have, say, a very, very large firm, let's just say a really, really large bank or something, right? A bank has lots of IT systems. A bank has lots of front-facing customer systems. Like, for example, the bank app, maybe they have an investment platform, so there's a separate application. They may have a chatbot that may be a different application that's embedded within the bank infrastructure itself, right? Oh, the bank probably also has some sort of administrative application to deal with, say, the customer app. So maybe they build a separate app by itself. Maybe it's a separate app altogether, right? I remember even for my local bank, they even have an app that helps administrators deal with certain multiple means of MFA. So they had different MFA mechanisms. And because of these different MFA mechanisms, they basically had an app that enables you to basically authenticate in a slightly different way. And why I understood this was because we had to do a pen test, and I remember seeing, oh, that's interesting functionality that we never really expected. Okay, so that's that. Now there's also applications that are not what you see in the front end, right? So there are backend applications, there's HR applications, there are finance applications, payroll. All these applications will be part of some sort of attack server somewhere. And then you will have some sort of portal. They will have VPN connectivity, perhaps for the employees to access corporate intranet. Or if they don't although if they don't use VPN, then somebody has to define what can be accessed to, say, a SASE solution, right? So now if you think about it, there are so many systems and subsystems, and the number of threat models that get generated annually is actually not that many, and more than half of the firms only generate between 10 to 100 threat models. So two reasons we think might be the case. One reason that might be the case is that if you look at security teams, they are already quite lean, right? So when you employ security professionals, you employ them to solve problems, and we like to call them type 1 problems. Basically, they are firefighting kind of problems, like, for example, ops, right? If you have somebody to deal with your SOC, you have somebody that deals with IR. These are examples of roles whereby we call the first line roles, right? Given the size of your firm. So usually what happens is that operations will scale, and usually it doesn't scale linearly. It's actually does have a bit of exponentiation to it because as your infrastructure gets bigger, you realize that you have to deal with integration. And with integration, these don't scale linearly, these scale exponentially. Or at least polynomially. Okay. Now you might then think, okay, so what do you threat model, right? And then the answer is that they probably threat model slightly different things. Perhaps in a smaller firm, you might try, or say if you're dealing with software development, maybe you develop games or you develop software. you might threat model more at the application level. You might threat model more low-level stuff. Whereas if you are, say, looking at a typical business like a e-commerce company, etc., you deal with infrastructure, quite a lot of your threat models will be more along the lines of system level threat models. And because of that, you might favor different kind of threat modeling frameworks, which also explains why you might see certain separations or preferences when you talk about threat modeling frameworks, because of the fact that different threat modeling frameworks will solve different use cases. Okay. Let's talk about difficulties. And I think difficulties is also something that is where we all come back to earth. We always like to tell you about best practices. Unfortunately, like it or not, when we try to do best practices, we always face difficulties with this. So the survey also mentioned about top 10 challenges in threat modeling by frequency. I have also mentioned some of the, I would say, examples where you notice difficulties in like scaling, right? Motivation, like if they have to deal with compliance every year, you will deal with compliance before you deal with threat models, right? And of course, other business priorities is also a big reason why you might find this as a challenge. As you can see, about half of the respondents think that you need to look at mitigation work and prioritize it against other business priorities. And if you then take a step back, you then come to the conclusion that it's a threat model that provides extra work for everyone else. And if that provides extra work for everyone else, it's usually one of these favorite activities for people to deprioritize, right? Okay, but I thought what is probably very important is to highlight that the top issue remains that you basically are unable to get in the list of system components, data flows, and assets. And then if you can't even get there, then let's not even talk about incomplete details of the system component, data flow, assets. So that's the first row and the fourth row of the key findings section, okay? And what's interesting is that up to now, this is still a problem, even though people have been talking about all sorts of things in application security, like, enumerating your SBOT, right? But as you can tell, this still remains a problem, right? We still can't really identify the system components or data flows that people use, right? So that's an issue. Now, I think it is also helpful to, I would say, highlight that I mentioned about some of these points earlier on in different ways, right? Like, for example, if you talk about getting the team to come together to harmonize on threat modeling exercise, you will come to the conclusion that in some cases, the threat modeler becomes the guy that is running the team bonding exercise. Simply because these guys normally don't come together. Then when they come together, you realize that, oh, actually, we learn more about the different guys. Oh, this guy does this guy does that. And if you think about that, that can actually be a problem because you then realize that the different, I would say, team members, right, are operating so differently that you begin to wonder how the system will be when you try to integrate it. And if that's not comforting enough, well, I would think that at least the threat modeler can say they are doing their part in trying to bring people together. Okay, so how will this change with AI? Haha, this is going to be a very, very tricky question. And this is going to be a very tricky question because, well, with AI, we are operating in many organizations from a very black box basis. Somebody can say, oh, I incorporate a chatbot, right? This chatbot runs some LLM or maybe some series of LLMs. How is it being run? Oh, we don't know. We got a third party to do this, right? And then, okay, what's inside? Nobody knows. Or maybe say, let's be a bit more adventurous. You have an agentic AI system because everybody claims they're selling you an agentic AI system today, right? So of course, as a good security guy, you ask what's in the agentic AI system. Can you explain to me the workflow? Can you explain to me how the agents are like? I will, ask you important questions on, say, okay, can you explain to me how you control these agents to make sure that they only access things they're supposed to? And you come to the conclusion that whoops, we don't really have good answer to it either. And that is also the reason why, if you talk about the industry conversation on threat modeling, there have been quite a number of AI threat modeling frameworks being developed simply because the typical old school threat modeling frameworks just don't seem to be as fit for purpose anymore. And that is a concern, actually. Okay, so without further ado, let me just jump into some thoughts that you may have. And once I talk about some of these thoughts that we may have, I leave the floor open to questions. Okay, so some of these questions that you may think of, right? So today I presented probably the first threat modeling kind of, I think, survey that you can find. And because of that, I am sure you will have many thoughts about this, right? Do these sentiments align with what you see in your organization? That's one question that you can think of. Another question that you can think of is whether or not these are expectations that you notice, maybe because threat modeling may be more mature or less mature in your country or organization. There may be certain reporting requirements that we didn't really talk about, etc. Right? First question. You may have certain thoughts about this, and I encourage you to think through some of these data points. And I think also quite importantly, which I also see in the chat, about alignment, because I think there's already a question in the chat on alignment of threat modeling with developers. Okay, I will answer that question quite soon. Okay, and what we must do to obtain buy-in. And I will also use the opportunity to answer the question that I see on the chat. Okay, so with that, I end my talk. And with that, I will take this opportunity to answer that question on the chat. And while doing so, you are free to ask questions. All right. So I just read the question. Okay. Zerdinator asked, do you have tips to get developers more engaged in threat modeling and want to participate more actively in the process? What do you think of games like Elevation or Privilege or Cornucopia? Okay, good question. I have personally played Elevation or Privilege before, as part of this group called the Threat Modeling Connect, which I co-lead the Singapore chapter with another good friend of mine. I have tried this out with some of the other Threat Modeling Connect chapter leads and participants. Elevation of Privilege is very much tied to Strike. And the reason why it's tied to Strike is because that I think was the creation of Adam Shostak. I think so. Or at least Adam Shostak was very instrumental in that. Because of that, that is very, very much tied to a certain threat modeling framework. If you are doing threat modeling with that framework in mind, then I think it's not a bad tool to get people excited. And the reason why is because you really want people to go through the threat modeling process and I would say find it enriching and find it at least something they find fun. And why that's so important is because there are already so many security activities that we impose on people to do, and we don't really need to impose yet another one. We honestly don't need to assign yet more Jira tickets to people. Having said that, I know I'm making fun of Jira tickets all the time. Having said that, it is important to frame security in a way that we're actually trying to help other members of the team. So when you talk about developers, I thought it was useful to also talk about how developers think. One thought that came about was a certain ex-CISO, I think, of Netflix, where he talked about threat modeling, and he took a view that you could threat model certain ways of work and certain ways of designing applications, and then based on that, you design guardrails around them. So if the developers obey these guardrails, then what happens is that, we would do a less rigorous exercise, maybe just a risk analysis, as opposed to a full-fledged threat model, simply because you already have a certain minimum baseline of security that we can understand, right? So that is one way to go about it. It is also important to get people involved as early in the process as possible, because you don't really want them to commit to more costly changes only when the security guy comes in to say, oh, by the way, something that we did 3 months ago, we realized that this is really not the right approach. So can you please change this? And then you realize that when you say change this, it involves changing significant amounts of the code base. And that keeps no developer happy. So always put yourself in the position that you want to sort out issues early. You want to be involved in the architecture design early, so that when I would say it comes to actually building the system, you can actually sell the perspective that you are helping everyone save time. So I hope that answers at least some part of the question. Yep. So any other questions? So if Melvin, if you want to ask questions, feel free to.
Yeah, thank you for the amazing presentation and talk. Well, yeah, there's one question, but you already kindly answered it, so you was in front of me.
Yes.
Yeah, as I said in the chat, for those people who are watching, if you have any questions, then now is the time to drop them. We have 10 more minutes, so yeah, you can just place your questions in the chat. We have time to answer them. Yeah, and again, in the meantime, a big applause for the speaker for the presentation and the talk.
Thank you. Thank you so much.
I don't see any questions popping up so far.
No, me neither.
Yeah, I think it was very clear for them. And else, if you have questions who might pop up later that you think, oh, damn it, I had to ask this, you can always reach out to him on Telegram or LinkedIn. He's very active, so shouldn't be long before you have your answer there. If you want to ask anything that pops up your mind. Yeah, I don't still see any questions, so I think we can go over to the finishing. So I want to give one more a big applause for the speaker. Yeah, and again, of course, thank you for the talk and presentation and your time. Yeah, and I think we go in a short break for about 5 to 10 minutes, and then I hope to see you all at the next talk, which will be Inside Threat Human Element in Cybersecurity. It will not be the mostly Android. There are some shifting in times. So I hope to see you guys at the next talk. And again, say thanks to Donovan for this presentation.
Thank you.
Silent nights online, hackers on the prowl. Keep your passwords tight, don't let your systems howl. Encrypted files safe, two factors quite a gift. Without it you're a target, your data might just drift.
Firewalls, guard your precious slave.
Hackers try to sneak inside, but they can't ruin your day.
Firewalls, keep the threats away.
Clicking links without a thought is Santa's big no way. Deck the halls with updates, patch your software right. Ignore that sketchy email, it's phishing in plain sight. Malware's creeping closer like snowflakes on a breeze. Scan your drives for safety and keep your holidays with ease. Silent nights online, hackers on the prowl. Keep your passwords tight, don't let your systems howl. Encrypted files safe, two factors quite a gift. Without it, you're a target. Your data might just drift.
Firewalls, firewalls, guard your precious slave.
Hackers try to sneak inside, but they can't ruin your day.
Firewalls, firewalls, keep the threats away.
Clicking links without a thought is Santa's big no way. Deck the halls with updates, patch your software right. Ignore that sketchy email, it's phishing in plain sight. Malware's creeping closer like snowflakes on a breeze. Scan your drives for safety and keep your holidays with ease. Silent nights online, hackers on the prowl. Keep your passwords tight, don't let your systems howl. Encrypted files safe, two factors quite a gift. Without it, you're a target. Your data might just drift.
Firewalls, firewalls, guard your precious slave.
Hackers try to sneak inside, but they can't ruin your day.
Firewalls, firewalls, keep the threats away.
Clicking links without a thought is Santa's big no way. Deck the halls with updates, patch your software right. Ignore that sketchy email, it's phishing in plain sight. Malware's creeping closer like snowflakes on a breeze. Scan your drives for safety and keep your holidays with ease.
Hello everyone, welcome back. We are ready for the next speaker, who's going to talk about insider threat, human element in cybersecurity by Pavel Georgiev, if I announce it correctly. I'm not going to hold you guys any longer. I see one question about the jingle rocks. I made it kindly with AI and some, how do you say it, some jingle in the background. So who's the singer? I have no idea. It's probably Mr. ChatGPT or Mistress ChatGPT. I don't know. But I will go over to the next talk. So hope you all enjoyed, and give a warm applause for the next speaker.
Okay, everyone. My name is Pavel Georgiev, and I'm going to talk about insider threat, human element in cybersecurity. And thank you for having me here. And till now, we saw a few very interesting, very technical talks, but my presentation will not be so technical. But I hope it will be interesting for you how to deal with the human vulnerabilities which are providing threats in cybersecurity, and how to build a so-called human firewall, because my opinion is that human is not the weakest element of the cybersecurity. It can become the strongest and most valuable defense for cybersecurity threats if it's managed well, if it's trained well. So let's dive in this. Okay. Yes. A few words about me. I'm from Bulgaria. In my daily job, I'm working in one of the biggest Bulgarian banks as a cybersecurity expert. Also, I'm a lecturer in three universities, guest lecturer, and I have some side activities on my batch as a vice president in Bulgarian Bulgarian Association of Cyber Certified Ethical Hackers, also vice chairman of Bulgarian Foundation, member of Hacker BG. This is our local community of hackers, part of Cybersecurity Challenge Bulgaria team for steering committee or from part of the organizers of the team. And more valuable for me is the founder and organizer of Cybersecurity Talks Bulgaria. These are monthly events, monthly meetups where we gather a local community and talk about different topics as we see on today's conference, and topics about information security, cyber security, cyber and security at all. And yes, this I'm doing for 3.5 years already. So yes, it's nice to have. And my newest initiative, where I'm a co-founder of Cyber for Kids. This is a platform where colleagues from the cyber community here locally in Bulgaria can join together and can go to schools to talk with students in schools about the internet safety, to provide them knowledge, to share experience, and to guide them in the digital area. So I'll speak about this initiative maybe at the end. So thank you very much for having me here, and let's start with the significant part of the presentation. Weakest element. Why people are always treated as weakest link in the cybersecurity? You can see some numbers about 68% of the breaches are featured by human element, with people being involved in error or privilege misuse or stolen credentials, social engineering, or no matter what. And this is from Verizon data breach investigation report for the last year. Also, 92% of the malware has been delivered via email, via phishing, and 24% of the breaches are used stolen credentials. This is lower than it was in 2023, but still very, very high number. And the weakest element in the cybersecurity, this is not something from me, this is not something from colleagues here locally in Bulgaria, but this is a thought of Taylor Swift in DEF CON 2011. So let's see, is it possible to transfer the human element from the weakest link to the strongest and most valuable defense of the cyber threats? In my presentation, you see these guys as this is the national rugby team of New Zealand, and this guys, the name of the team is All Blacks. So they are representing in my presentations the bad guys, the bad actors in the cyber field. And the idea to bring them here is because they are, as you see in the picture, they are performing their national people of Maori dance before every traditional dance, before every fight, before every match, to scare and to provide strength and to scare the opponent. So this is the reason that I'm having these guys here in the presentation for representing the bad guys, the bad actors in the cyber field. So, what are the cyber tactics on human? The cyber field, the cyber uh, category of threat of tactics related to humans is, as you know, called social engineering. The idea here is that bad actors trick people, manipulate the victims to give them, to provide them confidential information, to guide, to provide them an access or additional information about about themselves, about the company they work, about the uh, um, something that they have, for example, credit cards, and they're taking advantage of the users, the victims' personal weaknesses. As you know, or maybe not know, there are three types of social engineering: human-based, computer-based, and mobile-based. Human-based is the type of social engineering that combines the tactics of direct manipulation of the humans. That means pretexting, impersonation, direct contact, human to human. Computer-based social engineering combines the tactics that hackers or bad actors are using computer to manipulate, to trick the users. And the mobile-based social engineering is combining the tactics, the actions, and the uh, uh, yes, the tactics to trick the people, to trick the humans using the mobile phones. So again, we need to know what are these tactics. We need to try to classify them in order to be more efficient of dealing with all these techniques and tactics to our employees. Next twice we'll see some definitions, and first definition is about the insider. Insider is any person who has or had access, authorized access or knowledge about the organizational resources, including personnel, facilities, information, equipment, networks, procedures, systems, doesn't matter, anything about the company. There are some more information about this. This is person who has the organization trust. These are employees. These are some external vendors. This is a person given a badge or access to a device, to the company itself, person who is whom our organization has provided a computer and network access. Also person who develops the organization products, services, and provide some technical support, and also person who has knowledge about the organizational foundations, including pricing, costs, strength, weaknesses, and so on. So this is the classification, the definition provided by American Cybersecurity Organization, CISA. So what is the definition of insider threat? Insider threat is a potential for insider to use its or her or his authorized access or a specific understanding of the organization to harm this organization, to do malicious things, and um, um, to harm, yes, to harm the organization. There are three top types of threat actors. These are usually the regular employees of the company, Third parties, this is hard body rented or internal resources hired to help the organization, and privileged users. What is the cost? What is the cost of insider threat? As you can see on the slide, the cost evolves every year, and for the last year it was $17.4 million. The cost actually can be hidden because sometimes you will not understand, you will not realize that there is an insider threat in your company. As you see on the bottom, there is a report of Phenomenon Institute, where most of the companies, 66% of the companies, detects and contain the insider threat incident in more than 60 days after the incident itself. So sometimes even it's not possible, or we're not aware that there is an insider which is who is doing malicious things or data exfil from our organization. Another stats about the insider threat across the industries. So the healthcare and the finance are the top industries where insider threat is spotted, reported, and there is some bad actions in these sectors. What is the motives of the insider threats? As you see, there is the financial motives is the essential of the for the insider threat. Also, grudge, also espionage is in the list of top 6 of motivations of the insider threat breaches. Why do companies, organizations underestimate the insider threats? This is Isaka blog post which describes the topic, but usually the companies are focused on the unknowing instead of knowing factors, because as human beings we are afraid from the unknowing effects of unknowing threats, and we are preparing for them. Also, the insider threat has inherent trust of the organizations. These are usually already employees which are hired in the organization. There is trust inherent on them, so we believe that they are going to do the job they're employed. So we may not even recognize their bad actions. Miscalculation of the risk is also one of the reasons of underestimated insider threat. Some of the organizations miscalculated the risk for the insider threat instead of external threats of the organization. Also, budget issues are causing problems, are the main problem about the insider threat at all. My next slides are based on Robert Sell, the founder of TraceSwap's categorization. Robert is providing 3 different categories of insider threat. This categorization can help us to be more specific on actions and to be more specific on how to deal with these types of these categories. 3 categories, 6 types, and also there is a categorization of is there is an intent in the insider threat to harm the company? Is the insider threat triggered to to harm the company, to do the bad things, and also how sophisticated is to do these malicious things, and how sophisticated is to detect them. As you can see, the sophistication is growing with the type of and category of the insider threat. So let's start with this categorization. First category is are pawns. Two types. These are the least sophisticated, most common category of insider threat. Usually innocent victims or staff that don't care or may regret or may not even notice that are doing bad things for the company. And the first type of this category is accidental. There is no intent to harm in these people. There is no intent to harm the company. Often unknowing victim of external manipulation. These are usually normal employees who clicked on phishing link or provided information for the company organizational part, for the company procedures, or even provide some company information to bad actors. Often these people, these employees has poor judgment or easy can be tricked or distracted. Usually these are people, so-called social butterflies, using social media inappropriately, posting data and information about the company freely with no additional thinking how this can be used by the bad actors. And here is an example that I can point to. In the Darknet Diaries, episode 122, there is there are some examples of that kind of people, of employees who are tricked via social media to provide, to exfiltrate company information, and go there, listen to this episode if you didn't do it, and I hope it will be very interesting for you to see what are the tactics about this type of manipulating the people. Okay, typical scenario: employee who clicks on phishing, make their computer as slaves of the external attackers, installing malware on the computers, providing their credentials on phishing emails. This is type of usual, very often phishing to employees. Next type is lazy, aka negligent. These are people, employees, or insiders who has no intent to harm the company, but they don't bother about the cyber or information security policies. They don't care about the best practices for dealing with the security, and sometimes they even can leave their laptop or proprietary papers in public. They know the rules, and they are aware if it's a violation, but simply don't care. No motive, no motive in there by greed or self gain as much as work avoidance, and are not interested for additional to provide to do additional effort of required by compliance or with policy or to follow the best practices in the company. Yes, these people are just lazy of following the company procedures. Okay, let's move to the next one. Next category is called turncoats. While the pawns are often victims, turncoats are not. The purpose sometimes purposeful and sometimes acting with intent. No remorse, will not change their habits, and likely will repeat the actions. The first type is career from this category. No intent again to harm the company, but just to exfiltrate data. For example, these are employees leaving the company and taking all the data they can do, all their own data, all their own files, contacts, and all the data that they have access, exfiltrating it via media, via online storage. No remorse in them when confronted, and often pleads ignorance, motivated by desire to retain digital work for personal career benefit. They may ignore ignorant the of rules, or pretend to be ignorant, and also they don't care. They don't care that they're taking the company know-how or the company intellectual property to the other company, but they only care about their career benefit on the next stage of their career. The next type of the turncoats are disgruntled. This is the first type of the categorizations where the insider threat has an intent to cause a damage. No remorse until emotional satisfied. Usually these are people who are happy of receiving the salary, but not happy with not provided promotion or bonus that they are expecting, and they know the rules and will take necessary actions to avoid the detection, because again, there's some kind of motivated by self emotional not satisfaction. So they they can distract employees, they can encourage them to be unproductive, they can sabotage projects, also cancel or introduce external threats as ransomware to the company. Usually these are people which are not okay with company culture or how they are treated by the direct managers, and they're again happy to stay in the company because the salary maybe is okay, but they are not doing their job that they are employed. The last category of this whole categorization of the threats is called by Robert Sell imposters. This is the highly sophisticated to be executed, to be also detected. They are doing this as a professional. That they can be, this can be their job. Carefully planning their strategy. They're not emotional. They're running it as a business, and there is no trigger. First category, where there is no trigger in the invoice and the insider threat to harm the company. The first type is malicious. These are employees full intent to cause the harm to the organization, no remorse, likely disgruntled, malicious are not triggered. They're doing it. No, okay, they know the rules and likely to avoid them, to take necessary actions to stay hidden, not to be caught. And maybe a good scenario, good example are whistleblowers or sabotage, like WikiLeaks, like Anonymous. Edward Snowden is maybe one of the best examples for so-called malicious type of insider threat. And yes, they are not necessarily motivated by greed or self gain, but instead of hurting the company. And yes, Edward Snowden and another missile boss are good example for this type of category. The next one is pirates. Again, no intent, but no triggered, but yes, full intent to profit of providing malicious actors. For example, taking a payment for planting the ransomware or selling credentials or corporate data uh, to everyone. No remorse, know the rules, know how to avoid them, know how to, they know how to stay undetected. They have already backstories when they are questioned, motivated by greed and personal gain, and yeah, not interested to comply with policy. In fact, they are just barriers for them to follow to do their goals. Okay, and the last one. This is the first type. When I hear about the insider threat, this is the first type that I have in my mind: espionage. As you know, these are professionals with full intent to exfiltrate data. They can stay hidden for months, for years, and they can act like employees and waiting for the specific moment or for the specific action, or just exfiltrating the data slowly. Yes, they will fake interest to comply with security, and sometimes they may be hired by other company or nation state to exfiltrate a company without any knowledge of the company that there exists there. Highly sophisticated, hard to detect, and usually um, usually not even recognizing that they're in the company. So we finished with the categorization of the insider threat, but why the people are vulnerable to cybersecurity? Taking it into the deep, there may be some personal issues, some problems in the family or daily life of these people, which are making them easier for external threats or making them in cyber threat for the company. Also, there is a fatigue or too many tasks overloaded. Employees are also vulnerable to social engineering tactics, or they are inherit human frightis, and yeah, with development of artificial intelligence and deepfake last years, they can be easily manipulated, easily tricked to do the bad actions. So in next few slides, I'm going to bring you back to the idea of deepfake, how to detect, how to act and what to do when we face a deepfake. On next slide, I have one deepfake video with face swap that I did a few months ago with no software, no idea how to do it, and it took me just an hour and a half to have this result that you're going to see just in a moment. But what is deepfake before this? Deepfakes is a modern technology combined with artificial intelligence that can recreate person's voice or image, and it can take advantage of their identity. Combining, for example, phishing with deepfake, we can call it so 3D phishing is very dangerous for employees, for people who are not aware what is deepfake and how to detect. There are some technologies, there are some frame platforms that can detect deepfakes, but let's be honest, this can be called AI versus AI fight. So the platforms are using AI to detect deepfake, and also the deepfake is more or less artificial intelligence powered. So in next slide, you will see what is my deepfake video face swap. And as I said, this result took me 1.5 hours from zero to that. So let's have it.
Monsters. Makikimora kills because it's hungry. Renfrey kills for pleasure. She is a monster. She is the last of Lilith's women. She possesses the power to destroy us all. I don't believe anyone has that power. With the fate of the continent at stake, is that a charge you're willing to take? There's your right. Killing Renfrey is the lesser evil. Evil is evil, struggle. Lesser, greater, middling. It's all the same. I'm not judging you. I haven't only done good in my life either. But now, if I have to choose between one evil and another, then I prefer not to choose at all.
And this deepfake face swap is done with this software. It's free software. You can find it in GitHub, Face Fusion. And yes, this is the picture of myself a few years ago. And this picture is used to defect the real actor face. You saw, or maybe not, didn't see it, but if there is a movement, faster movement, there is a glitch. There are glitches in the bugs in the face swap software, but again, with artificial intelligence in help, this can be fixed easier. So this is an example how easy and fast someone can face swap another person with his face or her face or someone else's face. How to recognize deepfake? First, artificial looking eyes. The eyes are not easy for the deepfake softwares to be represented. So these are one of our detections that we can recognize that we're seeing deepfake videos. Skin colors and whites. Usually skin colors are not so well represented, not so well done in deepfakes, and whites are not can be indicators also of deepfake video. Picture contrast and sound quality. Deepfakes focus more on how the person looks and then how they speak. Maybe there will be a problem or a robotic voice in some words, in some moments, in some gestures also of the deepfake person, also which can point us also to a direction that this is a deepfake video. Artificial facial movements again. Sometimes face can be not so easy, or gestures not so easy to be replicated. Strange body shapes or movements is another indicator, another example for deepfake videos. And yes, we can use these examples to be more efficient in detecting of deepfake and dealing with the deepfake. In a commercial, in the business world, when we suspect that we're part of deepfake conversation with colleagues, for example, deepfake colleagues, it's good to have an internal secret on internal questions to check if the person in front of us is deepfaked. For example, if the person is the deepfake person is your colleague, you can ask your colleague, do you remember what we talked last week or on the last company event? And this is something that the artificial intelligence should not know. And again, this can be a flag for you that you're in deepfake situation. So we talked about and we categorized the threats, the insider threat, the tactics and of social engineering. So as I said in the beginning, I think that with proper treatment, proper education, and proper dealing with the employees, they can become the so-called human firewall. We have the threat in front of us, but the human firewall can help us to be more secure and to provide to us additional level of security. How to build a human firewall? First, training. For pawns, for dealing with pawns, user awareness training, social media appropriate training, social engineering training, also simulated phishing attacks is a must for every organization. Simulated phishing attacks, regular simulated phishing attacks provide more knowledge to the employees how to detect and how to act correctly in timely manner, because in phishing and in social engineering, the time is also a significant element of incident response and of dealing with such kind of threats. Also, physical security training and receptionist training. Usually, the receptionists are the weak element because they are facing all the guests to the company, but usually they're not properly trained with and they're not aware with all the tactics that they can face from social engineers. Dealing with turn clocks, sensitive data training, employee legal responsible training, infosec pen testing or physical penetration testing also can find some problems in the employees, which can provide more information about the insiders in the company. About the imposters, there is not much that we can do with the training, but espionage awareness training is a must for organizations. But why do security awareness training fails? Here are some examples, but I'll point three of them. First, all this training reliance on checking the box. Boring, not or very extensive, no interesting, no engaging content, or appropriate materials, and also unexpected, unreasonable expectations of user performance. And more or less reliance on single training exercise per year. This is completely not enough. The employees needs to be aware with the active and yes, the active at the moment phishing, not only phishing but also social engineering tactics that they can face during their job. Another way of building human firewall is management measures. For the pounds, not so much to do, but disciplinary actions for policy violators. You have policies, you have procedures, but you need to enforce them. The employees need to know that, especially for the lazy type, if you're not following the policy, or you're not following the best practices that we have in the company, there should be a punishment for you. Or yes, for turn clocks, annual non-disclosure agreement and monitor and remediate conflicts inside the team. The managers needs to know who is not so happy in the company, who is having problems in home or in their personal lives, and these problems can provide threat for the company. Also, for the employees who are leaving the company, exit interviews can provide more information about the internal problems, internal teams problems that can be again turned in the insider threat. For the imposters, strict background checks, counter-espionage team is also a measure that can be taken to deal with this insider threat type. Next one is corporate culture. For pounds, this can be a security champion program. Encourage your employees to be more security compliant, to be more active in providing on following the security procedures in the company. Do internal gamification training and awareness can be also a good company culture that can provide us more information about insider threats and potential insider threats. Separation of duties, report motivation, and strict enforcement of security policies is another corporate culture measures that can be taken. About the turn clocks, employee engagement programs, technical fellowship programs, and open dialogue on security, and open dialogue with the managers and the colleagues in the team. About the imposter, security culture, visibility in security tools such as and teams such as Security Operation Center, CM, CCTV, and other activities needs to be in place. Technical controls about the PALs, multi-factor authentication, phishing resistance MFA such as this kind of 2FA or MFA authentications who can save the people who can deal with phishing generally. Turnquogs, about them, technical controls for them, whitelisting specific corporate cloud storage, and blacklisting all the other possibilities and all the other cloud storage that can be used for data exfiltration from the Turnquogs. Also, data leak prevention is a must in every company. And maybe bring your own device to be allowed also in the company, because sometimes these devices can be used for, again, data exfiltration. About the Turnquogs, tamper-proof card access, microsegmentation of the network, physical access, microsegmentation, physical access, RBAC controls, VPN traffic, and holistic monitoring analysis and predictive profiling for identifying the potential insider threat or espionage actors in the company. How to detect insider threats? There are two methods. First of them is tools, typically information security tools and procedures to detect and to deal with the insider threat. And the second one is behavior, identifying the insider threat incident of IOCs. One of the solutions is corporate culture, and corporate culture like see something, say something, and anonymous reporting for people who see something inappropriate or something suspicious, to be able to report it and to have more visibility on this behavior. What are the signs of insider threat? Here are some of them, and maybe these insider threats can grant themselves access to more and more privileged informations, begin to access privileged information more often than usual, trying to access privileged information that they should not have access to it, and is not part of their daily job or their duties. They are printing a lot of documents or beginning to download data on personal device or external USB storage. And sometimes they can leave their computer without logging off and exiting applications with sensitive information. Again, we need to have visibility of people who are not following the security procedures and protocols in the company. How to respond? Okay, we're detecting some behaviors that can be indicators from insider threat, but how to respond to this insider threat? First, we need to have formalized insider threat plan or procedure or incident response plan, how to and what to do. Usually, in the insider threat incident response plan should be involved and should include human resources and legal. For sure, when we are dealing with insider threat, we need to we need to do our actions based on evidence, because sometimes it can become on which hunting, and we need to be patient. We need to be sure and to understand what is happened and why and who is doing it. And we need to have strong evidences about this. The next slide is about the strategy, how to deal with the already discussed categories and types. For pounds, again, the main strategy is education, awareness. It can be cost effective, it can be fun, and yes, you can be inspiring and also motivating. For Tunkworks, company culture, motivating the people, uh, checking for their satisfaction of being part of the company, and providing them more information for how their work is valid for the company. For the imposters, holistic technical controls and behavior controls, measure controls, mature controls needs to be in place in order to detect malicious activities and to find professionals insider threat in our company. Yes, coming back to the idea of rugby teams and building our human firewall based on the team of South Africa. As you can see on the picture, you should be only 1 point ahead of your opponent to win at the end. The last World Rugby Cup was won by South Africa with just 1 point for the last 3 games that they've played. So understanding of human vulnerabilities, um, providing better company culture is the effective way of dealing with this, with the insider threat, and building our human firewall for additional security. Yes, security for our company. As the Geralt of Rivia says, we need to have the proper weapon to deal with the specific threat. So this will be my final thoughts for the presentation. As we're at the end of the year, and we had an year of a very, very challenging year, very colorful, and very interesting year. So for me, dealing with insider threat, building human firewall is matter of choosing your weapon wisely. For me, this is knowledge. This is the best way to deal with every threat in the cyber field. So for the next year, build your knowledge and inspire, share, and go to your local schools, gather with your local communities, go to your local schools, talk with children about the internet safety, about the cyber security, teach them how to be more secure, because mm, this is the way for our safer future, for our safer cyberspace in next years. So this is from me. This was my presentation about the insider threat. So yes, thank you for having me here, and I'm open for questions if there are any questions. It's almost dark here. Sorry about this.
Well,
Yes.
you found the light. It's good.
Yes.
Well, thank you for the great presentation. Yeah, if you have any questions for the people who are watching, please place them in the chat. As I already mentioned in the chat itself. Again, a big applause for the speaker for his presentation and his talk. Yeah, I don't see any questions so far. Let's give them some time to write it down if they have any. Yeah, again, big applause for the speaker for the time and and the presentation.
If you may, can I say some few
Yeah,
more
sure.
words? Yes, again, we are end of this year, and I want to wish you secure next year. Again, inspire, again, share. Thank you for Mystical community, and I'm glad to be part of this community. And yes, thank you for having all of you here on this wonderful conference. And yes,
Yeah,
thank you very much again.
thank you for the kind words, and yeah, of course, no problem. We are happy to have you here. Yeah, I don't see any questions, so I think there are no questions. So it was very clear for the people who are watching. So I think we go for a short break for about 5 to 10 minutes. Then we go to the next talk, which will be from code to container, enforcing integrity access the software supply chain. So again, one big applause for our speaker here, and I hope to see you all in the next talk.
Silent nights online, hackers on the prowl. Keep your passwords tight, don't let your systems howl. Encrypted files safe, two factors quite a gift. Without it you're a target, your data might just drift.
Firewalls, guard your precious slave.
Hackers try to sneak inside, but they can't ruin your day.
Firewalls, keep the threats away.
Clicking links without a thought is Santa's big no way. Deck the halls with updates, patch your software right. Ignore that sketchy email, it's phishing in plain sight. Malware's creeping closer like snowflakes on a breeze. Scan your drives for safety and keep your holidays with ease. Silent nights online, hackers on the prowl. Keep your passwords tight, don't let your systems howl. Encrypted files safe, two factors quite a gift. Without it you're a target, your data might just drift.
Firewalls, guard your precious slave.
Hackers try to sneak inside, but they can't ruin your day.
Firewalls, keep the threats away.
Clicking links without a thought is Santa's big no way. Deck the halls with updates, patch your software right. Ignore that sketchy email, it's phishing in plain sight. Malware's creeping closer like snowflakes on a breeze. Scan your drives for safety and keep your holidays with ease. nights online, hackers on the prowl. Keep your passwords tight, don't let your systems howl. Encrypted files safe, two factors quite a gift. Without it you're a target, your data might just drift.
Firewalls, firewalls, guard your precious slave.
Hackers try to sneak inside, but they can't ruin your day.
Firewalls, firewalls, keep the threats away.
Clicking links without a thought is Santa's big no way. Deck the halls with updates, patch your software right. Ignore that sketchy email, it's phishing in plain sight. Malware's creeping closer like snowflakes on a breeze. Scan your drives for safety and keep your holidays with ease. Silent nights online, hackers on the prowl. Keep your passwords tight, don't let your systems howl. Encrypted files safe, two factors quite a gift. Without it you're a target, your data might just drift.
Firewalls, firewalls, guard your precious slave.
Hackers try to sneak inside, but they can't ruin your day.
Firewalls, firewalls, keep the threats away.
Clicking links without a thought is Santa's big no way. Deck the halls with updates, patch your software right. Ignore that sketchy email, it's phishing in plain sight. Malware's creeping closer like snowflakes on a breeze. Scan your drives for safety and keep your holidays with ease. Silent nights online, hackers on the prowl. Keep your passwords tight, don't let your systems howl. Encrypted files safe, two factors quite a gift. Without it you're a target, your data might just drift.
Firewalls, firewalls, guard your precious slave.
Hackers try to sneak inside, but they can't rule.
Hello guys, welcome back. The next speaker will be talking about from code to container, securing the software supply chain from Nabila. Unfortunately, the speaker he could not made it for the live talk, so he pre-recorded his talk and he shared with me the pre-recording. So we are going to watch to that. If you have any questions regarding the presentation or anything that he's going to explain in his presentation, then please do not hesitate to reach out to him. You can find him in our Telegram group or on Discord. And yeah, that's all I wanted to say for now. So I hope you all enjoy the next talk. Yeah, and I hope you guys stay for the talk afterwards. So enjoy the next talk and have fun.
Hi, everyone. Thank you so much for joining in. Today, I'll be talking about securing a software supply chain from code to containers. This is not a talk about a single tool or a single one class. It's about integrity, about how trust breaks as the software moves from the source code through the build pipelines into the containers and finally into production. I'll be speaking from an AppSec perspective based on what I've seen while reviewing the pipelines and containers and dependency workflows as well. Quick intro about myself. I'm Nabila, currently based out of India, and I work as a staff security engineer in Zscaler. My focus areas include application security, DevSecOps, and container security. You can find my LinkedIn ID on the presentation. Feel free to reach out to me in case of any questions about this presentation or about the topic that we are going to talk about. I would love to connect and discuss on the same. With that, let's move ahead. Today's agenda is pretty much packed with interesting topics, right from understanding why supply chain security matters to breezing through a couple of case studies on Shai-Hulud, reactor shell, understanding how supply chain attack occurs and the different defenses around the same, and also seeing how we can harden the CI/CD pipeline as well as the security restraints and response as well. Okay. Yep. So let's understand why supply chain security matters now all of a sudden. I'm sure you must have seen recent incidents around the Shai-Hulud case, NPM supply chain attack, and the most recent, the reactor shell. These have been creating havoc since the later part of 2025, and this is just the beginning, unfortunately. So before we begin, let's understand what supply chain security means for the audience who may not know about it. The supply chain security involves actually managing the risk of external suppliers, vendors, logistics, and transportation. In simple words, it also manages or concerns external dependencies or external libraries that dev uses in their normal um, creation of code. So why is it a concern, one may ask? The reason is when there's any security incident that breaches integrity, availability, or confidentiality, that will have a direct damaging impact on the organization in terms of losing their brand value or loss of finances and so on and so forth. This is a big deal for a lot of the organizations, and it's definitely worth considering while defining a security program as well. Now, coming back to why is it a concern, we have seen that around 85% of enterprises leverage some sort of open source software. Okay. Over 27 million devs have leveraged over 37 million open source components and packages. As per Gartner, they have predicted that in 2026, around 45% of organizations worldwide will have experienced attacks on their software supply chain, one form or another. And it has doubled since then. This has been a significant issue for enterprises, and it's definitely one of the biggest reasons what keeps a lot of the CISOs awake at night. But the important takeaway here is not the exact numbers. The takeaway is the trend. Okay, we have seen lately that the universities have shifted their focus from attacking a certain organization to actually attacking the package manager portals or package managers instead, which actually kicks off our entire supply chain concerns. Let's move on to the case study. Yep. The Shai-Hulud war. The first phase of childhood actually came about in September 2025, and recently we saw this onset and the second phase of childhood, that is 2.0, in November 2025. It is actually a very sophisticated worm which kind of infected around 700 JavaScript packages on NPM within hours, easily demonstrating the impact and speed of automated supply chain. The malware in question spread itself to other packages without any human intervention. The blast radius here was extremely massive and around 25,000 malicious repos across 500 GitHub users. The attack back then accelerating at least 1,000 new repos every 30 minutes. It was and the code ran, and how was it executed? The code ran during the package installation, sealing it up tokens and development secrets. And that was how the childhood came with the picture. Now let's go to Reactor Shell, which has been one of the most recent attacks that we have seen in December 2025. A very critical framework, the React server components, was affected. CVE 2025-55182 has been announced as critical vulnerability because it leads to an RCE with absolutely no authentication needed. Okay, RCE is widely deployed. The RCE, there are two different things there. RCE is remote code execution, and another one is RSC, which is React server components. So the React server components is completely widely deployed React frameworks. And this attack in question executes without any authentication, which kind of makes it one of the most lethal attack vectors out there. Tens of thousands of systems were vulnerable, still are vulnerable as we speak. And this was leveraged by a lot of the GPT supported groups and a lot of different adversaries and people to exploit this vulnerability and see if they were able to run codes on the respective servers. And within hours of this, we have seen a lot of the creation of a lot of public exploit tools. It was just a one-click wonder. You don't have to do much. The exploitability, the EPSS score was extremely high, and it was very easy to exploit this vulnerability, thus making it one of the biggest. I think it is on par with Log4j, which happened, I think, back in 2021. So it was at par with Log4j. So I think this was one of the most lethal CVEs and one supply chain attack to ever come in. The exploitation here requires only like a crafted HTTP request. The flaw stems from the insecure deserialization in the RSC payload handling logic, allowing attacker control data to influence the server-side execution. So as stated, this demonstrates the second vector of supply chain attacks, compromising the framework itself, not just the distribution mechanism. Okay, so with that, let's move ahead. Software is assembled, not written. So one mental shift that we need to ensure and need to make sure that it is considered is the fact that modern software is assembled, not written. We often think about application security that we often think that, okay, it's only about the dev code. It's only about the respective code. But in reality, that's not the case. Our application code is just a tip of an iceberg. Underneath that, we often rely on a lot of different other factors, like the open source libraries, the build scripts, the CI configurations, the container-based images and registries that we don't fully control, or we may not even know that existed. So when we talk about securing the code, when we talk about securing application code, we also need to make sure that we are also understanding and having visibility about all of these external factors that constitute and build entire product, not just the code that dev writes, but also the rest of things that strengthens the code. And many times in recent scenarios, you've seen that attackers leverage issues or vulnerabilities in those areas than the application code. Next up, we'll be looking at a very simple three-phase framework. So to keep this talk grounded, I'll use a very simple framework. we'll be looking at the software supply chain in 3 different phases. Okay. Every real-world supply chain attack will map to one of these 3 fundamental phases, namely the source, build, and deploy. Source is where the code and configurations are created. Okay. As you can see on the screen, we have repositories, dependencies, developer tooling. It's all developer-centric. Next, we have build. Build is where dependencies, the pipeline, and containers all come together. That's where you build a certain artifact. And third is deploy and package. These are where artifacts, after getting built, are processed, meaning they're signed, they're stored, and run. Every supply chain incident that we have discussed today, or that may come, fits into one of more of these phases. So let's look into the phase 1, source code in a supply chain. So when you say source, we just don't mean application logic. Source includes open source dependencies, CI, YML files, build scripts, and even IDE plugins. These components directly influence what gets built and shipped, and attackers definitely know about that. Source level risk often doesn't look like an attack at first. It looks like convenience, missing branch protection, unreviewed changes, or even tooling assumption. All of this is part of that. And this is one of the reasons why we said in the earlier slide that application code is a very small aspect of application security. The rest of the build, rest of the foundational stuff is something that is really important and makes up majority of our attack scenario basically. Next up, we have phase 2, which is one of the most important part, build phase. If source is where risk enters, build is where risk multiplies. Okay, one compromised build doesn't affect one service actually; it affects everything built from it. So if if one compromised build is there, so from an AppSec perspective, okay, yep. Hello. Okay, sorry, I think there's some. Okay, so you're saying that, like we mentioned, source is where the risk enters. Build is where the risk gets multiplied. One compromised build doesn't affect a single application. It affects everything downstream. The build phase transforms individual code changes into distributed artifacts, making it very powerful application factor in the entire supply chain attack systems. So from an AppSec perspective, what we have seen that this is the highest leverage control point in entire dependency or entire supply chain thingy. Okay. First, number of different components that are present here are dependencies. That can be the unintentionally vulnerable, malicious, transitive pipeline. Second will be CI/CD pipeline, and third will be container registries. So that's the reason why it's mentioned that it's very important that build systems need to be secure. And for that, we need to make sure that build systems have the least privilege. They have minimal privilege to run the runners and all of those things. Because if at all the build system gets compromised, it can definitely multiply, because based on the artifact it creates, it will definitely multiply and affect more other services. And that's how supply chain attack happens. With that, let's start and understand how real supply chain attack unfolds. So this is the attack chain right from initial access to deployment. So this is the usual attack kill chain for any supply chain, about how it enters into a system and how it gets detected. So first is initial access. Stolen tokens or compromised dependencies usually provide the entry point trust the system. So in case of even Shai Hulud, we have seen that one of the threat actors compromised the tokens of the maintainer of one of the repositories and then took control of the repositories, made changes in the packages, and that's how the attack propagated into a real world scenario, a real world catastrophe. The second is build system compromise. Like mentioned earlier, when attackers ingest certain malicious modifications in the code during build process, it definitely exploits the trust relationships that the consumers have with respective package manager. They usually trust that package manager in many cases, but due to this initial access thingy, they definitely have that breach has occurred. Third is registry trust exploitation. Poison artifacts spread definitely. Once the artifacts are compromised, they will be spreading silently throughout the entire container registries and package managers. And most of the times, the teams are unaware about the presence of this, which may have caused a lot of concerns. Deployment. Malware executes across environments as affected images deploy automatically. In case of a recent attack as well, um, once the affected malwares has reached the respective dev instances, it starts to run. It starts to grab all of the internal. In many cases, I mean, many of the supply chain attacks, they've seen cases where the secrets have been compromised. Secrets, even it starts to run the internal IDEs to extract more information about AI control IDEs, telling more information about the credentials stored, cloud-related credentials, or any cryptographic or crypto tokens, crypto wallets as well. So all of these are something that the malware has a list of all of the things that they need to target with respect to each systems. So everything is automated. They will just malware gonna is gonna get inserted. Look out for all of these sensitive details, PI details, tokens or AWS secret tokens, all of this something that the malware will look into. And fifth is root detection, unusual network connection integrity checks. Definitely based on the volume of network being volume of work being done in the background. That's how these attacks come into the picture because of such changes. Right. So now let's look into the common pipeline weaknesses. We have seen a recurring set of patterns in the security gaps. Okay. First is over permission CI tokens with excessive access, missing validation between pipeline stages, outdated base images, absent SBOMs, no signing or attestation, and shared runners. Most of them are CI/CD based. Specifically, in case of we talk about base images, in many of scenarios, you've seen that developers or dev teams usually rely on the public base images and without uh, checking if the authenticity of the date of the code or checking from where it has come from. It's just they want to use the public images, they'll download it and you use it. And most of the time, these base images are pretty bloated with a lot of excessive libraries and having multiple vulnerabilities. So these are like treasure trove of issues. Many of them have active exploits available. So in cases we do not crack these down earlier, there will be cases where the teams will either be struggling to fix these issues or cannot really, or maybe fall prey to the incidents like we've seen in a couple of days. In many cases, we also do not have SBOMs. So SBOMs basically like your list of ingredients of all the different packages that team uses. If you do not know what you're using, it's going to be difficult to fix what you have. You do not have the list of all the issues. And yep, these aren't theoretical anymore. They keep on getting resurfaced and surfaced in a lot of our day-to-day chores and CI/CD processes, like um, the one that we use. So we don't have to re-exploit it. These are like must. These are all misconfigurations in a way, and these are something that we need to make sure that we keep in mind while reviewing or while defining our processes. Next up, we'll see why developers accidentally create risk. There are a couple of very interesting risks over here, interesting patterns of devs that we've seen in the past. So first is unverified dependencies, installing packages without checking signatures or provenance introduces. Definitely. In this case, many of the times, uh, if the organization does not have a unified repository, the teams end up downloading packages based on what they need, and most of the time they don't check the location from when they have downloaded, the authenticity, the code of that specific library. And many a times, what results is these packages or these libraries are filled with malwares and backdoors. And these definitely can be a cause of concern for the organization. So unverified dependencies definitely tops the list. Next up, we have copy-paste Docker files. Again, similar to what we have discussed last time, base images or Docker files are being blindly copied from the internet without understanding the code and the source of this. So definitely another concerning risk that the developers often uh, are prone to. Third is latest tag syndrome. Now this falls under misconfigurations in Docker images or like a more of a like how this shouldn't be done. So in ideal scenario, in ideal cases, the base images or the Docker images in general needs to have a proper tagging mechanism. Latest is very vague because if you add latest, tomorrow's latest might be something else. So how can one be sure that we know which issue pertains to which image? So that's the reason why it's always considered a good practice to use a digest-based tagging mechanism so that you know exactly um, which entity you are referring to when you're probably scanning or when you're referring to the image. And also, if not that, it's a good practice to also refer to the image versions, right? Like 1.0, 1.0, whatever. And apart from that, you can also make sure to tag your image with the release branch or the branch details. So it's easier for the teams to understand that this image is the product of that specific branch when you talk about the CI/CD pipelines. Next up, we have hardcore secrets. Definitely, teams often embedded repositories with exposed plain text code right in the repository. So definitely a very ill practice. And provenance blindness. I think this should be one of the top reasons because many a times the teams and organizations are unaware about where images come from or who modified them along the way, right? Because we don't know about a reset. And this is something that we as teams need to understand, make sure that we know exactly what we own, and then we'll be in a position to actually fix. So to combat that, we have our 4 core defenses, defense in depth. Verify the build, check contents, harden containers, and monitor production. These defenses work together very well as layers of protection. Each layer stops different attack vectors, and combined, they create a resilient security posture. So the purpose of this isn't about finding one perfect solution. It's about building redundant overlapping protections. So we are going to talk about all of this one by one. And yeah, so let's first start with the first one that we have is software bill of materials SBOM. So SBOM is like a very comprehensive inventory. It has a list of all the inventories, every library, framework, and component within a container. It basically identifies the software components and licenses. What the purpose behind this is to track updated and known vulnerabilities for each and every components for auditing purposes. For in simpler terms, you can say that SBOM is often described as an ingredients list for software, basically. Okay, and the current standards include SPDX, Cyclone DX, so on. And the real value comes up during incidents, like you know exactly what different applications, what different dependencies are being used by the applications, what are the versions, and what is the different licensing with respect to those. As stated in the slides, it automatically you can also store as bombs alongside the container images as well. And yep, that's pretty much what SBOM is all about. And so whenever there's a 0 day, okay, whenever 0 day drops by, most of the times the most important question for us is, where is this component running? How, like in case of any supply chain as well, like we should we if we don't have SBOMs, we will not know exactly where this component is running, which application is using this component. So most of the times the SCA, the software composition analysis tool that we have in a picture, they they create SBOMs, and based on the SBOMs, they are defining or they are giving us the vulnerabilities. So there's first step is creation of SBOM, and the second step is running the vulnerability scans on those SBOMs based on the vulnerability database that they have. So they compare the vulnerability version details with the database that they have. And based on that, they give us a vulnerability. So of course, SBOM is a must in any system, and it's definitely something that's going to help us out in the long run. Next up, we have is image integrity with signing and attestations. So this is an interesting diagram that we have that provides us with the significance of including image integrity and how it's a best practice in today's times, right? So let's start with the source layer. The source layer includes scanning code, dependencies, and configuration. You can see in the screen, right? The left part. We are scanning the code base, we're scanning the dependencies, configurations, and also looking for source for export secrets. So here the goal is not to catch everything. It's to stop obviously like unsafe inputs from entering the pipeline, most obvious parts. Next, so once analysis is done, next comes the policy enforcement. Here, policy usually acts like guardrails, okay, ensuring that you're giving a list of different rules that you cannot bypass. And these rules here can definitely be defined by IECs, which stands for Information as Code. So they give you a list of rules that you need to abide by. And if these rules are not there, then definitely you will be gated. Okay. So based on the rules, you will be creating an image that is in the build stage. Okay. Once image is created, you'll be also scanning those images ideally, but this is since it's image integrity, we'll not be talking about scanning, but in general, we do scan. We do scan the images using Trivy, using Sneak, and we get a list of vulnerabilities. And those vulnerabilities are also gated based on the use case every different team has. Now, after the image is created, we sign the images. So I think it's critical because it creates a cryptographic link between the image and system that built it. This also allows us to verify that, okay, that image hasn't been tampered during the course of the entire process. And once signing is done, verification happens before the image is used, okay? Just to make sure that the image that we're using is in fact legit and it's not something that has been modified or inside. In parallel, we also generate SBOMs as well in the pipeline and attestations. SBOMs tell us exactly what's inside the image, and attestations tells us how it was built and where it came from. Defense number 3 is container hardening. Containers introduce definitely another trust boundary. We have seen in the past, like a lot of clean images have been found with hidden malwares and embedded inside those images. So registries are not just, initially it was considered that, okay, registries are just storage. They're definitely not storage. In current times, they are distribution systems. Because once a malicious image enters a trusted registry, the blast radius grows and leaps and bounds. That's the reason why you need to make sure that we are shipping only what we need. We need to make sure that we are applying the policy of least privilege to container contents, like making sure that we are using least privileges, we are not downloading, we're using public images blindly, we're investing in golden container images. All of those things are like a must-have when you have a Docker ecosystem. That's exactly what's being talked about here. We need to make sure that we are not using shell interpretators because that definitely paves way for execution of bash in scripts when it's not really required. Dropping the root privileges, we can opt for user privileges. That would be a good practice using minimal base images. Making sure that we are deploying distro-less images or scratch containers containing only the application you need and not bloatware. And last but not the least, multi-stage builds, compiling in build container with rows, and then copy only the runtime by rate of an image. Next up, we have CI/CD pipeline hardening the AppSec way. CI/CD pipelines are designed for speed usually. In the initial part, it was just designed for speed, but not for any attacks or any security purposes. But due to the fact that we have secrets everywhere, runners are often shared with definitely high privileges, it becomes cause of concerns to make sure that even CI/CD pipelines are should be hardened because of all of these reasons. So these are a couple of ways in which one should make sure that these are compliant in terms of making sure that all of the different phases, different modules are considered. First is secrets management, making sure that we are using secrets, storing secrets at proper vaults, having proper policies around rotation, minimum exposure, the credentials. Next, ephemeral runs, short-lived build environments, basically making sure that the environment that we are using are short-lived and they destroy after a certain period of time and they are not long permanently. Having minimal permission, definitely it tops the chart. Principle of least privilege should be a thing in CI/CD as well, making sure that they are having minimal privilege applied, making sure that the controls and scripts are not, unlike we are not making sure that we are running every random scripts and make sure that the scripts are reviewed with explicit approval. Because what happens is when attackers gain access here, they don't really need to be stealthy. We have our automations running, so if our controls are not in place, things can definitely go wrong. Next up, we'll be talking about registry security and incident response. So this slide basically focuses on the registry security and incident response. So first is making sure that we do not fall prey, or definitely it's not that. Firstly, the thing is, there's no foolproof solution to say that okay, by doing all of this, we will be bulletproof against all of these incidents. But by ensuring that we are keeping in mind all of these security controls and abiding by it, making sure that everything has been included and followed upon, we are significantly reducing the risk that the incident might bring in. And that's exactly what security team does. They need to make sure that we are securing ourselves and and reducing the risk of anything that is not been happening. So first, we're going to talk about the prevention mechanism, that is registry security. So the container distro, as mentioned earlier, are not just for storage; they are also distribution hubs. Because once a malicious image comes into the registry, it starts propagating and silently spreads across to every environment that pulls from them. So to make sure that doesn't happen, we need to have certain control in place. One of them is enforcing digest-based deployments instead of just mutable tags, blocking unsigned or unverified images at the admission controller. This can be done at the admission controller, or we can also use certain gating mechanisms in our CI/CD setup as well. We can use policies that define that okay, during build or during build, if these are not post build, basically if these tags are not there, they will not be allowed to be published in production or something of that sort. So all of this can be done in the CI/CD as well, making sure that vulnerability scanning is done before promotion to production, and having an audit registry access and image modification visibility as well. So basically, these are all important controls you need to make sure if you have a Dockerized environment, ensuring that you are blocking unsigned, unverified images or untagged images, and implementing scans and gating those scans. Just scanning is not really the only goal. Making sure that you're fixing those issues is the main goal here, and only the vetted images are being promoted or pushed to production. That's one of the biggest control or gating that we can apply over here. So all of this is important and need to make sure that we are reducing the impact of anything that, if any supply chain, if at all, comes into the picture. And the second part is supply chain breach response. Now, this is when you have been subject to an incident or any supply chain. So how to so this gives you a list of ways in which you need to operate. You cannot just roam around like a headless chicken. You need to have a certain plan in place, like incident response plan in place, and the specified step-by-step approach on how to tackle this one way or another. So assuming that there is supply chain thingy, or maybe your container has been compromised. In that case, you need to follow a certain list of rules, and one of them, and the following are these rules that we have seen. Okay. So first is identifying the compromised artifact and isolating it, tracing the deployment history, making sure that it has not been poisoned by other repositories, rebuilding the affected services. All of this are adequate rules and ways in which we can definitely um, do the post incident cleanup, as we say, because once a poisoned or a compromised image enters the trust registry, it, like we've seen, it silently just spreads to every environment and can be development, can be staging, can be fraud. It's that lethal. That's why it's very important for us to make sure that we are having the registry and security uh, appropriately. And in case if there's a supply chain detection, we need to make sure that these are the couple of steps that we follow for any compromised artifacts. Okay, because the reason why we are doing this, because we need to understand the deployment history, like where exactly was it deployed, what was the environment where it was deployed, what was the entry point for that attack. All of these questions will be answered when we do a step-by-step approach for any breach response. And this is like, yep, trust is earned and not assumed. So, supply chain security definitely comes from discipline and visibility, not just tooling. Adding tooling is just one part of the entire game. You need to make sure that those toolings have proper gating in place. You are making sure those controls are properly being followed upon by the dev team and everyone. That's when the actual security kicks in, and that's how we need to make sure that we are following. So these are a couple of steps that we can keep in mind uh, while making sure that these are followed. So firstly, first foremost, verify every stage. Assumption is a very ill way. Do not assume anything, and please make sure that you are safely validating inputs, outputs, transformation every step, be it application, be it code, be it anything. We need to validate everything, especially from the user side. Minimize trust boundaries. Reduce the number of systems that people must be trusted implicitly. Automate integrity. Like we mentioned earlier, we need to make sure that we have certain controls. Like for example, in earlier slides, you've seen code signing, you've seen image signing. All of this is automated in CI/CD pipeline. So make sure that we manual checks are not in place, and we have certain automations to automate integrity and make sure that this is followed as a repeatable pattern. Audit continuously. Regular reviews, cache drift and configuration creep before. Definitely, it's a must thing. And regular reviews, regular testing, regular assessments is something that will definitely help us in the long run. And building cultural awareness. Yes, security isn't just about tools. It's, and I would go ahead and say that security is just not one person or one team's responsibility. It is also a responsibility divided by everyone, be it dev, be it DevOps, everyone. They all have a part in this entire ecosystem, and their contribution and their help is definitely going to help uh, reducing the risk that the organization or any team faces while uplifting the security controls. So I think this needs to be propagated that security is a shared responsibility. And without other people's assistance, it is going to be difficult for any team to uh, scale and be successful. So this was pretty much it from my end. Thank you so much. I hope you um, uh, learned a thing or two from this. And if there's any questions, please feel free to reach out to me on my personal contact. I've shared my LinkedIn. So please feel free to drop me any question that you have or any discussions you want to do based on this. I'll be really excited. So yeah, thank you so much. And I hope you all have a great day ahead.
Yes. Well, thank you for the presentation. Yeah, I know we are not here. She's not here at the moment, as I explained at the beginning of the talk. But again, if you are by any chance listening right now or tuning in, then again, thank you for your talk and the pre-recorded video. Give a big applause to her. And then I think we go to a short break for 5 to 10 minutes. I think 5, because the next speaker is already waiting. This next speaker will be talking for 2 hours long, so it will be a very long but interesting talk. So I hope to see you guys there. So we now go to the break, and I see you then.
Silent nights online, hackers on the prowl. Keep your passwords tight, don't let your systems howl. Encrypted files safe, two factors quite a gift. Without it, you're a target, your data might just drift.
Firewalls, guard your precious slave.
Hackers try to sneak inside, but they can't ruin your day.
Firewalls, keep the threats away.
Clicking links without a thought is Santa's big no way. Deck the halls with updates, patch your software right. Ignore that sketchy email, it's phishing in plain sight. Malware's creeping closer like snowflakes on a breeze. Scan your drives for safety and keep your holidays with ease. Silent nights online, hackers on the prowl. Keep your passwords tight, don't let your
Hey guys, welcome back. The next speaker is already waiting, as you can see on the screen. It will be about Kubernetes testing by Moise. It will be a 2 hour long talk or 1.5, and I hope you all will learn some new Kubernetes testing things and tricks, and I hope you all will enjoy this next talk. So I give the word to the next speaker. Big applause, and enjoy the next talk.
Hello, everyone. Good evening. Uh, Welcome to Mystikcon. My name is Moise, and I will be talking about Kubernetes testing. A little bit about me. My name is Moise. I am a red and purple teamer. I work as a tech consulting analyst at EY. I also have few certifications related to cybersecurity, like CEH and CRTP. I have a wide range of interest. I am into cybersecurity. I like coding. I'm also passionate about motorcycles and cars, and I like working out and other outdoor activities like hiking or just playing football. In case you want to reach out to me on LinkedIn, I have also listed my LinkedIn so we can connect. And I also have a website where I post CTF write-ups and security related blogs. So in case you are interested, feel free to check that out as well. Moving on to our topic, let's first start by understanding what Kubernetes is, right? So before we talk about the security part, let's just make sure we all have the same mental model for Kubernetes. So Kubernetes is basically an open source container orchestration framework, and it was originally developed by Google. The easiest way to think about it is that it is like an operating system for containerized applications. So it decides where different things run, it keeps them healthy, and it exposes them to the network so that it is accessible to other services and users. Uh, why do we need it? So as we shifted from monolithic architectures to microservice architecture for developing applications and in general, we started relying more and more on container technologies. Just for information, monolithic architecture means that all the components are bundled into one uh, big piece and that is shipped and deployed. Whereas microservices architecture basically splits all the components into microservices or into smaller chunks, and collectively it is hosted so that uh, it is easily scalable and it is faster and it is easier to update. So as we started shifting from monolithic to microservice architecture, we started relying more on container technologies like Docker. So this now meant that applications comprised of hundreds, if not thousands, of containers. And this in turn made it extremely difficult and tedious to manage such large number of containers, and which in turn led to the creation of container orchestration technology. So before Kubernetes, running containers was quite painful. You would have to manually configure everything, manage the containers, and also perform networking for it to work as it is expected or required. But with Kubernetes, everything can be scheduled automatically based on the provided requirements. So let us quickly take a look at this practically as well. Let's say I want to spin up 5 containers. For some reason, I just want to spin up 5 Alpine containers, and I want to do that using Docker. So ideally, if I were to not use something like Kubernetes and I wanted to just spin up 5 Docker containers, 5 Alpine containers, I would have to do something like this. This will start my first container. Similarly, I will have to keep doing this until I have my 5 containers. So this is the third container. Fourth. Yeah, and fifth. To just to make sure I have those containers. Yeah, so I have those 5 containers running that I just created. Now, if I wanted to add some more containers, let's say the traffic that was coming to these containers was extremely high, right? My website is growing, my application is growing, and I just want to scale up these things. I would again have to repeat the same process if I wanted to scale up my project, right? Uh, what if I wanted to do this n number of times? That would mean I would have to keep on repeating this as per the requirement, right? Also, deleting this was also kind of a task because we would have to do something like let me just list down the containers that are there. All right, there are 6 containers. So if I wanted to delete these 6 containers, I would have to write I'm just naming these containers from 1 to 6. And after doing that, yeah, these containers should be deleted now. Yeah, it's clean. So yeah, this meant that now manually I have to write everything and nothing's automated. But what if I told you that the same thing could be achieved with much lesser effort, right? So that is where we will understand the true power of Kubernetes. So I have a configuration file of an extension of type YAML. This is the language that Kubernetes requires in order to understand our instructions. So if I were to just concatenate the contents inside this file, it is a very straightforward, easy to read file. I will go through certain components or terminologies that are described here as we proceed in our session. But for now, let's just focus on a few key things. Deployment can be thought of as a group. So I have created a certain group, right? I have named that group as Alpine Demo. Spec contains information about the things that are present inside this particular group. So I said that I want whatever is there inside this particular group, I want 5 copies of that. So the replicas are 5. Uh, then about I have another spec tag which describes the things that are present inside each one of this replica. So I have named that, I have provided it with an image, a Docker image, and I have provided a command for it to run so that it is actively running and it does not die instantly. So if I wanted to, let's say, use this particular configuration file to create 5 Docker containers running Alpine image, I could do that using a command line tool called kubectl. So if I just type in kubectl, apply means I want to apply this particular configuration into my existing Kubernetes cluster. And with -f, I can just mention the file. Alternately, I could also list down each one of these properties through the command line itself, but that would make the command extremely long and kind of difficult to understand. So I have decided that for the sake of simplicity, I will stick to configuration files. So if I just type in this will first of all create a group, right? A group that I mentioned. And this group will automatically spin up 5 Alpine images. So if I just look at information about the group, so the group that I said is actually the deployment. Right? So if I view the deployment, then it says that, all right, there's a deployment named Alpine Demo. It has 5 things inside it. It is up to date and it is available, and it was created 17 seconds ago. Now, if I try to list down the containers that are present inside it, I can do that using the kubectl get command. The containers are called pods. I'll get into more detail about pods in the future, but for now, we can just assume that containers mean and pods mean the same thing. So this basically lists down all the containers that are present inside this particular group that we created. So yeah, as we can see, we have 5 Docker containers that are up and running. So if I ever wanted to scale this further, I could just change the replicas to 6, 7, even 100, and Kubernetes would automatically spin up 100 Docker containers for me. It's just that simple. If I wanted to make this even less, I could change this to 2 and it will automatically update things for me. Let's say I want to add 2 more containers, right? But I don't want to modify my existing file. What I can do is I can provide a command line argument for that as well. So as I mentioned earlier, kubectl allows us to apply configurations using special YAML files or using command line arguments. So if I just change the replicas to 7, I get a message that, all right, your Alpine demo group has been scaled. So from 5 Docker containers, I should now have 7 Docker containers. And yeah, there we go. As you see, from the age, we can know that, all right, this and this particular Docker container has only been created 10 seconds ago. So yeah, when I executed this command, these two containers were created. Now, if I wanted to delete them, deleting them was also as simple as creating them was. So I can just use the kubectl command again and delete the entire group. The group in Kubernetes is called deployment. So I can create this particular group that I created previously, and this will delete all the containers that was created using the previous commands. So if I just again type in the same commands that I did, yes, a few minutes back to list down the pods or containers that are present in this particular group, I'll see that these containers are now being terminated. And after a while, these won't exist. So let's just wait a few more minutes and few more seconds, and all right. So the reason these threw an error was because my my configuration file only had 5 value. Oh, never mind. Yeah, so things have been deleted using a simple command of kubectl delete. So this just shows us the power of Kubernetes and why it was a game changer for microservices, for applications or things that relied on microservices architecture. These are some of the challenges that were faced and the solutions that Kubernetes provided in return. So as I mentioned earlier, we had to manually create containers. We had to start and stop them. In case something needs to be updated, we would have to take down the container, update it, and then spin it back up again. In case of an error, we could not recover anything. And also scalability was a challenge when there wasn't an orchestration platform. With Kubernetes, we can automatically schedule and scale our cluster. We have high availability, which means that there's just almost zero downtime. And in case of an error, we can recover easily from it using backups or restore back to the existing scale. Uh, this is the architecture of Kubernetes. So for now, just ignore the cloud provider API and cloud controller manager parts. I will come back to this after I've explained the core architecture of Kubernetes. So a Kubernetes, whenever I am running a Kubernetes somewhere, that is called a cluster. Kubernetes cluster involves two main parts. There's a control plane, which can be thought of a control panel. This is how we interact with anything that we are trying to run inside the cluster. And then we have something known as worker nodes. We can have multiple worker nodes. Again, worker nodes are where actually our services are running. Whatever it is, our application, our services, website, whatever it is that we want to run inside the cluster, that is ran inside the worker node. Control plane contains four main components, four components. We have the API server. This is the entry point for all our calls, right? So when we used kubectl commands, or if we make any API calls, that command or that API call hits the API server, the kube API server. Even internally, if the worker nodes or if this particular control plane has something that it needs to tell, that communication is done using the API server. Then we have something known as the kube scheduler or the scheduler. This decides which node runs which pod. All right. After that, we have a controller manager. Controller manager basically ensures that whatever state it is that we require, that state matches the actual state that's there in the cluster. So earlier, when I wanted 5 Alpine images to be running, 5 Alpine containers to be running in my cluster, the controller manager ensured that if the desired state is 5, the actual state or the actual number of containers that are running inside my node or my cluster should also be 5. etcd is a key value store, and it basically stores all the information that is related to the cluster. So even our desired state, the number of pods we want running, what pod should communicate with which service, and all other communication or configuration related data is stored in the etcd component of the control plane. Moving on, we have the second component, which are worker nodes. Worker nodes are where actually our services run, and it contains three main components. You have the kubelet, you have kube proxy, and container runtime. So kubelet is basically, it can be thought of like an agent that runs whatever it is that we want as per the instructions provided by Kube API server. So if we want to run 5 Alpine containers, the Kube API server will actually inform the kubelet that, hey, this guy just instructed us to run 5 Alpine containers, and the kubelet will actually spin up those containers. After that, we have kube proxy. Kube proxy is a way that a way for the node to communicate with others. So it basically handles networking and handles the traffic that is sent during communication. Uh, Finally, we have container runtime. These are what Docker and container is. It basically runs whatever container it is that we want to run. Right. So under the hood, Kubernetes is basically a distributed system, and it is made up of two main parts. You have the control plane, which can be thought of like a brain, right? It exposes the API server, it runs the scheduler, and it stores the control state in this particular etcd. After that, we have your worker nodes, which are the muscles. So they actually run the containers that we want using the kubelet, and it handles the networking and communication using kube proxy. So when we deploy an app, our kubectl commands apply command hits the API server, right? It first hits the API server. This API server in turn stores the state inside the etcd. And after that, the scheduler basically finds space inside the nodes to run those things. And finally, the kube, after it has found the space, it sends the signal to the kube API server, and the kube's API server instructs whatever node has been chosen to run those 5 containers. In case one of the container dies, the controller manager will alert to the kube API server that, all right, the desired state was 5, but now we only have 4 containers running, and the kube API server will send another call for the kubelet to spin up one more container so that the desired state matches the actual state. Uh, as you see, we have something known as a pod. Now, pod is the smallest building block in Kubernetes, and these can be thought of as an encapsulation that are present on top of our containers. So they basically provide runtime environments for our containers. And in Kubernetes or with Kubernetes, we never directly talk to or deal with containers. What we deal with is pods, and each pod lives inside a node. Node is basically a, a physical machine where everything's running, and each node can again communicate with each other within the cluster using internal IPs. Excuse me. Right. So because pod is basically just an encapsulation on top of a container, there can be times where, let's say, our pod has been assigned 2 GB of RAM, and there is a certain sudden surge of operations that needs to be performed, and this leads to uh, that the crashing of this particular pod. So in such cases, Kubernetes automatically spins up a new pod in case this particular pod has crashed. And I just explained that how it is done from the controller manager, as this is actually monitoring the state. So now that we have a basic understanding about the topic, let's move on to why we need to test. So Kubernetes testing is a shared responsibility. Okay, it does not secure itself, and there are layers to it. Basically, the cloud provider protects the infrastructure and the control panel. So what you saw over here, the cloud provider API and the cloud controller manager, are additional layers that are only present when we are using a cloud service like GKE, Google Kubernetes Engine, or EKS, right? And what we do is we usually interact with the cloud provider API, which in turn interacts with this, and all the other components are encapsulated or hidden behind the cloud. So the cloud provider basically protects the infrastructure where the cluster is running and the control plane. We as security professionals or operators configure and test the access controls and policies that are there inside our cluster, and the developers that are building apps so that they can be run inside the cluster are the ones that are securing the apps and the images that these apps rely on. So most breaches that happen in Kubernetes aren't because of bugs. They come from misconfiguration and overly permissive settings. So our testing focus is to catch these before the bad guys do. Now, as we saw in our architecture, Kubernetes isn't just one system. It's like a mesh of different APIs and agents. Right? The API server, kubelets, etcd are usually the first point of contact and are hence often the first targets as well. So if, for example, our dashboard is open to public, then that is a huge problem, because that just makes it easier for attackers or hackers to get access to our cluster. On the workload side, an outdated image or a pod running in privileged mode, which basically allows the pod to break out of its container runtime and get access to contents that are present inside the physical machine, the actual machine, which is the node. That is again a huge problem, right? And it could lead to elevated access if there is a lack of network policies. If ACLs are not properly configured, then an attacker can laterally move like it's just one big LAN. Now, even if we build perfectly hardened clusters today, it won't stay that way, right? Because new pods, new namespaces, new images, everything's being spun up regularly. And this is what actually leads to security gaps or misconfigurations. So as security professionals, this is why we actually test Kubernetes. And to help us to make our job easier, we already have few tools like Kubebench or Trivi or even Falco that lets us automate the validation and detection issues before it turns into a breach or a trouble for our customers. So yeah, moving on, let's talk about reconnaissance. Uh, this is similar to reconnaissance in any other security field, similar to what we do in penetration testing. What we're doing is we're just trying to map the cluster. Recon in Kubernetes is the process where we try and understand what's running inside the cluster, where those things are running, and who might have access to it. To better understand this, I also have few practicals. I have a practical as well. So let's just move on to it. I'm just going to make sure that I don't have anything running right now. Okay, these are the default pods. So I have another configuration file which will just spin up an example scenario that will help us understand the concepts about Kubernetes recon. So I'll just apply it using kubectl apply. Let's just wait a few minutes to. Okay, we have our namespaces, and let's just ensure that everything's running. So yeah, these are running, these are running. Okay, all are running. Great. So first thing that we do in reconnaissance, and something that we must do, is to verify what cluster we are in, right? Even though this sounds obvious, it is very easy and common to mistake the dev cluster for a production one, or even worse, to mistake a production cluster for a development one. So if we just simply run something like kubectl cluster info, this will print information about the API server, the Kube API server, and DNS related information. So this can be used to ensure that you are communicating to the right API server and that you are actually targeting the right Kubernetes cluster. On cloud platforms, again, these same checks can also reveal that our control plane is public or private. And this again is a key security factor. So I can, after I've verified this, I can start by listing namespaces. Namespaces are basically isolation boundaries, right? These are kind of similar to VLANs, virtual LANs, except one thing, that when I have something in namespace A, that does not mean that it won't be able to communicate with things that are present inside another namespace, right? Unlike VLAN. So namespaces are like boundaries or isolations, right? And everything that, if everything's in the same namespace, that is a red flag. After that, I can list all the pods that are there inside these namespaces. Right, so before moving on to the pods, let me just show you how to list namespace. So to list down namespace, we can use the kubectl get command. And after that, I'll just mention namespace, and this will list all the namespaces that are present inside my cluster. The default is the default namespace, right? These namespaces are must be ignored for now, because these are created by the local cluster that I'm using. In case you're curious, I'm using a cluster, a Kubernetes cluster called Minikube that allows us to create a single node cluster. And it is great for practicing in case you want to explore this topic further. For now, we have two namespaces, or three namespaces for that matter: default, team A, and team B. After finding the namespace, I can also list all the pods across these namespaces. Now, this tells us that what's deployed and which nodes they're running on. So to do that, we can just use the kubectl get pods command that you saw earlier. This will just show the pods that are running inside the default namespace, right? So this particular pod is running inside the default namespace. If I just add a -A, this will list down pods running across all namespace. So the default namespace has hello pod. Team A namespace has 3 pods. All right, something related to web, and team B has 2 pods. Alpine related containers running. Right. If I want to see deployments, if you remember, I mentioned deployments are basically groups of pods that are running, groups of containers. If I view deployments, I have 3 deployments. This is the default, so we can ignore this. We have the default deployment with the name of hello. We have team A deployment, which contains 3 containers inside it, and it has a name called web. And we have team B deployment, which contains 2 containers, which just in case you want to verify, right? Team A contains 3 containers that we see over here. Team B, which is another group, contains 2 containers. It's called Alpine Sleepers. So we listed down the namespaces, we got the pods, now we also got the groups. After that, we can also find more information about these deployments, right? So if I were to use something like this, what this command does, I'm using the kubectl commandlet to interact with my local cluster. -n is used to define or to specify the namespace. So I am interested in team A namespace. If I don't mention this, it will by default stick to the default namespace. So after that, inside this namespace, I want the cluster to describe a deployment called web. As we see, team A namespace contains a web deployment. If I enter this, I'll get even more details about it. It shows what image is running, what port is being used for by this particular container, right? And some more information about it. If I wanted to, similarly, if I wanted to find more information about my second deployment that's there inside team B, which is called Alpine Sleeper, I can do that as well using the same command. Just I can change the namespace. Instead of team A, this will become team B, and I want the Kubernetes cluster to describe a deployment called Alpine Sleeper, which is our second deployment that's present inside team B namespace. And here I'll find some more information about it. So just a quick summarization. Pods are basically the smallest runnable units, right? Deployments are groups of pods, and deployments basically ensure that whatever a desired count is, that remains constant, right? So if I want 2 as you can see in the replicas part, if I want 2 containers to be running, deployments are what actually enables Kubernetes to ensure that if the desired state is 2 containers, then the available state or the actual state should also be 2 containers only. Another way to find more information about a particular deployment or a pod for that matter is using the -o parameter, right? So I'm trying to get all the pods that are present across all namespace, and wide will just show if I don't use wide. We saw that it just shows this much information. If I were to just add -o wide, this shows some more additional information like the internal IP, the node that it is running on. Right now, as I said, I'm using a single node Kubernetes cluster, which is called Minikube, and some more information about it, right? So yeah, after this, I can, or we can also check for services, right? A simple command like kubectl get svc will reveal the services that are running. Now, since I haven't explicitly specified a namespace or -a, I will only get the services that are running inside the default namespace, which is called again default. It contains 2 services, right? Kubernetes and Hello. The cluster IP is the internal IP that is being used for internal communication within the network. External IP is the IP that is publicly available. Now, these services are also having various types, right? We will get into this in the future. But yeah, this is cluster IP. If I see in place of this, I see node port, this node port, or if I see something like load balancer, then that usually means that the service is externally exposed. And in many cases, from my experience, we don't really have a firewall between the externally exposed services, right? After that, we can also, so this is the default services, right? If I want to list the services that are present across all namespace, I can use -a and I'll get some more services, right? There's another service called web inside team A. Now, if I want to find even more information about this, I can use similar to the one that we executed before this. I can use -o wide and I'll get some more information about these services. So apart from services, there's also something known as secret. And yeah, just one more thing. Cluster IP is an internal only IP, right? These are only accessible within the cluster. Apart from this, there's also something known as node port, which I mentioned earlier. This basically opens a port on every node, right? And this is something that must be done with extreme caution. After that, we also have a load balancer, which is usually a cloud facing IP or a virtual IP that is cloud facing. Just to show you that, just to show how what's the difference between cluster IP and node port, since I mentioned that node ports are also externally accessible, right? Let's try and get a public URL for this. So if I just enter this, I'm using Minikube, which is my actual node, and I'm just trying to get a URL to interact with this particular service. So I got a URL. Now, if I just go into that, see, I'm able to access it. If I were to do the same thing with this, that would fail. See, it fails. So this just proves that cluster IP is a local only IP and node port is something that is externally exposed. After this, we also have something known as secret. Secrets are basically key value pair that are stored, and these could be credentials or tokens. And one important thing to note is that secrets in Kubernetes are not encrypted by default, right? They are only base64 encoded. So to get secrets, we use kubectl get secrets. This will list the secrets in my default namespace. Obviously, there are no secrets in my default namespace, but there are secrets in other namespace. So if I add -a, it will show that, all right, there's a secret called db creds inside team B namespace. it has a certain type as well. And if I want to find more information about this particular secret, I can use the describe command with kubectl. So inside this team B namespace, I want you to describe a secret that is called dbcreds. Just hit enter. I will find some information about it that, all right, there's a password that contains 19 bytes and there's a username field that contains 9 bytes. If I wanted to uh, get the actual value of these, there are two ways to do that. The easiest way would be to output the result in YAML format. So earlier we did something called void, right, which just tries and shows some more information. But with things like deep secrets, like finding information about secrets, we can use various output formats. So, all right, I forgot to mention the namespace, right? So the reason I was getting this error earlier was because my default namespace obviously does not contain that particular secret, right? So uh, we earlier looked at void, which just displays some more additional information in a tabular format. We also have another format called YAML, which displays the secret information, the actual YAML contents of that particular secret. And as I mentioned earlier, the secrets are not encrypted, they are only base 64 encoded. So if I ever find a secret, I can easily decode this, or even if I look over here, I can view the plain text secrets. So there's a username called demo user and there's a password called super secret password. If I wanted to decode this as well, I could easily do that using echo. See, I got the password, and similarly, I can also get the username as well. So yeah, this just shows that secrets are not encrypted, and this is how we can find secrets. Besides YAML, we also have an option of viewing secrets in JSON format. So if you're more comfortable with JSON, you can also change the format to JSON, and it will output the results in JSON format. This was the easiest way to view secrets. Besides this, if you want to list a particular secret or a particular field inside that secret, the username and password field only, then we can use another output type, that is JSON path. JSON path basically lets us define the path inside this particular JSON that we want to get. So inside, if I just output this in JSON format, see there's a field called data, and inside data there's another field called password now, and another field called username. If I want to get the username field, I can use the JSON path format and give it data and username so that it can get the value of whatever's there inside this particular key. So yeah, this is just piping the same. So I'm piping it to base 64, which is just decoding it, and it is just echoing the same onto my terminal. This reveals the username, and similarly, if I were to change the username to password, this would reveal the password as well. So this is where we find sensitive data, and yeah, these credentials could be used for internal applications or also for external applications if that is what's being used. But again, these shouldn't be accessible, and it is best practice to encrypt these credentials on top of encoding it. After this, we move on to ACLs. So Kubernetes have a concept of cluster role bindings. Role bindings are basically roles or ACLs that are bound to certain clusters or certain, yeah, that can be bound to host or a user or a service. It can be bound to anyone. These are basically access lists that can be bound to anyone. So right now we have a few role bindings, right? If these are the default role bindings, so I'm not going to dive deep into those things. For now, what we are interested in is this. So there's a role binding called, this is the name of the role binding of the ACL, team A default admin. This is the type. So it basically provides whoever has this particular role They are essentially the cluster admin. Cluster admin is like the administrator of the entire cluster. Right? If I do role bindings, so I'll find more information about those things. If I now try to list down the service accounts are basically accounts that are used for communication. I'll see that, all right, there are these many service accounts. These are the default service accounts. What I am interested in is the team A and team B namespace service accounts that are called default. Right now, since we saw that there is a particular cluster rule binding, right, that basically provides administrative privilege to whoever it is that it is bound to. Let us look at find out more information about this. Right? So if I do kubectl get command is again used to get anything from the cluster. I'm trying to get the cluster role binding. The name of the cluster role binding is team A default admin. This is the name, and I'm just outputting it in YAML format, displaying it in YAML format so that it is easier to understand. And yeah, this basically defines the same even more. What we look for in role bindings is basically broader permissions or wildcard permissions or something like this. Where did it go? See this cluster admin. If we see something like cluster admin, then that means that whatever service or whatever account is bound to this particular role has cluster admin rights. And in this scenario, it seems that the service account that we listed earlier called team A is bound to this, and the default service account present inside the namespace team A is bound to this particular role. So that means that this particular service account has administrative rights over the entire Kubernetes cluster. So yeah, that was a brief overview about how we can perform reconnaissance and how we can map out the entire Kubernetes cluster. Let me just take down the lab that we created. To delete it, I can just do kubectl delete -f to specify the file of the configuration file. And after that, I'll just mention my configuration file and this should automatically delete it. So while this is deleting, let us just quickly go through everything that we have covered, the various components that we looked into. We looked at namespaces. Namespaces are logical folders or logical boundaries. These are where policies, quotas, RBACs are scoped, right? After that, we looked at pods. Pods are basically things that are encapsulation, that are running one or more containers, and pods are always scheduled together, and they share a network and also share storage spaces. We looked at deployments that can be thought of as groups. So deployments are basically groups of n number of identical pods, right? This deployment is what actually enables us to ensure that the desired state matches the actual state. We looked at services. Services are names or IPs that are used to reach our pods, and we looked at secrets, which are key value stores for sensitive data. Then we looked at service accounts, which are again identity for the pods when they call the API server. We looked at ACLs, which are also known as roles or cluster rules or bindings. These are basically permission sets, and these can either be namespace scoped so that they only work within a namespace, or they could be cluster wide. Just as we saw in our case, the RBAC that we discovered was cluster wide, the cluster admin one. And basically these roles are applied to objects like users or containers. After that, we looked at nodes. Nodes are the actual worker machines. It could be a VM, it could be a physical machine where our cluster or where our pods are running, right? Finally, we also looked at cluster information. We must ensure what cluster we are communicating with to prevent mishaps like accidentally enumerating or performing harm to systems that we are not authorized to do so, where we are not authorized to do so. So yeah, Recon is basically the foundation of Kubernetes testing. It is how we build our cluster map. We try and understand what namespaces exist, what's exposed, and where sensitive data might be hiding. And everything that we do next depends on what we have found in our reconnaissance phase. This includes initial access, privilege escalation, post exploitation, everything. So yeah, after that, let's move on to another topic, which is uh, initial access vectors. So now that we know what's inside a cluster, we have to start exploring different ways we could gain access to the cluster, right? So first part is gaining foothold. When we talk about initial access in Kubernetes, we mean that this is the very first step of a compromise. So this is how we get into the cluster and how we are able to directly communicate with the Kubernetes API and the pods. This could be using an exposed dashboard, a leaked kubeconfig file, or a container image that has been tampered with. And because Kubernetes is so modular, it contains APIs and it could be running various registries and it could be part of various CI/CD systems as well. There are many possible ways of gaining footholds. Some of the most common vectors that I have seen or read about are first publicly exposed dashboards or APIs that do not have authentication, or even if they do, they have very weak credentials, weak or default credentials. Insecure images or registries where they are the images that the Docker containers are running are being are unverified and are outdated with known vulnerabilities. Leaked kubeconfig files or tokens that are stored inside, let's say, repositories or CI/CD logs. Then secrets that are hard coded inside version controls. These secrets could include tokens related to particular pods or API keys or even passwords that we saw earlier. Finally, this is just an extension of the first topic. The first point, weak credentials or default admin accounts. So this is again the last point is very common in early setups, but once the setup has been matured, you won't really find this that often. Common ways we can access these are basically common entry points, right? For example, we can scan images using tools like Trivi or Gripe. What they do is they flag known CVEs and hard-coded secrets before deployment. We can scan code bases if we have code bases, or if you're using something like uh, GitHub. We can scan them using tools like GitLeaks or Trufflehog. And what they do is they look for leaked credentials. And finally, we can also test our registries and dashboards to confirm that they are restricted and are only available to authenticated users. Okay, I have a lab for this as well. I'll just show you how we can run Trivi. I won't run it because Trivi takes a lot of time to run. So let me just move on to Foothold. Yeah. So if I wanted to run Trivi, right, I can first thing that I'll need is an image, right? A Docker image. For now, I'll just use Nginx with the latest tag, right? This will just download the image from Docker Hub. And once I have the Docker image, or this could also be the image of whatever application that you are building. After that, you can use Trivi inside a Docker container only to actually scan your image and to just provide a table or a report of all the findings, all the vulnerabilities that it has found. Once this is downloaded, I'll just show you the command. I won't run it. I won't let it complete because it is a very time consuming process because Nginx has a lot of vulnerabilities. All right, so this is done. To run Trivi from a container, what we can do is docker run -rm means that once this has completed execution, it will delete the container. Yeah, from Aquasex Docker Hub, you can just run the latest Trivi image, and the severity flags the vulnerability that we want. So we are only looking for high and critical vulnerability. The format means that I want it in a human readable table, basically something that is easier to understand. And finally, you just mention the image that you want to scan. So if I just hit enter, this will first download Rivi, run a container, and start scanning my particular image. I again won't be doing this if this image or the base OS that's present inside this has any known vulnerabilities. Trivy will flag them out and will just display a table with all high and critical severity vulnerabilities. So now let's just stop this execution and move on to another lab that is quite common as well. So I have a GitHub repository, right, called leaky repo. It has a Python file called config.py, which contains some Python code, right? Now, this could, again, let's say my company had an intern. I asked that intern to just create this particular file, right? And that intern created this and gave it to me. Now, as a user, I just got this file and I was like, okay. But if there was an attacker, what they could do is they could view the logs as well, and they would see that, all right, some changes have been made to this particular file. Now, since this is a Python file, I would assume that these changes are just some code level changes. Maybe I just fixed some bugs to improvise my application, and that's about it. But if I were to find more information about it, right, if I were to verify what exactly was removed from it, then I would realize that, all right, this intern accidentally pushed sensitive credentials to my repository. And yeah, that is what was removed over here. And I would get access to sensitive keys. There was also recently a case that I read on news where a student had accidentally leaked their Copilot credentials on GitHub. Once they leaked it, they directly deleted it as well. But it wasn't completely gone because it was present in the history only. So they were planning on using the $300 credits that they get by default. But after a few months, after their summer break ended, they ended up getting a bill of $300,000 because the Copilot, I don't recollect the exact application. It was, I guess, Copilot only. Their Copilot access key was leaked, and someone managed to get it from the the logs of GitHub. So yeah, this just shows that in case something is there, you must also clear the history as well. Now this was done manually, and I only had 2 commits over here, right? For large repositories, we can also use tools like GitLeaks. So GitLeak will automatically detect any hard-coded credentials that are present over there. So GitLeaks detect. I'll just provide it a source repository. Since I'm already inside that repository, I can just type this, and I want it to be verbose. No. Yeah. So as you can see, it actually detected a secret. And I got my results. After finding the secret, if I just wanted to completely delete the secret from my repository, I could do that by using another tool that is present in Linux called git filter repo. Okay, so with this, I can filter out or remove all the credentials that are there inside that have been hard coded in my GitHub history, commit history. Or we can also do that manually and then rerun the git leaks command to just ensure that all the tokens or all the credentials have been deleted. Right, so yeah, that concludes my practical for foothold initial access. Moving on, when we talk about managed interfaces, right? So in our architecture diagram, we looked at 2 additional components that were Cloud Provider API and Cloud control plane, right? These are only present when we are using cloud services or managed Kubernetes services like Google Kubernetes Engine or EKS or AKS. Now, our control plane runs basically inside the cloud provider's infrastructure. So this obviously means that a lot of risks have been avoided or have been covered and is being managed by the cloud. But this again introduces new risks like API endpoints that are publicly reachable, or IAM roles, cloud roles that are overly privileged, or dashboards that are left out open to the internet. So during testing, we must also check that the control plane endpoint that are specific to these cloud providers are private, or even if they are available, they must have proper authentication in place so that no one is able to interact with our cloud clusters. So yeah, once we are inside a cluster or once an attacker is inside the cluster, the next step is to check if we can escalate our privileges or move laterally, right? So let's move on to privilege escalation vectors. So privilege escalation is basically something where if let's say I have limited access, and if I am trying to escalate my permissions, or if I'm trying to do something that I'm not intended to do or meant to do, that comes under privilege escalation. In Kubernetes, this could mean moving from a single pod to controlling the node or controlling the entire cluster. Now, this is one of the most important things to test, because once an attacker reaches cluster admin level, uh, let's say in the previous example, in the reconnaissance example, an attacker managed to get access to the service account which had cluster admin role bindings, then every other control that we had in place, it could be access controls or security policies, all of those would become irrelevant. uh, just like other just like in other cases, even in Kubernetes, privilege escalation have two forms: vertical, where we are moving up the hierarchy, and horizontal, where we are moving sideways into other namespaces or roles. The common paths that are mentioned over here are usually the first suspects for Kubernetes privilege escalation. This is the most obvious one: privileged containers. When you run a pod in a privileged mode, or with something known as host mounts, which means that it is mounted onto the node, that particular pod or that particular container can literally see and change things on the host or the node's file system. After that, we have cluster admin bindings. This is something we looked at during our reconnaissance lab. These are often left over from debugging or CI/CD steps. And if a service account is bound to this particular role, and if we get access to that particular service account, we can own the cluster. Then there's service account tokens abuse, where every pod gets a token by default, right? And if we are able to use it outside the pod, then this can often be used for privilege escalation. Finally, we have host path mounts and host PID namespaces, and these can allow direct access to the node, which is the underlying infrastructure on top of which our pods or containers are running. So yeah, let's look at this practically as well. There's another lab for this. We are on Prevesk. So I will create a lab with two namespaces. One namespace is hardened and one is permissive. Right. So what's the name of my all right. Mr. Admin. Okay, now this containers. Yeah, all right. So for our next lab, I will create a namespace. One is extremely restrictive and the other is slightly more permissive. So let me just create a pod first. There must be two configuration files, one for a namespace and one for pods. I'll just create the namespace first. So it created two namespace. One is restrictive, other is privileged. After that, I can just list them down. And yeah, they have been created. So the PSA that you see over here, PSA stands for Pod Security Admissions, and these letters label namespaces with policy levels or security levels. The restricted that you see over here or over here, the restricted that you see over here is the safest, and the privileged allows the most host level powers. So we'll try deploying the same pod in both the scenarios and see what is being allowed and what is being denied. So in our case, what we are doing is we're just trying to create a pod using the following configuration. And what we're doing is we are trying to run it with higher privileges than what is necessary. So the privilege has been set to true, and it is something that will allow privilege escalation. And I've also added few capabilities that will allow it to have access to the higher level of access on the underlying node. So if I apply this, this meant that the privileged pod was created. Right? If I look at the namespace that this is being deployed in, it is PSA privileged. Right? So if I view the pods inside my PSA privileged namespace, get pods -n, I have a privileged pod running. This isn't ideal. This is a bad practice. You must not allow, as much as possible, you must avoid allowing pods to run in privileged mode unless and until it is absolutely necessary for the functionality of your services. If we just change this now from PSA privileged, so I'll just change the namespace now. I was able to successfully run the privileged pod inside the enforcement level of privileged. If from privileged, PSA privilege, I choose make this restricted. Is it restricted? Yeah, it is restricted. And now if I try deploying this, I'll get an error that this particular action was forbidden. Why it was forbidden? It was forbidden because it violates the security control that we have provided, and that is restricted. So we are not, this particular pod requires certain privileges, access to the host or the node, and is asking to run in a privileged mode, and I cannot allow it because that is not within the scope of my particular policy. So that is why this particular case was forbidden. So just to sum everything up, PSA stands for PSA stands for Pod Security Admission, and it has basically two levels: privileged and restricted. Privileged means that it is more allowing, it allows more host level powers, and restricted means that it is more restrictive and it won't allow such actions to take place. Yeah, if I wanted to, if just to show you how dangerous the host level privilege is, I will actually show you one very simple demo. I have my privileged pod running in the privileged namespace, right? If I were to execute inside that pod, say villaged, this is spelling error, right? Who am I? I am the root, all right. If I at the view the contents of my root directory, I can see there's a special file called host etc. Host etc is basically the file of my underlying node. So I can view the contents that are there inside my node by ls host etc. This will show everything that's there on my node. This is the etc file present inside the node inside which this particular container is running. So this will essentially allow me to break out of the container and gain access to the entire underlying infrastructure. So yeah, this just shows that a privileged pod can break out of its container sandbox and can access or control the host system directly. If you can create pods in a namespace, this is one very important point. If you can create a pod inside a namespace, you can mount any secret that is there or that is part of that namespace into our pod. And we can also read it even if we don't have access to it. And this is unfortunately one of the known caveats in Kubernetes. So we must enforce proper policies to prevent such things from happening. We have another lab as well. Before that, I will just uh, clear out this lab. So kubectl delete -f pref pod. Deleted the namespaces. I now know why this isn't being deleted. I'll just The reason why my pref pod did not work, this particular command did not work, was because I had modified it earlier to deploy the pod inside the restricted namespace, and that was denied, obviously. So as technically no pod was created, and this is why it is telling us that you do not have any pods running using this particular configuration file. Now if I do the same, it should delete it. All right, since I deleted the namespace, it automatically deleted everything, it seems. Yeah. Okay, should be good. Let's move on to the next practical, which is understanding cluster admin role bindings. So I have another lab, right? I'll just create a lab to understand this, where we'll see that a low privilege service account cannot read cluster secrets. But if we actually bind the service account to a cluster admin role, like we had in the reconnaissance lab, with that, we are also able to read secrets and we are also able to perform persistence so that we have access to the cluster even after everything has been deleted or restarted or changed. So I created a secret, I created a namespace, and I created a service account. If I want to check if I'm able to use the service account to read the secrets, I can use another kubectl command called kubectl auth can I. So this lets us find out the permissions that we have, right? So if I use kubectl auth can I, and I'm using this particular flag as is equal to, and here I'm mentioning that, all right, can I perform this following operation if I have been logged in as this particular service account, which is this, right? So if I try to get the secrets, the kubectl cluster, the Kubernetes cluster replies back with no, I cannot do that. Just to get a clearer picture, I will just list down the secret hyphen the secret that's present inside this. Hmm. Kubectl okay, bindings demo get svc. Oh, all right, that is a service account, my bad. Secrets hyphen n, no resources found, get secret. All right, this is weird. Anyway, all right, we will it is actually there. For some reason, not able to view it right now. All right, so if I also try to list any other secret, I will get an error called forbidden. Now, if I were to bind this particular service account, which is this bindings demo, which is present inside this, for that I have another configuration called cluster admin YAML. What this does is it is a role, basically the cluster admin role that we saw earlier, and it binds this to a particular service account called viewer. So kubectl get there we go, we have it. I was actually trying to view the services and not the service account. So this particular service account, viewer service account, what I'm doing with this is I'll bind this particular role to it so that kubectl apply -f, and so that I am able to escalate its privilege. So now if I were to run the same command as above, where I use can I to understand if I'm able to get the secrets, the Kubernetes cluster will reply back with yes, that yes, you're able to list down the secrets. If I wanted to list down secrets of all right, I'll do one thing. I'll just list down the secret that is present inside that is present inside demo secrets. Forbidden. Interesting. All right, kubectl get secrets -a. There is a demo secret. If I had, okay, I am able to get secrets. As stem, I want to do this as service account called bindings demo. Inside the bindings demo namespace, there's a service account called viewer, and I want to get this secret is present inside which namespace? It is present inside kubec system. Get secret It seems our configuration wasn't wide enough. Anyway, uh, yeah, so what we can do with this is, my point is that if we have cluster admin rights, our our user, our service account will be able to read the secrets that are present inside the cluster. And usually this cluster admin right is used for backdoor and for maintaining persistence. So that if the pod dies or some things are restarted, we can get access to it as well. So for that, I'll just show you an example of a backdoor as well. What this configuration does is it creates a cluster admin role and it binds that to a service account called default, right? And this is bound to this particular namespace. So if this creates a cluster admin account as well, and the new account indeed has access to secrets as well. So even if the defenders or the blue team guys were to find my first account, my service account, and they were to remove the bindings from it, the default, the second account would still remain and would allow us to gain administrative privilege over the containers as well. So yeah, these are some quick and easy ways to test our privilege escalation inside the cluster. I will just delete whatever artifacts we have created. Deleted the backdoor. I deleted the cluster admin as well, privilege as well, and I will now remove the entire lab as well. So yeah, so what we do is once we have access to a cluster, we try to deploy a privileged pod. If the admission controller or the pod security admission blocks it, we are safe. If it runs successfully, then that is a red flag. And the container basically has access to the node's file system. We can also list cluster role bindings to see if anyone has been granted cluster admin permissions that they shouldn't have. And finally, we can use kubectl auth can to find information of whether we can do certain actions that require higher privilege. In this case, if we are able to list or get the secrets for all namespaces, and that just returns yes in our case, in case of a higher privileged user. Next, let's move on to lateral movement and persistence. So now that we've tested how an attacker might elevate privilege, the next step is to explore what they could access or extract. So this includes the post-compromise phase, where we usually have three goals. First is extract credentials. Second is move laterally to other parts of the cluster. And third is to establish persistence so that even if the first pod is deleted, we can still gain access over it. My bad. Yeah, so first, credentials. So Kubernetes stores sensitive data in secrets, but those secrets are just base64 encoded as we saw earlier, and they're not encrypted unless you enable encryption at rest. Apart from this, every pod also has a service account token that is automatically mounted at a particular location, which is this var run secrets, where run secrets kubernetes.io. And this particular path contains the token that are available for that particular pod. Now, if the RBAC that is configured on that particular cluster is too loose, these tokens might give admin level access. And even sometimes environment variables and cloud metadata endpoints in case of managed services, even those can sometimes be used or abused to leak credentials if they're not properly secured or configured. So we already saw this practically a few slides back. So we can also, one more thing, the cloud metadata can reveal sensitive data just by visiting the internal or the common IP that is uh, used for internal API calls. So in most cases, it is 169.254.169.254. One practical that we can see in this case is looking at how a pod's built-in token can access Kubernetes API with whatever permissions that pod's secure service account has. So if that pod service account has cluster admin access, it can access the Kubernetes API as cluster admin. And in case that token leaks, then the attacker also gets the same permission. So moving back to our terminal. Okay, so I have a lab as well to show you the impact of leaked pod tokens, right? Here we have a particular secret. This entire lab has a namespace, a secret as well. Let me just spin it up quickly so that we can look at how to do things practically. The things have, the configurations have been made. Let us just verify if all the pods, all the accounts are ready. Conditions have been met. What I have done is what I've instructed kubectl is to wait until a particular condition for a particular condition. So inside this particular token impact namespace, if all the pods, all the token pods are ready, then only you must complete your execution. But till then you need to wait, and I have set a timeout of 60 seconds so that after 60 seconds, if the token pods aren't in the ready state, it will just automatically exit. So if I again list down the pods in my namespace called token impact, I will see that, all right, there's a pod called token pod. Now I can use the internal token to hit the API and list secrets. To do that, I can use the kubectl command as again, where I'll tell it that, all right, there's a namespace called kubectl. Let me just show you how we would do it ideally. So my bad, get ns, right? There's a namespace called token impact. So kubectl -n inside the token impact namespace, there is a, I want you to execute inside a pod called token pod. And inside that, I want you to run the following command. So after the two hyphens, whatever I type over here will be executed inside this particular pod. So I will just list the secret from its location. So it is stored in var run secrets kubernetes.io service account and token. Now this is a JWT. This is a JSON web token, and this has been signed by the API server. What I can do using this is I can read the secrets by directly sending a call to the API server. So I'll just copy it, kubectl from this particular namespace. I want you to exec into this particular pod, and I want you to execute the following. So sh and just send a curl request with a particular header, and the header will contain this token for authorizing as this pod. So authorization will be bearer, just paste the token. I hope I did not change the token. And I'll just mention the Kubernetes API URL. So it is present inside Kubernetes default SPC. The API v1, I want to view information about the namespaces. Inside the namespaces, there must be a namespace called token impact, and I want to list down the secrets that are present in it. All right, there was indeed a mistake with my token. So what I'll do is I'll kubectl -n. I'm mentioning the namespace exec inside token pod. So run shell lc call and h with this particular header. Authorization bearer all right, I get the error. I forgot it to add another quote. Malform input to a URL function. Weird. All right, what I'll do is just give me a second. What I can do instead is I'll just re-get the token, the service account token. And let me just save it as a variable so that it is much easier for me to create the URL. So I got the token, right? After that, I'll just create a variable called token and save this thing inside it. Finally, what I'll do is use the token to read the secret. And yeah, secrets is forbidden, cannot list resource secrets in API groups. Token impact. All right. So it shows that it is forbidden. That is strange. Well, this is a good thing if the secrets are forbidden, or if we get this response, then that means that we have safely tested for that the configurations that are there in our particular in our cluster or in our namespace does not allow this particular pod to run in a privileged mode, and hence it cannot list down the secrets. Uh, we can also use kubectl get secrets -a to see what all things exist. And as we can see, there is a secret called db. Just to try it again. Hmm. Okay, it seems that I made a configuration that does not allow to do it. So after that, let me just clean this up quickly and let us move on to the next point, that is lateral movement. Now, once the credentials are stolen, the next step is lateral movement, right? We look for ways to reuse service accounts or we look for open network paths or kubelet APIs. Now, by default, pods can talk to any other pod unless we define a network policy. During testing or during simulation, we try and simulate this scenario by curling from one namespace to another. Now, if traffic flows freely, if a pod that is present in namespace A is able to communicate with another pod that is present in namespace B, then that means that there is no isolation and lateral movement has been made easy. To understand this, we have another lab inside this called cross namespace, right? This will basically create two namespaces and will deploy two pods inside those. Uh, there is a small web server and a client pod inside these namespaces. So I'll just apply this configuration. It created a namespace called server, which contains a web application pod. It created another namespace called client that creates another pod that can be used as a client. And it created a service called web that will allow us to communicate with this particular pod. Now, just to ensure that things are up and running, I can use the previous command where I wait until the pod inside this particular namespace is ready, and I'll just wait for 1.5 minutes. All right, it is ready. Same thing can be done for the client pod. Conditions have been met. Now, if I wanted to I wanted to test for cross namespace communication, what I could do is, let me just list the namespaces. I have a namespace called client and a namespace called server. Inside the client namespace, get pod. Let's see what pod I have. I have a pod called curl pod. Now, uh, let me just get the SVC as well, the service as well for the server namespace. Okay, there's a server service called web. Perfect. Now, if I wanted to test if there is a network policy in place or not, I could simply curl to the service that is running on another namespace using kubectl only. So there's a client pod inside the client namespace. So I'll use that. So I want to exec inside curl pod. I want to run a simple curl command and send a request to the server that is running in another namespace. So the name of this particular service is web, or the server that is running is web. So I'll just use web.server dot it is a service that is present inside the local cluster. And this should, yeah, this returns an output. This is the default Nginx page, and it just proves that from namespace A, I'm able to communicate with namespace B. So in our case, from the client namespace, I'm able to communicate with the server namespace. Now, if this is an intended functionality, then this is not an issue. But if this is something that's unintended, and then this could lead to privilege escalation or lateral movement and could even help with persistence. So to stop lateral movement, the first thing that we begin with is network isolation. Every namespace should begin with a default deny policy, default deny network policy, and only known flows or known traffic should be allowed explicitly, so that it minimizes the blast radius in case of a compromise. We should also block access to cloud metadata endpoints and consider another key component called service mesh with MTLS for end-to-end traffic encryption. So by default, in case you're wondering what MTLS is, by default, the traffic within a cluster is unencrypted. So if any communication that is happening within the components inside a cluster are happening in plain text using protocols like HTTP. Now, if an attacker got access to the to a pod inside a cluster, as an attacker, I could just sniff around and I would be able to view the communication in plain text. To prevent this, we have something known as MTLS, which basically encrypts the traffic that is happening within a cluster. So to clean the lab up, I can just use the same kubectl command and use my configuration file to delete the setup. Cool. So after that, we have persistence, which means staying in the cluster. This is about making sure that our access sticks around. When we want to perform this, we might deploy a cron job. By we, I mean attackers. We might deploy a cron job that respawns their pod every minute, or it modify a static pod on node, or sometimes we might even register a malicious admission controller that injects some sort of payload or sidecars into new pods that are created. So we can also test these paths safely by creating cron jobs and verifying the audit logs or whatever alert mechanisms we have in place to ensure that in case there is a mechanism that has been set up for persistence, we get alerted for it as soon as possible. Moving back to our terminal, seems things have been cleared. And yeah, so I'll create a namespace that allow cron jobs for a particular account using a special configuration file called cron setup. This is a namespace that is called jobs allowed, and basically there is a particular role. This can be thought of like an ACL RBAC, role-based access control. The name of this role is cron writer, and it is bound to this particular namespace called jobs allowed. What I'm doing is I'm providing these verbs. Verbs are action words, right? So whoever gets this role can create, they can get, they can list, or they can delete cron jobs, right? They can do all these things for a cron job inside this particular namespace. After that, I also created a role binding where I bound this particular role to a particular service. So yeah, let's just deploy this kubectl apply -f cron setup. So this has created our lab for us. Now I have also created a cron job as well. A cron job has been created using the cronjob.yaml file configuration file as well. What this does is it runs this every 30 seconds, and what it does is it just runs a date, whatever date it is, and it echoes this particular command, hello from cron. And yeah, if I just run this, let me just create this. Cron setup is up and running. Let me just verify if that is ready. Just to verify if the RBAC is working. Forbidden. Right. All right. The RBAC is working. Right. So cron job has also been created. All right. Now let us just look at the cron jobs. All right. There's a cron job that is running every minute. Okay. There's no jobs in pods. Weird. If I look kubectl delete -f. Let me just delete this for now. It seems there's some sort of authentication problem. There is a cron job. Suspend false. Active. Yep. There is a pod as well. It is completed. All right. And if I look at the jobs, aha, yeah, there you go. So as we can see, our pod is executing successfully. Ideally, this should be updated every 30 seconds. This was executed on this. So the next time we get a log, we should get this on 17:39 and 34 seconds. It is waiting to start. All right, it seems that it is being restarted. Yep, there you go. So every 30 seconds, not every 30 seconds, every minute, it runs this particular cron job that was present inside my configuration file, and it just mentions the date and hello from cron. This just proves that if in case there is a cron job that's running, or if there's anything that can be used as a persistence mechanism that's running, then our security implementations, our detection tools must be able to detect these and prevent these, or at least give us an alert so that we can take appropriate actions on it and prevent persistence for the bad guys. So yeah, this was a safe test that can be performed to to analyze our persistence mechanism, and this simply prints a message every minute. In hardened clusters and ideal scenarios, this should only be allowed in a specific namespace and should also trigger alerts in the audit logs. So the idea of this is to make sure that attackers can't use the same mechanism to persist silently. So that covers our attacking part. Let's move on to the final part of our topic, which is cluster hardening. Since we've explored how attackers can move inside and stay within a cluster, let's finish by learning how to harden Kubernetes that in a way that prevents all of this. So cluster hardening is not just about patching systems, it is about systematically securing the various levels or the various components that are present inside Kubernetes. This includes the control plane, the worker nodes, the workloads, or the runtime itself. You can think of hardening as moving from firefighting to prevention. So first, the key principles of cluster hardening are least privileges everywhere. You always follow the principle of least privilege in security. It is quite famous. Similarly, we have defense in depth, and after that, we also have continuous validation. So these are the three core principles that we follow while hardening our clusters. So first, let's talk about control plane and access hardening. So the control plane is our command center, and locking it down is or should be our number one priority. We must make sure that our API server isn't publicly exposed, and we must always rotate our TLS certificates and also disable any anonymous authentication on kubelets. For etcd, since it is a key store, it is a storage space where it stores key value, key keys and values. We must always enable encryption at rest so that in case it is compromised, hackers do not actually get the real contents out of it, because etcd is where our secrets actually live. And airbags should be configured. They should be used to follow the principle of least privilege, which means that we must only allow or only provide the privilege that is absolutely necessary for our application to be up and running smoothly. And again, as always, after that, cluster admins should uh, always be avoided unless it is absolutely necessary. After that, we have pod and workload security. So most of the attacks happen at the workload level. All right. So our PSA, which is the pod security admission, is the first line of defense. Now it enforces restricted modes so that no one can spin up a privileged pod or mount the host file system. After that, we enforce image trust as well, where only signed images are acceptable and tags such as latest are denied. The problem with the tags like these tags, where we just mentioned when we allow :latest tags, is that it provides a way to it like opens a door for new vulnerabilities to come in, which we might not be aware of. So it is considered a best practice to explicitly specify the version of whatever image that we are pulling instead of using the latest tag. After that, finally, we can also add runtime enforcement. So tools like Falco or SecComp watch our containers, watch what our containers actually do at the system call level, and it can be extremely useful for cases where some malware is being executed or there is a miner that is running within our system. After that, we can move on to the final part, which is network and data protection. For networking, we should think of zero trust, right? So do not trust anything that's inside the cluster. Pods shouldn't talk to each other unless it is absolutely necessary and it is explicitly allowed. There must be a default deny network policy so that pods inside different namespaces can't communicate with each other. And this is very similar to what we follow when configuring firewalls as well. Even with firewalls, we follow the principle of least privilege, and we apply a default deny policy. So after explicitly allowing certain type of traffic, all the rest is denied by default and it won't pass through the firewall. We can pair these policies, or we can pair these methods with something known as MTLS through a service mesh, so that even the traffic that is flowing within our cluster is encrypted, and it prevents man in the middle or sniffing attacks. And also, our secrets that are present inside etcd, all secrets in Kubernetes are only encoded, so we must always encrypt it as well, even at rest and even in motion. So yeah, to wrap things up, let's just quickly go through everything that we've explored so far. First, we started by understanding Kubernetes itself, what it is, why it exists, and why testing it is so critical and essential. Then we looked at the offensive side of Kubernetes testing. We went on from reconnaissance to initial access, gaining the initial foothold, to privilege escalation and some post exploitation or post compromise attacks. Finally, we shifted to the defensive side, where we looked at uh, how we can prevent such attacks from happening by adding security policies or following certain strategies at various levels of Kubernetes. Together, these give us a full circle view from how an attacker gets into a cluster and how defenders can uh, protect everything and lock everything down. And yeah, that concludes my presentation. Thank you all for listening, and have a nice day. Over to you, Vicerean.
Well, thank you for the presentation. You did, yeah, very great job to keeping it 2 hours, 1 hour and 48 minutes. So that's good. Yeah, and thank you, of course, for the presentation. I think it was very interesting that you showed most of it on the terminal. So real hands-on practice is always good. For the people who are watching, if you have any questions, please place them in the chat so we can answer them if you have any. And of course, one big applause for our speaker who did a 2-hour talk, which is very long. Yeah, I don't see any questions so far. Let's give them some couple of seconds more to, yeah, maybe type it. The next speaker will be the last one for today. Because of shifting some time slots, we are done earlier than planned. But the last talk will be about state of blockchain security. I still don't see any questions, so if you perhaps have any questions later tonight or tomorrow or whenever you are watching this talk later, you can always hit him up. You can find him on social media, you can find him in the Telegram group, you can find him in the Discord channel, so here the information is. So again, thank you for the talk, thank you for the presentation, and I see the people who are watching. I see you at the next talk.
Thank you, Vicerean. It's my pleasure. Have a nice day, guys. Bye bye.
Silent nights online, hackers on the prowl. Keep your passwords tight, don't let your systems howl. Encrypted files safe, two factors quite a gift. Without it you're a target, your data might just drift.
Firewalls, guard your precious slave.
Hackers try to sneak inside, but they can't ruin your day.
Firewalls, keep the threats away.
Clicking links without a thought is censorship. Ignore that sketchy mail, it's phishing in plain sight. Malware's creeping closer like snowflakes on a breeze. Scan your drives for safety and keep your holidays with ease. Silent nights online, hackers on the prowl. Keep your passwords tight, don't let your systems howl. Encrypted files safe, two factors quite a gift. Without it you're a target, your data might just drift.
Firewalls, firewalls, guard your precious slave.
Hackers try to sneak inside, but they can't ruin your day.
Firewalls, firewalls, keep the threats away.
Clicking links without a thought is Santa's big no way. Deck the halls with updates, patch your software right. Ignore that sketchy mail, it's phishing in plain sight. Malware's creeping closer like snowflakes on a breeze. Scan your drives for safety and keep your holidays with ease. Silent nights online, hackers on the prowl. Keep your passwords tight, don't let your systems howl. Encrypted files safe, two factors quite a gift. Without it you're a target, your data might just drift.
Firewalls, firewalls, guard your precious slave.
Hackers try to sneak inside, but they can't ruin your day.
Firewalls, firewalls, keep the threats away.
Clicking links without a thought is Santa's big no way. Deck the halls with updates, patch your software right. Ignore that sketchy mail, it's phishing in plain sight. Malware's creeping closer like snowflakes on a breeze. Scan your drives for safety and keep your holidays with ease. Silent nights online, hackers on the prowl. Keep your passwords tight, don't let your systems howl. Encrypted files safe, two factors quite a gift. Without it you're a target, your data might just drift.
Firewalls, firewalls, guard your precious slave.
Hackers try to sneak inside, but they can't ruin your day.
Firewalls, firewalls, keep the threats away.
without a thought is Santa's big no way. Deck the halls with updates, patch your software right, ignore that sketchy mail, it's phishing in plain sight. Malware's creeping closer like snowflakes on a breeze. Scan your drives for safety and keep your holidays with ease. Silent nights online, hackers on the prowl. Keep your passwords tight, don't let your systems howl. Encrypted files safe, two factors quite a gift. Without it you're a target, your data might just drift.
Firewalls, guard your precious slave.
Hackers try to sneak inside, but they can't ruin your day.
Firewalls, keep the threats away.
Clicking links without a thought is Santa's big no way. Deck the halls with updates, patch your software right, ignore that sketchy mail, it's phishing in plain sight. Malware's creeping closer like snowflakes on a breeze. Scan your drives for safety and keep your holidays with ease. Silent nights online, hackers on the prowl. Keep your passwords tight, don't let your systems howl. Encrypted files safe, two factors quite a gift. Without it you're a target, your data might just drift.
Firewalls, guard your precious slave.
Hackers try to sneak inside, but they can't ruin your day.
Firewalls, keep the threats away.
Clicking links without a thought is Santa's big no way. Deck the halls with updates, patch your software right, ignore that sketchy mail, it's phishing in plain sight. Malware's creeping closer like snowflakes on a breeze. Scan your drives for safety and keep your holidays with ease. Silent nights online, hackers on the prowl. Keep your passwords tight, don't let your systems howl. Encrypted files safe, two factors quite a gift. Without it you're a target, your data might just drift.
Firewalls, guard your precious slate.
Hackers try to sneak inside, but they can't ruin your day.
Firewalls, keep the threats away.
Clicking links without a thought is Santa's big no way. Deck the halls with updates, patch your software right. Ignore that sketchy mail, it's phishing in plain sight. Malware's creeping closer like snowflakes on a breeze. Scan your drives for safety and keep your holidays with ease. Silent nights online, hackers on the prowl. Keep your passwords tight, don't let your systems howl. Encrypted files safe, two factors quite a gift. Without it you're a target, your data might just drift.
Firewalls, guard your precious slate.
Hackers try to sneak inside, but they can't ruin your day.
Firewalls, keep the threats away.
Clicking links without a thought is Santa's big no way. Deck the halls with updates, patch your software right. Ignore that sketchy mail, it's phishing in plain sight. Malware's creeping closer like snowflakes on a breeze. Scan your drives for safety and keep your holidays with ease. Silent nights online, hackers on the prowl. Keep your passwords tight, don't let your systems howl. Encrypted files safe, two factors quite a gift. Without it you're a target, your data might just drift.
Firewalls, guard your precious slate.
Hackers try to sneak inside, but they can't ruin your day.
Firewalls, keep the threats away.
Clicking links without a thought is Santa's big no way. Deck the halls with updates, patch your software right. Ignore that sketchy mail, it's phishing in plain sight. Malware's creeping closer like snowflakes on a breeze. Scan your drives for safety and keep your holidays with ease. Silent nights online, hackers on the prowl. Keep your passwords tight, don't let your systems howl. Encrypted files safe, two factors
precious slay.
Hackers try to sneak inside, but they can't ruin your day.
Firewalls, keep the threats away.
Clicking links without a thought is Santa's big no way. Deck the halls with updates, patch your software right. Ignore that sketchy mail, it's phishing in plain sight. Malware's creeping closer like snowflakes on a breeze. Scan your drives for safety and keep your holidays with ease. Silent nights online, hackers on the prowl. Keep your passwords tight, don't let your systems howl. Encrypted files safe, two factors quite a gift. Without it you're a target, your data might just drift.
Firewalls, guard your precious slay.
Hackers try to sneak inside, but they can't ruin your day.
Firewalls, keep the threats away.
Clicking links without a thought is Santa's big no way. Deck the halls with updates, patch your software right. Ignore that sketchy mail.
Hey guys, welcome back. It's the final talk of today, which you will also see on the screen. It will be about blockchain security, the status of 2024 and 2025, with a critical overview, major incidents and emerging threats by Jakub. Yeah, I hope you all will enjoy this final and last talk of the day. So I will no longer hold you guys. I wish you a wonderful talk and have a great time. So here is the speaker.
Hello, my name is Jakub Godula, and today I wanted to talk a little bit about the status of blockchain security over the last couple of years, with main focus on the recent years. I've been doing cybersecurity for the last 4 years, mainly the blue team part, with a recent switch towards blockchain security, to be a bit more specific. And personally, I've been interested in cybersecurity subjects for nearly a decade now. So without further ado, let's just get straight into it. Unfortunately, in 2024, we had quite big losses when it comes to blockchain security incidents, which totaled over $2.5 billion. Most of it actually came from phishing, which isn't really that surprising when you're actually considering the overall trend in security. And quite a lot of targets were actually the decentralized finance platforms, with over 75 attacks in 2024. And access control misuse or lack of it, or just poor execution of it, accounted for nearly $1 billion in losses. If we'd like to compare it to 2025, we don't really have a full comparison yet because the year hasn't finished. But within half a year, we had over $3 billion in losses, which topped it quite quickly. And that's not really a good news if you're asking me. Major incidents that we had in 2024 involved Japanese trading platform DMM Bitcoin, which due to a phishing attack lost over $300 million. And unfortunately, it made that company go bankrupt before the end of 2024. Play the App was another big exploit of a gaming platform, which also brought significant losses. That one had exploited a vulnerable smart contract that were actually posted by the attackers on the blockchain. So it's slightly different type of attack. And then Wazir X was very similar in nature to phishing, although it wasn't just purely that. When it comes to 2025, we had two very big, or actually very loud attacks in media. First one would be Bybit attack that brought over $1 billion in losses, which makes it the most expensive attack in the history by far. And fortunately, in that attack, over 77% of the funds were actually recovered, which makes it slightly better, but still the losses were bigger than any losses in any singular attack from 2024, which, depending on the price of Bitcoin, would be around from $350 to $500 million. And another significant attack that we've seen this year was attack on Coinbase, where the attackers actually bribed the employees of the company in order to get the access to the funds of the users, and then actually used their access to perform those attacks. And at the end, they actually posted a hefty ransom from Coinbase, just to, with a promise that they don't release the data of their clients publicly, which Coinbase actually denied and didn't pay that ransom. Technically speaking, the most common attacks were private key compromises, with over 50% of total losses accounted to them. And needless to say, most of it happens due to phishing. So that's why it's second on the list. I believe that you all know that phishing is growing, especially with all of the deepfakes and AI writing the phishing emails, or helping the malicious agents write phishing that looks pretty much on par with the legitimate mails or websites. Next, we've got smart contract vulnerabilities. Those are logic errors, overflows, and other implementation errors, which would also include access control. And they are pretty much the same thing, although technically speaking, they are treated separately as a type of a vulnerability, because vulnerabilities that exploit smart contracts themselves are mostly targeting the exchange of value rather than just access control within the smart contract. And other two honorable mentions for that list would be sandwich attacks, which are actually exploiting the change of price with large volume orders. The main idea is that the attacker can actually buy or sell before your transaction actually gets finalized, and that's how they can get a few percent of the value that otherwise would have gone to you. And lastly, the very juicy threat vector is actually the bridges between the L1 networks. Two most well-known L1 blockchain L1 networks are Ethereum and Bitcoin. And the connection between them is, technically speaking, very prone to very multiple different types of attacks, and it doesn't it puts all of the users at risks, regardless of what exchange you're using, whether it's centralized or decentralized. Most of them have to depend on the bridges between those blockchains to a certain extent. So if you're using any of those cryptocurrencies that are under attack, you might be also vulnerable and get hit by those. So, like I mentioned before, AI is still getting a big portion of the attack vector, as well as the defense part in blockchain world. We can get some real-time anomaly detection and predictive threat analysis using those tools, meaning that some of the malicious activities can be caught up way sooner, and that might allow for freezing the transfer to the malicious actors. But like everything that involves AI, there's also a chance to have false positives or just some AI bias. So at the end of the day, it still has to be double checked by human and verified, right? We also have quite decent push from the European Union to implement the MiCA, which actually targets only the centralized exchanges or centralized entities, as it just fundamentally cannot enforce anything on the blockchain itself or any decentralized entity, as they are not under any of those European jurisdictions. But that centralized part of the exchange world can definitely feel a bit more secure due to those requirements. And yeah, cross-chain risks or bridges are still remaining very attractive targets, including in AI, including the use of AI, because plenty of those patterns just emerge over and over again. And since blockchain still is quite new technology, they might look vastly different when you compare the same type of vulnerability that is present between, let's say, Bitcoin and Ethereum, and then Cosmos and Ethereum. But they fundamentally work, let's say, the same way. And for the machine, it's somewhat easier to find those patterns than it is for humans. So that's another good news, that we might be able to leverage AI to secure bridges between L1 blockchains. Furthermore, DeFi and smart contracts are getting hit in a few different ways. Re-entrancy is a type of a call to the contract where the transaction is done at least twice. It might be done multiple times, including recursive calls, which can drain your wallet within a few seconds, depending on which blockchain are we talking about. If it's something fast as Solana, it might take just a few seconds to drain your entire wallet, even if the initial transaction was just for a few dollars. So those are quite dangerous. Flash loan oracle manipulations are quite quite advanced when it comes to the logic behind them, because it requires understanding the business logic of business/financial logic of the contract. For some, it's just pure maths, but for others, it's money that they can't even have in hand. So figuring out how loaning that can get your funds stolen is on somewhat another level for quite a few people, and also took me quite a while to understand how it could be leveraged. Although I'm still not a specialist in this particular type of attack, I know that they can be very devastating. And lastly, ice fishing. Again, fishing is very popular in the real cybersecurity world, tricking users into signing a contract that gives the attacker pretty much a full access to their seed, or the initial private key that is used to generate all signatures. Pretty much gives over the full control over the victim's wallet to the attacker. And well, needless to say, we can just lose not only the funds that we have on blockchain, but we can also lose our identity that way. Some projects on the blockchain currently allow for storing as sensitive data on the blockchain as the details of the passport or the ID cards. And once you lose access to that kind of wallet, you don't lose just the money, you also lose your real world identity at the same time. Going forward, we are looking forward to use zero knowledge proofs way more regularly across all blockchains that support it. Rather few of them support it natively, and those that don't do it natively often have some projects on top of them that aim to fill that gap. Zero knowledge proofs are a type of a contract or a certificate to say it in terms that are closer to some of my cybersecurity folks. It is a type of a certificate that allows you to prove that you are a owner of certain data without revealing the entirety of the data as a whole that you are proving something about. So, for example, I can prove that I have over 18 years of age with that kind of proof without revealing my other sensitive personal data from passport or my ID card. Multi-party computing is another fancy way of saying that sensitive computation can be done safely across distributed nodes, which is more or less the aim of blockchain as a whole. But MPC allows for sharing sensitive keys and other stuff that wasn't originally possible on Bitcoin or even original version of Ethereum. Another very big topic is quantum resistance. And well, some people say that quantum computers might be able to crack the security or the hashing algorithms of Bitcoin. And once that happens, the private keys of the wallets on Bitcoin can leak. And well, needless to say, that entire blockchain could theoretically go down because of this threat. And simply because blockchain is growing in use and threats, insurance is also something that is also a type of a service that grows quite rapidly on the blockchain. Having that said, there is a quite big difference between the type of hashing algorithm used on the blockchain, namely ECDSA is fundamentally vulnerable to Shor's algorithm, meaning that it cannot be secured from those types of attacks. But at the same time, it means that if such blockchain that uses this type of algorithm would like to get future-proofed, most of the times the only way is to migrate the wallet address onto the new type of wallet address, which is already possible on Ethereum. Not so much so on Bitcoin natively, but there are workarounds for it. Although the big issue with those blockchains are still the sleeping accounts or the accounts that were inactive for a very long time. And well, if an account was or is inactive on Bitcoin for, let's say, 8 or 7 years, whatever Bitcoins it has on it stored is worth millions, if not tens or hundreds of millions of dollars right now. So compromises of those accounts can be very devastating for the price of that currency in general. So migrating those accounts isn't really something that is possible, and backward compatibility is not really achievable with that kind of with ECDSA type of encryption. Fortunately for Bitcoin and Ethereum, we haven't really seen any of hard fork type of attacks lately. They were actually a few instances of those happening prior to 2024, mostly prior to 2024, and the trend is actually going downwards. Because those attacks most of the times require either a huge amount of processing power or huge amount of cash that can actually make you get in control of the entire blockchain. But like I said, Bitcoin and Ethereum haven't really experienced any of those for over the last 6 or 7 years, I'd like to say. There might have been a smaller instances of those type of attacks on those blockchains, actually not on them, but rather on the bridges between them. But again, it's something that is fundamentally difficult to secure. And going forward, we have a chance to actually secure the blockchains that are using EDDSA type of encryption to derive the public key from the seed. And those are, for example, Sui, Solana, Near and Aptos. And the difference between ECDSA and EDDSA is very subtle. It's pretty much just almost pretty much just a single additional step where the seed is used in EDDSA, and because of it, that seed can be used to deterministically derive a key that is secure from this ready for the post-quantum world, and we can generate a zero knowledge proof that can later secure all of the future transactions done with this particular wallet. And users can actually later just prove the ownership of the seed without revealing it, just like I explained before. This is just something that zero knowledge proofs allow for, and they're very interesting bit of technology in the crypto world. Fundamentally, they're actually quite similar to zero trust principle. They pretty much deploy all of the zero trust principles because only the user or only the wallet address that you allow to access certain data can do it, and they cannot really see anything else, like I said before. And And all of it means that using even an elliptic curve type of encryption, which is the EDDSA, which by itself is actually vulnerable to Shor's algorithm, we can generate keys that are quantum resilient. And that means that we can use a simple seamless migration for the users. The users don't really have to do anything on their part on those blockchains, unlike on Bitcoin and Ethereum, where wallet migration is necessary. If the blockchain uses that EDDSA type of encryption, the entire update can be done on the blockchain protocol level with just a simple update. And unlike on Ethereum or Bitcoin, the updates of those newer protocols like Solana or Sui are actually very, very well thought through, and they can be very frequent and pretty much seamless. On Bitcoin, they're extremely hard because they require convincing over half of miners to start using the new protocol, and then the others just have to adopt. On Ethereum, it's slightly easier, but still challenging, and it takes a lot of time. And the newer protocols are just built to be able to update very frequently if it's necessary. And those newer protocols also allow for no asset transfer, so the users don't have to worry about anything. They don't have to open up a new wallet, remember a new seed. They don't have to send any of their assets to those new wallets, and it even works for the accounts that were inactive. So, like I said before, quantum computers seems to be a big threat even for the accounts that were inactive for nearly a decade now, and suddenly having an access to 1,000 bitcoins can be very damaging for its price. It can make it drop very suddenly, and it is also backwards compatible with SLIP 0010 formatted wallets, which is just a definition of how those newer wallets are designed. And if you wanted to read a little bit more about the blockchain security, the how and why this encryption works, you can actually have a look at that paper that I've included here at the very bottom, which is post-quantum readiness in EDDSA chains. It's been posted quite earlier this year by the Myston team, which is a part of Myston Labs, which is a group that is responsible for maintaining and developing the Sui blockchain, which is also quite new. If you wanted to know a bit more about it, it's a blockchain designed by ex-Meta developers that wanted to create something that would compete with Solana in speed, but would provide way more security-related features. in its standard library, and I happen to be on the SWE hackathon right now. Thus, my internet connection issues might have been because people want to test their stuff quite often, or I just had to go to the place where I could easily present to you guys. Anyways, I wanted to mention a little bit more about SWE and what makes it different. By default, SWE allows for or actually implements zero knowledge proofs, so long as we want to compare it to Solana. And there are a couple of interesting projects that are built for that SWE ecosystem by the Mystikcon Labs teams. From a security standpoint, I believe that you guys might be very much so interested in SEAL, which is a project that tries to replicate PKI on blockchain, with the main difference being that it includes the identity of a user. So it means that rather than just signing anything with any key, the user has the data is actually secured with the identity of the user, which in turn allows for way more security, or is actually way closer to the zero trust principles that we love or hate, depending on which side you are. It might be a bit more challenging thing to implement than PKI, because it requires some newer elements, but still it allows for quite a lot of fancy stuff security-wise to be done with blockchain. And lastly, I'd like to mention Walrus, which is a storage service which allows you to host websites and other data for very low prices. I believe that if you searched up, you'd be actually quite surprised how cheap it can be to store data on SWE. Even if you consider storing terabytes for, let's say, a year or two, I leave it up to you to see how much it would cost you on SWE. And the combination of those two solutions means that you can actually have a solution that works similar to CASB-B, meaning that you can decide which user or which wallet identity can have access to certain blobs or bits of data living on Walrus. And it's all guaranteed by the blockchain to be verified and secured. Soon it's going to be secured even from the quantum attacks, which, if you're not aware, pretty much every single jurisdiction, like European Union, United States, most major technically advanced countries, so including Japan, Australia, South Korea, have made legislative efforts to force users and, first of all, companies to use only quantum resistant quantum resistive hashing or security algorithms, either by 2030 or 2035, depending on jurisdiction. So depending on where you live, it might vary, but most of the countries will have to start preparing their migration plans as soon as 2028, with some of the entities in the US already having to do it for the most critical parts. So long only the migration plan is required, but if the target is full migration of the most critical components of the infrastructure by 2030, then we all have to prepare for it at least 2 years in advance, right? We don't want to have or be stuck with a vulnerable encryption type way after it's actually meaningful, because it can actually bring a lot of damage. I tried to do it a bit faster than expected and skipped a few notes that I had, but I'm not gonna say everything on time. But that's it from me for today. Hope that you learned something and that I've got you interested in the topic.
Well, thank you for the talk. It was quite interesting to learn about all those implementations. Yeah, for the people who are watching, if you have any questions regarding what you have just shown, please place them in the chat. There's still time that we can go over them. And again, a big applause for the speaker for talking about this and sharing his knowledge with us. I don't see any questions so far, so let's give them some time. This was the last talk for Mystikcon 2025. There's just one more thing to do after this, but let's wait for that. If there are any questions so far, but I don't see any. So I think the presentation was clear and they all understood it. So again, I want to have a big applause for the speaker to share his knowledge with us and do this presentation. So thank you. We will go into a short break for 1 or 2 minutes, and then we will be back with the closing part, and we will wrap it up. So see you guys in 1 or 2 minutes.
Silent nights online, hackers on the prowl. Keep your passwords tight, don't let your systems howl. Encrypted files safe, 2 factors quite a gift. Without it you're a target, your data might just drift.
Firewalls, guard your precious slave.
Hackers try to sneak inside, but they can't ruin your day.
Firewalls, keep the threats away.
clicking links without a thought is Santa's big no way. Deck the halls with updates, patch your software right, ignore that sketchy mail, it's phishing in plain sight. Malware's creeping closer like snowflakes on a breeze. Scan your drives for safety and keep your holidays with ease.
Yes, there we are. There we are at the end of Mystikcon 2025. I want to thank you all for for being here, for watching many of the talks. I hope you all learned something. At least I learned some new cool things. And of course, if you are just tuning in right now at the end of the conference, don't worry, because all talks have been recorded. They will be uploaded one by one on the YouTube channel. So if you did forget one talk, don't be afraid. You can watch it back later. It will probably be around January that I will have time to cut them and make them and upload them to the channel because of the Christmas holidays and everything around it. But I want to mention two things before we go down offline. I want to thanks again to all the speakers who made this day possible, because they are the ones who made the presentation and they are the ones who were talking. It was not me who was talking the entire time. So yeah, again, big applause for the people who gave talks. And again, I want to also mention Mr. Robot, who's a member of Mystikcon for a long time. I think the first year when we started, he was already in the group, and he made the graphical designs, so the Twitch the template you see in the background, also the PowerPoint slides he made. So I want to have a big applause for him too. And then there's only one thing for me to say to finish this, and that's I wish you all a Merry Christmas and a Happy New Year in advance. And I hope to see you all in 2026, of course with your 10 fingers and 10 toes. And yeah, I hope to see you then in 2026. So again, thank you all for watching for this year. I hope you all enjoyed and learned something. And have a nice evening, morning, afternoon, and have a nice weekend. So bye bye everyone.